Проба. Добре. Радо. Това сега как да го намеря?
Аз ще го намеря спокойно.
Цъкни, там си.
То. Това имам малко само. Така.
Имаме технически проблем с маковете, които трябва да бъдат забранени със закон, но...
Трябва да започнем подобаващо все пак.
Тайна. Така. Здравейте! От нас започваме, още няма много хора, но сме с супер стрикна програма и няма как да протакваме много. Добре дошли на първата дейта конференция за ever, поне за която аз знам. Нямаме официален език на конференцията. Това е нещо, което е важно да се сподели. Тоест, някои лектори ще говорят на английски, някои лектори ще говорят на български. До някъде лектора преценя на какъв език да говори. Така че, ако вие не говорите на български, so if you are not speaking Bulgarian, and if the talk that you are super interested about is in Bulgarian, you can just ask the speaker, but it's up to the speaker to decide do he wants to speak in Bulgarian or in English. Okay. So we have several goals in this conference, which are
usually the main goal for us is to do it annually, meaning this is the first but not the last conference that we are going to organize regarding data and data stack softwares. We tried to invite the best speakers that we recognized. Most of them were too busy to join us, but I think maybe top-ranked speakers for Postgres really joined us today. And we also try to increase the networking. We will organize also Postgres community. Later I will speak about it. And Naiden, next slide.
So, for some reason, one of the slides is missing.
Not one,
super
many
absurd.
of them are missing, so...
I'm not entirely sure why. So, let's introduce ourselves, because for some reason, the slide for introduction of ourselves is missing. I don't know why. So, we are trying this conference for the first time this year, and we are actually 3 people. My name is Naiden Gochev. I'm not a data engineer. I'm an application developer. However, I have, 20 plus years. However, most of the applications today that are written, everyone is speaking. Domain-driven design, whatever, I don't know, is there any developers in the cloud? But I think it's mostly data-driven design. So we actually try to design the applications and everything with having data focus. Like, what are the biggest tables? How we should split the data, blah, blah, blah. How we should make the rest, so whatever. So I don't think we ever do domain-driven design. We are doing data-driven design, at least since 2005. And it's very strange that the data is super overshadowed. So the idea and why I'm here is because I believe that even for application developers, the data is important and the data engineering is important.
My name is Velichkova Danicharova. I am database engineer since 2016 maybe, so almost 10 years. And yeah, data is huge. Give me next slide, give me something.
Radu will have to introduce himself as well.
Yeah. Okay, my name is Radoslav. I have been with databases for 15 years already, maybe more. I fell in love, its first look love with the databases back in 2009 when I started working for one of the major companies here in Bulgaria by this time. And this love brings me to a lot of places worldwide, and I'll speak about me more deeply in the next presentation. So,
Yeah.
Yeah. So just to explain why data is huge, there is research by Global Admissions. So I'm sure that no one sees this. Even this, I think no one sees, but what you can see here is the first, which is the fastest growing jobs from this year in the next 5 years, is big data engineers or big data specialists. So it's not a big deal. But what you can see here is like the 6th place is the data warehousing specialist. Down there, there is a data analyst in data sciences, and also DevOps engineering, which is part of it is data. So what you can actually notice is that the application development, or maybe you don't notice it, but it's the 4th row. So we in Bulgaria are kind of used to having many application developer conferences and so on and so on. But in the next 5 years, the data will actually probably overshadow all of the programming languages and all of this.
So the data dream. The data dream here in this conference is to, how to say, unite all of the data user groups in Bulgaria, which includes data specialists as engineers and developers also. So the dream for the next events is to unite. That's all.
Yeah, so again, even more slides are missing. So the result is do not use Google Docs ever.
Ever.
But
don't do that.
The thing with the data is that there are, first of all, no real data events except this one. So there was an Oracle conference, probably some of you know, but it doesn't exist since 2019. There is a Postgres user group, but more or less they haven't done anything since 2019. There is a data event which is about Microsoft data stuff. Maybe some of you know there was this SQL Saturday, and SQL Saturday actually decided to be general, not for Microsoft, but then SQL Saturday became Data Saturday, so it's only for Microsoft. So the idea here is to have a conference that is for all about data. And this year we have only 2 tracks. This is the main track, and the deep dive is upstairs. However, the dream is maybe next year we will have an Oracle track, and maybe a Postgres track, and maybe a NoSQL track, or maybe we will have a
the community to grow.
caching track, and so on and so on. So the idea is not to be only about SQL, to be all about data, and to have an annual conference where you guys can actually meet colleagues, ex-colleagues, or future colleagues, or just some other people that have the same passion as you. Or maybe you will get a passion about some Databricks or a Snowflake or whatever that you haven't heard about before. We created Facebook group, which is called Data Engineers Bulgaria, sorry. You can scan this QR code and join the group in Facebook. The whole idea is you will receive a spam about our conference anyway on the email that you used for the registration today. But if you leave your company or if you change your email or whatever, we will post in this Facebook group any future events. And yeah, you can also find some people that probably have
And other events about data also,
and other events,
not just data stack.
Yeah, not organized by us, but in general, data stuff. Okay.
Yes, Naiden said we have 2 tracks today. The conference talks will be in this hall, Vitusha, and the deep dives will be on the next floor upstairs in hall Vihren. So what we prepared for the main track is 60% Postgres, of course, a lot of AI, and a lot of data movement. So you have the entire agenda in front of the door. I'm pretty sure that you cannot see anything from so far away, but you can check also your badges, scan them, and your agenda will be on the screen.
Yeah, or check the website where the agenda
Yeah.
is up to date. The main thing from this slide is that some talks doesn't have break between them. For example, 11 o'clock to 11:30, and the next one starts right after that. So I suggest if you participate on such talk, do not leave the room. I mean, there is no time for coffee. It's better to just, I don't know, when the speaker is saying something that is annoying, then take a coffee, not make a huge break all at the same time, because yeah, you will miss the introduction of the talk and not great. So as Radu said, the deep dive, we have only 4 deep dives. They might actually, some of them might finish earlier, but if you notice, they are around 60 and 90 minutes, which means if you go to a deep dive, you basically miss 2 or even 3 of the talks at the main hall. However, there is a streaming, which is available. So yeah, how to find it? In YouTube, if you search for Conf, probably you will find it. So both tracks are there. So even if you miss something, you can watch it later. You can watch it tomorrow at work instead of doing work. And we will also have the recording at some point, split, so you will not miss anything. I still believe that the deep dives is something that usually I'm more interested about, maybe because whatever, but you can, yeah.
More
you can,
technical stuff there.
Yeah, but you can decide what you think is better.
So, this is the place plan. You can see we are here. This is the main hall. We have 2 places that you can pick coffee. You can see it on the screen. Shout out to our sponsors. Their booths are right beside you. So go check them throughout the day, several times maybe, because everyone can share something interesting with you. And the chill and snacks area is here on your right side. Only one area is with snacks and chill, but the coffee and the water that is not listed here, you can, I think you probably saw them already. Yeah. And the registration, it's already done.
Yeah, the registration, if you haven't registered, the whole idea of registration is to participate at the raffle at the end.
Yeah, you can win something.
So it's better to go at the registration just so your name is scanned and you participate in the raffle. And maybe important is the toilets,
yeah,
or
the
WC.
I forgot, sorry.
At the end of these 2 corridors. So, yeah. The important bit here is Vihren. So Vihren is you have to take the stairs on the left side, and you will go to the 4 upstairs. The other deep dive room is above the sponsors. So it's actually the next level right above the sponsors. So once you go through the stairs, you will basically go on the next floor. You will be in front of Vihren. There are entrances from the side as well. There is also a toilet if someone wants to, I don't know, use the other toilet. So big shout out for our amazing sponsors, which are Platinum sponsors Entity Data, Storpu, and Linky.co, and our gold sponsors, SAP, Redis, Royalty, Postgres, and Contiant. If you are employed by other companies that are not a sponsor, please help us to get them as a sponsor for next year. Because basically, by having more sponsors means we will have more stuff. Means we will probably have a t-shirt for everyone, which this year we just didn't have budget for. Or probably we will have, I don't know, better snacks or
we will do better
or more of everything. So it's very important, actually also for me, to work for a company that is supporting the community. So if you work for a company that is not supporting the community, that's not great. It's fine for this. We are doing this conference for first year. Most companies have a budget. The budget is confirmed up front, but for the next year, we will have the same conference. So everyone should be aware. So as Radu said, we are planning to do PG Day as well. So join the group. You will receive probably email about it. So
Actually, the first event we are planning to do is next year in the spring or in the summer. We are trying to engage a lot of people that are already engaged with Postgres and they like to join the community, but feel free to register on the website. I'll send later the QR code for it and you can join as well.
Yeah, so summer or spring next year in Sofia, or maybe somewhere in Borovets, Bansku, maybe we will have a weekend to do the PG day with a lot of drinks. Yeah, so now is the time our platinum sponsors can say a few words. Entity Data, I'm not sure if they have a representative. If they don't, I can share that they were actually the first platinum sponsor that we got, and we were super happy when they joined because, yeah, maybe next year if we have another platinum sponsor, we will even have a beer at the event. But
Thank you to Entity Data.
yeah, huge thanks to Entity Data.
Yeah.
The next sponsor is platinum sponsor is Torpu, and they have a representative here that will say a few words in Bulgarian or English, whatever you prefer.
Ще го кажа на български, че реал-тайм превода в главата ми е по-бавен. Смело на български, да. Да, ние сме с Torpu, занимаваме се с Storage, там където живеят данните на вашите бази данни. Няма да говоря за продукта, ние сме там, елате ще разкажем, но за нас като българска софтуерна компания е голямо удоволствие да подкрепяме такива събития, за да можем да се видим, да се поговорим, да се посмеем и знаем, че всяко начало е трудно, така че от мен молба, много аплодисменти за организаторите, защото това е много работа.
Thank you so much.
Thank you. And yeah, and the other company the last company that's platinum sponsor is Linky.co. They will say a few words, but if you don't know, they do some cars, and which you can drive, real cars, not for kids. So.
Здравейте, дами и господа, участници в днешната конференция. Нека и аз ви приветствам от името на Linky.co, от името на New East, официален дилър на марката за България, от името на нашите партньори, официалните вносители на марката Max Mobility. Тук сме, за да направим още по-вълнуващ деня ви. Благодарим на организаторите за поканата. Смятаме, че нашите автомобили са изключително интересни, високотехнологични, качествени и може да им се насладите по време на целия ден на конференцията. Заповядайте, нашия щанд е непосредствено пред вратата на залата. Благодаря ви и хубав ден. Благодаря на организаторите.
Да, бих добавил, предоставят ни Linky всъщност тест драйв на 3 автомобила. Може да минете през тяхния щанд, да се регистрирате. Според мен, между другото, готино изглеждат количките, под 100 каса, така че в нормален ценови диапазон. Малко приличаш на Kia, ама както се пееше в една песен, аз съм Мазаряти и на Уралта в Kia, ама вече Kia-та изглежда добре, не като едно време. Да, всъщност много приятно изглежда, особено големия автомобил, мен много ми хареса на Linky.co. Даже аз съм се регистрирал, но не знам дали ще успея да направя тест драйв. Така, да се фокусираме върху конференцията. По принцип за опенинга, това ни е идеята на опенинга. Ако имате нужда от някаква помощ на регистрация и информация, ще има хора през цялото време, през целия ден. Приветствам ви да си оставите якита и някакви други неща, които ви пречат. Имаме гардероб. Ще има човек на гардероба цял ден до края на конференцията, така че няма нужда да го размотавате, да се размотавате наляво надясно. И надявам се да ви хареса евента, надявам се да се получи як, надявам се всички лектори да дойдат наистина И да
Интересната част е първа започва.
Да,
Скучната част с нас мина и с фейл, презентацията и така нататък. Ма докато се съберете, може.
Слава Богу, Радо
Да.
за другите си презентации не е ползвал Google Docs, между другото.
Да.
Специално видях.
По-добре ще е.
Така че не напускайте, тъй като директно превключваме всъщност към
Да,
презентацията
оставаме в
на
ръцете
Радо.
на Радо и първата лекция за деня. Благодарим.
Така, честа да съм първи се падна на мене. Найден каза, че съм най-грозен и трябва да ви събудя. До година ще опитам да докараме Поршета за тест драйв. Специално за колеги. Това е наша вътрешна закачка. Така, моята встъпителна презентация ще бъде насочена по-скоро към обобщение на рисковете, които имаме и които аз съм се запознал с моя стаж като дейтабейс админ за вече 15 години. Както казах, запознанството ми с базите данни беше любов от пръв поглед и в последствие това нещо ме преведе през почти половината свят. Работил съм в компании, които просто няма как дори да им кажа името на някой от тях. Такова е естеството на бизнеса. Минал съм през банкови институции, през атомни централи, правителствени агенции, производители на автомобили и здравната каса на Великобритания. Така изглежда картата с държавите, в които съм работил като дейтабейс администратор. И в момента мисля, че това е пика на моята кариера. Чувствам се много добре в компанията, в която работя. В SAP работим с най-сексапилната технология PostgreSQL, според мен. И лично за моя екип тази година онбордваме и Redis като технология. Така че благодаря на колегите, които ми позволиха последните няколко седмици така доста по-спокойно да се подготвим за ивента днеска. На екрана е чат съобщение от Messenger, което няма данни. Защо изглежда така? Защото просто без данни нашите приложения не струват абсолютно нищо. Те са изработени, за да могат да помагат на хората, които ги ползват, а за целта те имат нужда от храна. Тяхната храна са всъщност данните. Всеки може да си позволи да загуби кода си, но няма компания в света, която да си позволи да загуби данните. Защото това означава в повечето случаи дори директен фалит за нея. Както знаем, в последните години имахме дори няколко cyber security атаки с пробиви на данни, имаме регулации, които означават, че при такъв пробив компанията плаща сериозни пеналтита на държавата и на потребителите си. Съответно, наистина данните са златото, което ние съхраняваме в нашите приложения. Сега тук исках да извадя една снимка от банковия ми акаунт без данни, как изглежда, защото на няколко пъти ми се случи тук последните 2-3 месеца, но щеше да е политически некоректно. Къде живеят нашите данни? Живеят в така наречените софтуери за управление на бази данни на български или RDBMS Softwares. Всичките наши приложения, всъщност вече има и нерелационни, те са по-модерните и трендинг. Всичките наши приложения, искат или не искат, ще трябва да ползват такъв софтуер, за да се свързват с информацията, която потребяват. Както казах, конференцията има доста PostgreSQL. Причината е, че през последните 5 години това е технологията, която е най-търсена от нашите девелопери за стартиране на нови проекти. 55%, над 55% от девелоперите, според сървея, който е в Stack Overflow, предпочитат да стартират разработките си с PostgreSQL. И както виждате, open source софтуерите са в топ 3. Скъпите решения, Enterprise, ние знаем, аз съм работил над 12 години с Oracle. Скъпите решения си имат техните предимства, но все повече девелоперите и компаниите предпочитат да ползват open source solution. И така изглежда цената на свободата. Когато ползваме open source софтуер, както Postgres, ние плащаме само за инфраструктурата да го потребяваме. Ние не плащаме за никакви лицензии. Да. Така, слайдовете ми бяха приготвени за 15 минути. Трябва да ги завърша за 5, затова ще прескоча много бързо през следващите. Няма да влизам в детайли за PostgreSQL, но това е Game Changer от тази година. Мисля, че с тази стъпка PostgreSQL Development група ще разбърка доста плановете на гигантите, защото това означава поне по 2 по-добър перформанс и поне 80% по-ниски рискове за outage. По-нататък ще разясним и защо. Има един много интересен слайд. Добавил съм го, защото основният риск за базите ни данни, когато те не са копирани или не са съхранявани като backup архиви. Невъзможността да възстановим база с данни, която ни е в продъкшн среда, означава отново фалит за компанията ни. И добавил съм слайда, защото тук наскоро, преди няколко години, ми се случи да участвам в един сценарий за рекавари на цялата девелопмент среда на една голяма организация, която беше изтрита и нямаше бекъпи за възстановяване. Ако ме питате как се е случило, ще ви кажа отделно. Но ги възстановихме в рамките на 3 дена, 110 бази рекавърнахме, без те да бъдат бекъпвани. Също огромен риск е очакванията спрямо реалността. Повечето компании се опитват да мигрират към клауд среди от on-prem, опитват се да мигрират към open source софтуери от добре изпитаните платени солюшени, но не припознават рисковете, когато го правят. Всяко нещо си има позитиви и негативи и Postgres също, въпреки че е един от най-секси софтуерите за релационни бази данни, си има собствените си рискове. И най-големия риск е Transaction ID Wraparound. Така нареченият Silent Killer на нашата база с данни. Защо? Защото все още, дори с версия 18, софтуерът ползва Core Engine, който е разработен 86-та година и има 4 милиарда топ hard coded limit от 4 милиарда Transaction ID-та. Какво се случва, когато ричнем половината от тях? Рискуваме да загубим данни и всъщност, за да превентне тази ситуация, PostgreSQL Engine спира вашата база. Много често в дневната ми работа се случва да откривам девелопери, които изобщо не са запознати с този риск, разработват приложения с огромни обеми от локове, рискуват не само загуба на данни, но и outage, знаем, че в продуктивни системи това е критично да се случва, почти недопустимо. Естествено, за всяка болка си има хапче и за Transaction ID Wraparound хапчето е добър мониторинг и бързи екшени. Engine има собствената си функционалност, която е разработена специално за да противодейства на този проблем. така наречените вакууминг процеси, автоматични, ръчни. Но за да бъдем 100% сигурни, че няма да изпаднем в критична ситуация, нашите среди трябва да бъдат много добре мониторирани, следени с правилните метрики и с естествено подходящата сигнализация към екипите, за да могат да се включат на време. Естествено, за да може да бъде по-плавен прехода от риска към солюшъна, следващата сесия е подготвена точно в тази насока. Павло, който е от Украйна, в момента мисля, че е локиран в Чехия или в Полша, не бях точно, не съм запомнил точно, но Павло е един от топ презентаторите и всъщност стои зад проект, който доста добре се е справил с изграждането на мониторинг за PostgreSQL. Мисля, че ще е интересна тази негова лекция и ви оставям точно 2-3 минути, 4 за почивка и му давам сцената. Благодаря ви.
And
You have Pavel or Pavel?
yeah, we do have.
Same, but check, check.
So everyone, this is Pavo. He will start with his lecture. Go on, Pavo.
Okay, thanks a lot. So, zdrasti, or should I say zdravейте, if it was good enough. So, okay, so my name is Pavlo. I'm working for Cybertech. My official title is senior something consultant developer, but I'm doing a lot of things, like I'm a significant contributor to Postgres. This is the level of contribution. We have major, we have significant, and we want to introduce even more. I do like talks, I do community advocating and support and everything. So those are just like small part of our database tools. Some of those are under my maintaining. We are like distributed company. As you can see, we still don't have the office in Bulgaria, but I hope we will fix it somehow. Okay, so agenda. Today we want to speak about like different ways to monitor your database, right? So this is a full-time talk scheduled for 45 minutes, but we only have 30 minutes slot. So if I won't have time for live demo, please, and you will be interested, we have a booth for Postgres there, and I will have my laptop, and I can show you everything without hurry. You can ask questions, touch things, and anything else. So, okay, let's go for it. So, first question, why to monitor? Silly question, right? So, first of all, it's money. For me, I mean, not for me, but for me as an engineer, it's always money. How much do we spend on that, on that, on that? And especially in the time of cloud providers, you can have like 1,000 bill like for nothing. You want to know where your money goes. And of course, you want to be effective, you want to know your performance, blah, 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 but first of all, money, right? So if we will like try to understand what are the different ways to monitor the database, I would say we can split it into the levels. So the high level, then we want to see what's going on in our system, operating system or cloud or whatever, and then we want to know details inside our database. So for high-level service availability, I mean, yeah, it's silly, right? Who want this? I mean, just to know if our database is running, but that's like a common case. For example, in some Docker environments or if you're an application developer, you just want to know if the database is up and healthy, right? You don't care how many shared buffers or what is going on there. No, from the application point of view, I want to know that my database is accepting connection. If we are speaking about system monitoring, we need to understand what exactly we are trying to measure, what all the CPU, memory, and all other metrics mean to you. If you are running under hypervisor, or if you're running in cloud, or if you're running on the bare metal, you want to know what those metrics mean to you, to your database. And for Postgres specific monitoring, we can split this into three parts. First of all is a log. Then we have a special facility inside the Postgres called statistics collector, and we have a lot of different extensions that might help you to see even broader picture of what's going on. Many people that come from other databases or they just start their career, they're just like, okay, 21st century logs, really? Well, we have open telemetry, Prometheus, and all these fancy words. But the thing is that everything that happens in Postgres always go to logs, everything. Whatever happens, you might miss it in some monitoring system. You might miss it somewhere. For example, crash. You cannot handle, like, you can't have the metric for crash outside of database, but you will see it in the logs. The reason, when, why, who to blame, right? And of course, we have like dozens of scripts and systems for the active like parsing. So first of all, we want to keep those logs for later analysis. Maybe we have some AI chat, right? That's go through our logs and say, oh, we need to tune this and tune that. But usually we have like some kind of grep plus something. For example, the new thing here is PG Weasel, which is like implemented less than a year ago. It was presented during the PG Conf Europe. Just try it if you want. Of course, we need to specify what exactly go to our logs. In Postgres 18, the latest version, we have 44 different parameters of how we can configure logging. What, when, minimal durations, the format, do we want it CSV, or do we want it in JSON, or do we want to have only errors, or do we want to have debugs, and so on and so on and so on. There are a lot of happening. So sometimes for investigation, you may increase some parameters, right, verbosity, and then for production, you may want to decrease those. Another gorgeous thing in a Postgres is a special part, is a machinery called statistics collector. The statistics collector is responsible for gathering all possible information in this system and provide it to you in views or tables. So you just can type select something from PG start activity, for example, and you will have like the list of currently working session, right? So, and we have like the division into two parts, so-called dynamic views and cumulative views. Dynamic views show you what is going on right now. It's just like temperature, pressure, right? I need to know what's going on, where to look at. And cumulative views, they're accumulating the statistics all over the time, and you can see how the metric changed all over the time. And that might be really surprising. So when you come to someone and you want to investigate what's going on, the first thing you probably want to do is to reset statistics, then run workflows like for a day, 2, 3, week, and only then analyze the metrics you have. Otherwise, your data will be like polluted with random like numbers, and you don't know what to do with those. Extensions. So Postgres is famous for its extensions. The must-have extension that we always turn on in any like system, production, whatever, this is PG start statements. It's easy, lightweight. It allows you to see a lot of things, that happens with your queries. And on base of the PG start statements, there is a PG start monitor extension implemented by Percona, which gives you even more. And I forgot to put it here because the new extension arrived like last week. It was presented on the European conference, PG stat plans. So you can see different plans for the same queries and why they changed and what happened. PG stat tuple will let you see inside your rows, are they bloated or not. Like auto-explain is good to see the plans for some of your queries, so you can specify the threshold after which auto-explain will produce output. So you will not pollute your like production database with a lot of explain plans. But for example, for 10% like longer than 200 milliseconds, I want to see what plan is, why, what happened, right? And then you can address these slow queries without touching anything else. Okay, so in real life, what do we have in real life? Life is hard, and every company has like their own implementation of monitoring. Usually, they all do log collection and parsing in some way. Usually, they all do like collection of the PG stat data, and then they do something with it. And alerting and trends, it's not a part. I think that alerting is not part of monitoring. Monitoring is to see what's going on, to save this for later analysis. Alerting is to react immediately, right? So nowadays, usually people use Prometheus alerting system, so it works well for them. And monitoring tools in the Postgres Postgres universe. So we have a lot of them. This slide was like trying to list most commonly used, but then I decided to replace it with just like the link to the wiki, because we have like 30 plus, and then they're constantly changing, and I mean, you will see if you will check this. If we will speak about real-time monitoring versus the okay, so real-time monitoring is when you want to see what's going on immediately, right, in your system, and you want to understand, are we fine or something is bad going on? So someone like run, I don't know, the import during the working hours, and we are like, I don't know, are out of CPU or disk or what. So for that thing, we have like a lot of open source real-time tool enabled, like pgactive, pgcenter, pgtop, pgadmin 4 is the GUI, the Beaver is another GUI made not by the Postgres community, but made by for different databases. So for example, this is how pgactivity looks like. Can you see it? So it's now on pause. If I will hold it from the pause, so, and let's start some things. Okay, so you can see that on the top, we have like the main information about our instance, the name, the version, how long it's up, the cache hits, and all these things, like how many workers and all these things. Then we have like the main screen divided into tabs. On the first one, we can see the real-time queries as they are happening. On the second one, we can see the waiting queries if they are locked. Waiting queries. And then on the third one, we can see like the queries that are blocked. That's sometimes we want to, release the blocked queries. Okay, we can see the PID, like, psst, let's go and kill the guy. Okay, pgadmin 4 has like, I would say poor support for like real-time monitoring, only 5 dashboards. But I mean, for the beginning level, it's okay. So you can see like major things there. The Beaver pretty much the same on the 3, but you can add your own dashboards. I never tried it, but should work. If we are speaking about continuous monitoring, that means you are collecting your data and then later you get back to it to analyze what was the reason and how to work with it. In this field, we have commercial and open source different applications, like all of them are mostly agent-based. That means that something is gonna running beside your Postgres instance and will send the data to the guy, right? And of course, like support for generic open sources, open source frameworks also there. Most of them based on the check Postgres. This is like the old famous script that produces the data and send it to the frameworks. Oops, sorry. So if we are speaking about Postgres specific monitoring tool, I can say about the pghero, the POA. So, and they are authors of several cool low-level extensions like pgqualstats, pgstat and weight sampling, pgclue. Oh, sometimes it's hard to pronounce those, pgstatwiz, pgwatch, that I will talk about a bit later. So pgwatch, I told you that we have like 30 plus different systems. Why do we need another like one? Why do we need another pgwatch for that purpose? So first of all, I want to thank you, my former colleague, Karl Moppel. He is the author of PG Watch version 2. If you want to ask what happened to PG Watch version 1, nobody knows. Probably that was kind of, Python script written in the basement by some wizard. Nobody saw this. We only know that there is a PG Watch version 2, and that's how we count our history. So the main principles about the tool. So it's supposed to be an external tool. You can run it with binary, or you want to run it with a Docker, right? Immediately, just pull and run. You want to change your dashboards. Someone needs one information, someone needs another information. Someone has this kind of thresholds, other has another completely thresholds, or I'm just interested in absolutely different workflows or whatnot. So you need to have the ability to change the dashboards. It should be non-invasive. So we are running somewhere in a cloud, somewhere in a basement. We don't know where our server is. The only thing you have is the connection string. But we need to have the ability to connect to it and to fetch as much data as possible. And even though you have no root access, or not root, but super user access, right? We need to have the ability to suck as much as possible without those special extensions. And if you know your database, if you know your workload, probably you know what exactly metrics, specific metrics, you want to have. That's how we want to add the ability for you to create your own metrics. And if we are speaking about architecture, it's simple. It's just a Golang binary. We can provide configuration via Postgres, environment variables, YAML, whatnot. Then we have the concept of measurement sync. Sync is where our measurements go. So we are a database company, so we want Postgres first of all, right? Then, of course, Prometheus, it's standard de facto nowadays. Sometimes you want local file, especially nowadays when we have the access to all these beautiful AI agents that will replace all of us in a week or month, right? And we know that sometimes people want to have these, pretty interesting ideas how to use the data. So we want to have the ability to provide you with the RPC, which means that you can write your own binary that will be connected to the main PG Watch and will send you the data, and you will do with it whatever you want. Alerting, archiving, what else? Sending somewhere else, make your ideas. Yeah, and we have optional web UI for administration, and we use Grafana for the dashboarding. So this is the architecture. So the PG Watch is the small cube inside, in the middle of the photo, right? And as you can see, only one instance of PG Watch is designed to handle hundreds of instances, not databases, instances. So you connect them to whatever you have. The only limitation is the monitored sources must speak Postgres dialect. That means that we easily can monitor CockroachDB if only we know what to monitor, because they have their own implementation. But all flavors of clouds, all flavors of Postgres, TimescaleDB, Citus, I don't know, just imagine what you have else. Everything works out of the box. When you have your measurements sucked, you want to send them somewhere. That's where the concept of sync comes, right? So you want to save it to database to analyze later, or you want to send it to Prometheus for your alerting, or you want to have a local JSON files for archiving, and so on and so on. And later, on top of this Prometheus or Postgres measurements database, you can build Grafana dashboards that will later your management or your DBAs or your developers, so depending on what dashboards you have or you provide, you can split the the access for different layers of the or departments. So yeah, features like we support all of the PG stat collectors. So every major version we update our set of metrics. So you may be sure that after each major upgrade, all new features will be there. Nowadays we support Postgres 11 and higher, but for you to remember, the latest supported officially Postgres version is 13, right? And it will be discontinued next September. Okay, so what else? We can set up the auto discovery, nice feature. For example, you have a database where you create, or your clients create new databases sometimes, right? You don't want to track all the new or deleted databases every hour, right? So you can say the mode auto discovery. So the PG Watch, when it collects the database and when it fetches the metrics, it will check for the new database objects on the instance, and if new databases are found, it will automatically add those under the monitoring. So you don't need to do anything like new databases arrived, it's already in monitoring, right? Beside of the Postgres metric, out of the box we support PG Bouncer and PG Ball, PG Pool pullers. Also we have support for Patroni. So for example, if you are running your Patronic HA cluster, right? And you have like dynamic structure in it, you can say, okay, so please follow the architecture of this structure and then add under monitoring the nodes depending on their roles, right? So if we want to apply full monitoring to the primary node, we probably are okay to have a minimal monitoring to the replica. We don't want to stress it so much. And if failover happens, or switchover, PGWatch can handle this situation. Okay, so now you are the primary. Okay, so now I will ask the full set of metrics from you, and you are chill, right? Yeah, so alerting, as I said, so nowadays Grafana is one way to go. I don't like it because like it's kind of it's not the purpose of the Grafana to send alerts. But I mean, yeah, so Prometheus is usually a way to go for alerting nowadays. I never saw something else unless you have your own written scripts or systems. Another one is a PG timetable. I'm a maintainer of PG timetable as well. So with this one, you can just access the database, check the measurements, apply your logic, and send alerts like in emails, Slack, whatever. Among other things, so very cool thing we found with the timescale DB and the Citus as well. So any forks of Postgres that provide you with the compression are very good to use for measurement databases. So for example, if we take 6 databases under monitoring for 3 months, it will produce 45 million rows. And if we use like the vanilla Postgres, it will take 70 gigs for 3 months. But do not be scared. I mean, the automatic retention period is 2 weeks. So we just stress the system and see what's going on. So if we use like timescale DB with a compression, so the ratio is 9. So we can compress from 70 to 8 gigabytes. And right now we are working on the feature where we can even increase the compression just in case if you want to keep your data for a longer period of time. Another cool thing is the parallel syncs. So if you want to have like the best of the world, if you want, for example, you may send your measurements to the Postgres, right? Or for alerting purposes, you want to say the same measurements to Prometheus, or for the same purposes you want to, or for the same reason you want to save to local files to look at it later, or you have different set of metrics. One is for management, another for DBAs, right? You can have those. So one is going to one instance, another goes to another. And Docker images. So as I said, the first idea was we need to have a Docker image. So when I come to a client, I don't have a USB stick with me, like compiling everything. I just say, okay, this is the connection string. Let's suck the image. Let's start it, and we will see. So we have two Docker images. One is pgwatch demo, which is the big one, because you have everything there packed. So you have Postgres, pgwatch, Prometheus, Grafana, everything in one package for you, so you just can run it and see, to touch it, how it goes, what's going on inside, right? And we have a special image for production, pgwatch only. It's only 44 megabytes, easy. In this case, you are responsible to have your own storage, you're responsible to have your own Grafana, which is usually you do if you're working in the tech company, right? So it's easy to start. Like if you want to see how it looks like, you start the pgwatch demo, and you can see what's going on. Or you can go to demo.pgwatch.com, and this is how it should like. So we have 2 minutes left. I will show you some dashboards, and later you can come and I will show you more. So this is one that most people love the most. I call it all green, right? So we have a lot of metrics. You set your own thresholds, and you want to be sure it's usually somewhere in the corner on the big screen, and you're just like sipping your coffee. I'm fine, all green, right? The next one is when we start to see what's going on instance. This is the first level called global database overview. On this level, we can see what's going on instance level for all databases, right? For resource consumption and all other things. If we want to go even deeper, we have a database overview. Here you can choose for which database we want to see what's happening, right? So here's the monitor source. We can test it, we can change it, and we can see, okay, so this database is having these issues and these issues and whatnot. Of course, after that, the question comes, what is with our performance? And for performance, queries are responsible things. So we have a special dashboard where on top you have a list of top 20, in this case, top 20 queries, and you can filter and sort by average time, average call, blah, 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 CPU consumption, and whatnot. And you have a query, and if you click this ID, you will go into the detailed, okay, let's click it. You will go to the detailed query overview. So we can see how query behaves over time, right? How many calls, how many total runtime, shared buffers, missed buffers, all the things. And on the top of it, you can have your like the same top 20 things, but here you can see those on graphs, right? So you can visually see what happened here. And the last but not least, the table overview. This is like the same for queries, but for tables. You can see size, you can see the change of size, less vacuum, less analyze, and yeah. And here at the bottom, you can see like visually how big one table comparing to another. So the same here, if you like click on it, you are going to the detailed overview of the table, and you can do a lot of things. Okay, so I'm out of time. I will love to see you at our booth, and I will love to answer on your questions. Thank you.
Bravo. Huge thanks. There is a small break now, I think. So if you wanna grab food, water, or there are some snacks on the left side. Yeah, and you can drop at the Postgres booth for questions because we don't have time.
Yeah, we
But
have,
very nice timing, by
yeah,
the way.
we have
It was-
stickers.
You were on the minute.
we have a lot of stickers. Please come and take them. We don't want to bring them back home. And for the best interaction, for the best questions, for maybe you want to have selfie, we have a special presents for you. So please come and take those.
the order you send those. It's it's like a I like it because it's very lightweight, and every single script that talks this language, if you wish, those scripts can talk to each other. Essentially, you can connect every single source to every single destination with minimal effort. So that's really it. You have a small spec, but with massive leverage. Now, I must say that Singer is just for extract and load. Singer is like the pipe, it's not the processor. It means it doesn't care about the transformation layer. You need to run your transformation somewhere else, maybe dbt, maybe SQL scripts, or whatever. It means Singer is specifically designed for ELT workloads and not ETL workloads. And one more note. When I say streaming JSON, I'm not talking about real-time pipelines. In fact, most people run their workloads, run batch workloads, right? So here we only talk about the protocol, the language if you wish, and not the approach. Now, let's dive deep a bit and see what we're talking about. First of all, the specification, as we said, defines those tabs and targets, those two separate kind of scripts that you need. The first part is the tabs, and those scripts are responsible for authenticating to your source, discovering and emitting those schema messages, emitting the actual records, and finally emitting reliable cursors for incremental loads through these schema to these state messages. Then you have your target script, and its responsibilities are to ensure the destination tables exist, and that means also creating and altering them. Then you have the other responsibilities are to map data types consistently, observe the records, and obviously then store the state. So next time when you rerun that pipeline, you don't start from the beginning. So, when something breaks, you know actually where to look at. You only need to check whether your tab speaks correctly or your target listens correctly, and you eliminate any mystery in the middle. And now you have the second part of the Singer specification, the 3 types of messages. First, we start with the schema messages, the JSON messages. You have 3 main things here. The first one is the stream identifier. Usually that's something unique for the whole pipeline. It would be, in my experience, I personally like to have the source name and the table name, for example, Postgres accounts. And then you have the schema, which holds the actual information about how your source and therefore destination table needs to look like. That means you have column names, data types, any kind of constraints, like can this column have null values or should it be unique? All kinds of constraints. And finally, the schema messages holds key properties, like the primary key, let's say an ID, or which key you use for incremental loads. Let's say that would be updated at. The next message in this Singer specification is the record. Here you have 2 main things. You have the stream, again, the unique identifier, and the actual data encoded in JSON format. So you have, let's say, ID 1 and name John. Here, it's important to say that you need to emit just one schema message when you start syncing your pipeline, but then you emit a record message for every single record that you need to sync. So if you have 1 record, it equals 1 message. But if you have 1 million records, that equals 1 million messages. And finally, we have the state message. The state message essentially collects all the streams for your pipeline, in a single JSON file, in a single JSON message, but you have the latest incremental values for every single stream. So it means, let's say you sync the Postgres accounts and Postgres users. For the accounts you might have, the latest account was created, let's say today at midnight, but the latest user was created this morning at 7 a.m., for example. So you have all of these, which means next time when you start the syncs, every single stream only pulls the data that's new for this stream specifically. Now, what's next? The next thing is the Singer files. Now, you don't need this. Singer doesn't specify the files itself. But in my experience, what I found is that having some configuration, things like this, helps a lot. First, you have the config JSON file. Here you define endpoints, you define different toggles, credentials, all of these things. And then you have the catalog JSON file. In the catalog, what you have is the streams that you want to sync, the actual schema, again, column names, data types, and all of these. And you have also your incremental keys and all of these things that we just mentioned about a minute ago. Finally, you have the state JSON, where you save where you are at with your pipeline, with your syncs. Now, I must say that in my experience, I have never seen somebody actually having these files committed to their repositories. What you'd usually have is you'd create those in the runtime. So that means, you can definitely have a file where you store some toggles, some flags, but essentially what you'd have is you'd create those files in the runtime. For example, with credentials, you absolutely don't want to keep this in your code. You'd have them in the environment variables. So before you start the pipeline, what happens is you put those credentials, you put those flags and all of this information, create the file in the runtime, and pass it to the target. Same thing with the catalog. Let's say you talk to a Postgres database. There's zero sense to store the schema of your Postgres database in a file when you just can pull that information from the database, from the information schema, create that file, and again, pass it to your tap script. So the idea is that you will never actually use these files, but they help in the runtime. And here's the thing. If you use Singer without any wrappers or any files, it's extremely easy to use. You only use standard interface. You use normal Unix pipes, really. In this case, that's how you sync data from your Salesforce instance to your Postgres instance. And here's the power. If you want to change that and you migrate, let's say, from Postgres to ClickHouse, all you need to do is to just change that second script and run tap Salesforce pipe target ClickHouse. And that's the big power of Postgres. You have those two separate things that talk to each other, and you don't care about the interface. It's there and it works. So let's make it a bit more real. Let's say you have a paginated API that you need to pull this data from and push this data into your, again, Postgres database, for example. All of that happens incrementally. You only need the new data by using the updated at column. So what you do is you have the tab, and its behavior is the following. It authenticates to the API using the token, then it discovers the schema, selects all the streams that needs to be synced, and requests the data using something like where updated at is greater than the latest bookmark. Then the tab emits all these record messages. And finally, after each page, when the page is printed essentially, you emit a single state message after each page. Then you have your target script again, the tab, and what happens is this tab ensures the schema exists, right? The tables exist. It maps all the data types, observes by primary key, and finally it persists the state consistently somewhere. To test this whole thing, what I'd recommend is to kill the pipeline mid-run and restart it. It should start from the state. If it breaks, you know where to look at. It's either you need to fix either the tab or the target. You don't touch the middle. You don't touch the interface. That's really it. And here's let's talk more about the ecosystem. The thing with having an open specification like Singer is it also means that you have a ton of plugins, open source plugins that you can pull from. You can certainly look into GitHub or PyPy, for example, but this is the most comprehensive catalog I've ever found, where you can find a ton of things. So let's say you want to start pulling data again from Salesforce or HubSpot or whatever, and again want to push that to Postgres or Snowflake, Databricks. You just pull these things, read the documentation, and it's extremely easy to run them. So this is my favorite catalog, really. You can find a ton of scripts here, literally hundreds of tabs and targets. But here's the thing. You will still need to write your own code. Having an open specification means that you can write things for, let's say you want to change something that you put, like a pre-built script, or you work with a very niche connector. So following this, you can build your own tabs and targets. My recommendation is to use one of these two approaches. The first one is the, so to speak, official lightweight library, the Singer library, where you need to code everything by yourself, and it only takes care of printing out the messages for you. The other approach is to use the Singer SDK, which is not so lightweight, so to speak. It's still Python, but has a lot more things. It has the benefit of you not needed to think about how to authenticate to APIs, for example, and you just need to fill in the blanks. However, the learning curve is a bit more steep. So my recommendation is, if you want to dive deep into Singer, start with the lightweight library, and only then, after you are more confident about how things work, then you hop to this Singer SDK. Now, I guess let's recap. First of all, Singer is not about having a tool or a framework. Any specification like that is not about that. It's not about performant pipelines. It's all about having performance within the team, about having clarity and consistency. It's about onboarding people quickly, understanding what happens, and having all these quick code reviews, if you wish. So that's really all about Singer. I don't want to show you exactly how it runs. I don't want to show you code. It's all about, it's you who need to understand that, but it's extremely easy. I strongly recommend that. Now, if you have more questions, definitely reach out, check with me. You can look for me on LinkedIn. I'm Jordan Ivanov. I post there probably every single day. And also you can find the link to my newsletter. Now, I'd be happy to take some questions, really. Who's the first one?
How does Singer compare to other frameworks such as Airbyte and Fivetran and so on?
That's a very good question. So Fivetran, first of all, it's a tool, right? It's a software service, which means you need to pay a lot. Singer is a specification that is open source, so you need to run it. basically you can self-host it. Airbyte, and there's a lot of tools actually that also support Singer. You know, you can use Meltano, you can use things like Mage, which is very hot now, and a lot of other things actually use Singer in the background. Singer, by the way, it came out from another software service, and they found out that if they open this specification, it would be very helpful for, first of all, for the community, because now it's de facto the standard for anybody who doesn't want to write bespoke scripts, but also it helped this company specifically because people started writing connectors themselves and contributed to the company. So it's very different. I mean, one is for running on a service, and the other one is if you want to run them yourself. Yeah, does that help? I hope it does. Awesome. What's next? Okay, yeah. Yeah, great question. So the question is basically how you link everything together. If you have Singer just for digestion, how you run the transformations and everything else. What you would usually do is you still have an orchestrator like Airflow, where you run your Singer pipeline, you pull the data, and when you're done, you run something like dbt. That's what we do in my workplace, really. So it's very, very simple. Well, I guess if that's everything, thank you so much. I was quick, and that was my goal. Thank you.
Oh, okay. Okay, it's fine. Yeah, I think I'll be done. Like, would there be anyone like telling me like as the time goes on? Fine. Yeah.
Okay, guys, it's time for the next talk. Kartik will let us know about the orchestrating machine learning operations. So yeah, without delaying the talk, the stage is yours.
Thanks so much. Thank you, guys. Good morning, everyone. So thanks. It's wonderful to be here to see like so many bright folks this early in the morning. So I'll be speaking about a particular use case at our company. So if you have not heard about EDB, so it's a database company, and we are a Postgres-based, primarily Postgres-based company. So being a database company as well, so we had our own data challenges internally within the company. So this is a case, use case about how we used or how we transformed our machine learning operations, and also different analytics engineering workflows within EDB, and we use the tool of choice Airflow for doing that. So I'll walk through different parts of this journey, and also like how we thought about keeping Postgres at the core of everything, right? So how we use Postgres for multiple purposes, like not only for transaction processing, but also for analytical processing as well. So a quick note about me. So I'm based out of Toronto, Canada. It was a decent bit of flight here. So, but I love being here, and I have close to 15 years of experience working in the data space in different forms of it, like think analytics engineering, think machine learning, and data science workflows as well. So I've been a software engineer, pivoted into data side. So that's my career. And a quick personal note: I was recently promoted as a dad, and it was the most challenging role for me yet. So I'm still figuring out changing diapers in the midnight. So that stuff. It's very challenging, but very like one that I was looking forward to as well. So a quick note about EDB. So we are leading contributor to Postgres. We have been doing that for 20 years now. And recently, like we're working on a product which is positioned to be the core analytic and data and AI platform for Postgres, based out of Postgres, and putting Postgres at the center of it, right? So, and this particular use case, or I would rather say like all the use cases that we do internally, like our data team does internally, we try to dog food our own product. So we try to use our own product within our architecture. So we build our architectures around it. We try to pull maximum amount of Postgres, whatever we can, and then only reach out to other vendors or other particular tools in the stack outside of what it's not, what we can't do it with Postgres. So a quick note about the product that I would be talking about briefly. So we have a new offering called Hybrid Manager. So think of it as, it allows you to actually deploy an Postgres-powered engine, both on-premise and also cloud. So it brings the cloud-like agility to your on-premise and hybrid deployments for Postgres. And you would have observability baked in to the product itself. So you could actually connect your multiple other databases over to the single platform, and then see like how other databases are performing as well. So that in that sense, it is wonderful. And this particular product actually also allows provides support for AI and analytics workloads. So I'll dive deep into those as I walk through different use cases that we did internally with this as well, right? So How many of you have come across this particular use case, right, in your career? So basically, you would be looking at multiple departments within your company, each dealing in analytics in a different way, and each having their own source of truth. So when it comes to time of consolidation or reconciliation, that's when we'll analyze that the numbers that sales is reporting, it does not match with the numbers that marketing is reporting, or it does not match with the finance as well. So, and this was a problem or the challenge that we had internally as well. And another challenge was around the toolkit or the technology stack across the company, right? So for example, like someone in marketing was using GitHub Actions for the orchestration workflows, but sales were using different Python packages like Lugi or other packages. So we wanted to manage, take a step back, take a stock of the situation, and understand how we can actually bring everything together into a single stack, right? And that's what we did with our transformation journey. So we tried to break this into different phases. So as part of, in the phase one, what we wanted to do is we wanted to take a stock of the structured information sitting within the enterprise and try to give a definition to the data, right? So basically bring it to a single source and then build a data platform around it and serve this data to BI and analytics workloads as an upstream. So that's what we did as part of phase one. And when we started to do that, we quickly realized that we need an orchestrator of choice, which will be able to actually pull in data from these multiple varied data systems, right? And for that, we chose Airflow. And one of the reasons why we chose Airflow was we wanted a code-based orchestrator because we wanted to monitor and actually version all our logic. So treating data pipelines as your software product is very important in the sense that we can be very quickly get overrun while maintaining multiple single scripts that you want to run for your pipeline. So it's very important that you have software engineering best practices baked in to whatever the systems that you're adding. And some of the great features of Airflow include its flexibility and also its scalability. So when I say it's flexible in the sense that you can use it for data ingestion, you can use it for machine learning, you can use it for analytics engineering workflows, and you can pair it with other tools like dbt and also Cosmos in order to actually run your entire ecosystem. So it's just a single orchestrator that you need, and obviously the community support for Airflow as well, right? So it has a huge community around and with huge presence of operators for literally anything out of the box. And you can even write your own custom operators as well, in case you have any particular need where you need to write something unique and specific for your particular use case. So, sorry for that. Oops. Yeah. So, just a high-level note about the architecture, the analytics architecture that we had internally, right? So, as I've spoke, right, so we look to have Postgres at the center of our ecosystem. So you could see, we have an hybrid manager setting. Think of it as an Postgres, Postgres with high availability, available within multiple different regions. And then you have different extensions like PG Vector sitting on top of Postgres for our embeddings, to capture our embeddings data. And there are a couple of EDB hosted extensions, specifically around analytics accelerator, which what you call an analytic accelerator, which allows to convert, use Postgres for both transactional and analytical processing. So I'll speak a bit on that. And also we have another, couple of other extensions like AIDB, which allows you to author AI pipelines, which would take your data setting within Postgres, convert them to embeddings, and then keep it hosted onto PG Vector. So this is an ecosystem that we created, and we then added other tools on top of that. So we have Airflow to do the ingestion and also do the orchestration, and we have dbt, which does analytics engineering. Basically sits at the transformation layer for your entire architecture. And finally, you then ship it out to Tableau or PG admin or whatever the downstream systems that the users use. So this is what we deployed in phase one. And to talk about the implementation approach that we did, so we tried to do a phased approach. So it's not like you would do a big bang approach. Like you can't really move everything from what it was running into a completely different system overnight. So what we did was we identified a couple of key pipelines that were running our enterprise data set dashboards, and then we migrated those first into this system, and after that we slowly introduced, brought DBT into the mix, and then slowly worked on our analytics engineering pipelines as well. And as we built, we learned, we iterated, and then we created little snippets for ourselves, which will allow us to reuse a lot of what we have already implemented. So a couple of use cases that we are internally running at EDB with Airflow. We use it for data ingestion heavily, very heavily, like in bringing in both the structured and also the unstructured data coming across from the enterprise. We use it for reporting and analytics. We use it for machine learning operations. We use it for analytics engineering, and we also use it to run automated data quality checks happening throughout our ecosystem, right? So, and there are two key components here which I will dive deep in today, specifically being the analytics engineering and also the machine learning operations and how we did that, keeping Postgres at the core. Right? So, how many of you here have heard about DBT? Okay, so most of you are aware with what DBT does. And how many of you have heard about Cosmos? What Cosmos does, right? Okay, so I'll give you a brief introduction. So basically, DBT sits at the transformation layer, and it allows your users to actually code their transformation logic in the language that they are very familiar with, and that's SQL, right? So for that reason, it became very popular. And we have like different flavors of DBT as well, right? So we have an open source flavor called DBT Core, and then you have your DBT, the DBT library or the DBT engine that runs, and that's a paid version of it, which comes with an orchestrator. But if you want to pair with an orchestrator of your choice, then what we did internally was that we took the open source version of it, and then we paired it with Airflow. So what the challenge with putting Airflow on DBT, DBT on Airflow, is that like you would lose information on different steps of the pipeline that DBT is building for you. And that particular problem is what Cosmos is solving. So what Cosmos does, it does this magic within your pipeline, right? So basically, you have a task called transform data. So before Cosmos, that's a single task in Airflow. So you wouldn't have rerunning capability, or you wouldn't have failure visibility on which particular task failed. But after Cosmos, then each of the DBT models get transformed as separate Airflow tasks. So then you'll have, like, you can see like which task has failed. You can rerun that particular task. You could retry multiple times, and you can actually capture the state of the pipelines that you're running, right? So this is what we actually use internally as well. So we heavily double down on using DBT for our transformation layer, and then we pair it up with Airflow for our particular pipelines. And another use case that I want to talk about here, as I quickly spoke about using Postgres, being able to use Postgres for analytics workloads, running your analytics workloads, not apart from your transformation, OLTP layer as well, right? So we do that with the analytics accelerator. So what analytics accelerator is that it's an engine that actually that helps you to query external data sets sitting within S3 or any other object store of your choice, and you can query it natively from within Postgres. So you can register that external data set as a table on your Postgres. So you have now separated out your compute and the storage from the Postgres database, and then once it's registered as a table, then you can give that table to your analyst. Then they can create the DBT workflows on top of that. So it's very seamless, and it's a columnar-based query engine. We ourselves have found it to be 30x quicker in processing huge high-volume data. For example, like we had a data set which was spanning into 176 million rows or something like that, and it took under 30 seconds, or I think under 30 seconds, like 30x increase on when we are running it on native Postgres. So that was the benefit of that. And a quick dive deep into this, right? So basically, this is how you register your external, Delta or even Iceberg format data sets into, like, bring your own S3 bucket and then create a table with it. So it allows you to, it creates a table and then you can communicate with it as if the data exists on Postgres database itself. So that's how it does. And then another key enabling factor was, thinking about the HTAP architectural paradigm, right? So basically, HTAP is something that's called hybrid transaction and analytics workflow as well, right? So basically, being able to use Postgres for your OLTP and also analytics at the same time. And that's what we do with replicate to analytics command that runs it on the backend. So within your database, like if you have an transactional table that you want to replicate to analytics as well, so it directly converts that to Delta and Iceberg format, which you can use, or you can base your analytics queries on top of that. So, and this is a great feature that we heavily use internally. And speaking of some of the gates that we kept for ourselves, right? So basically, data quality was very important for us. And this was something that we lacked previously. So we do not have visibility into quality of the data that was sitting across the enterprise. And with this stack, like, we were able to, at the transformation layer, we use dbt tests to do a lot of our testing. And at the during the ingestion phase, we use another data quality framework called Soda Core, if you have heard about that. We use Soda Core heavily for doing YAML-based data quality checks. And then we also, promoted fail fast and also fail loud, right? So basically, so if something goes wrong, so we triggered it up with PagerDuty, and then it would let us know that something within your ecosystem has failed. And it's no more realizing that your numbers are off on the dashboard, but you are catching those errors very quickly before on the pipeline itself. So what this entire setup has brought us, right? So it gave reproducibility for us, in the sense that we are now following best practices for all our data pipelines, and for all the data that comes out of this team is being stamped as it was already vetted and it went through production, data policies. And a key thing it enabled us to do is to have a thorough understanding of the data lineage on what are the sources of the data that we are consuming, how it is evolving over into different formats as it moves through the ecosystem, right? So, and that's something which we unlocked. We were able to unlock after this. And switching gears, so I'll speak a bit about machine learning operations as well. So, right, thinking of machine learning operations, I would say, like, it's very similar to data pipelines, but it's different in the sense that now you need to worry about a lot more other things than your regular pipeline script that you're also orchestrating. So you need to worry about data versioning. So you should be tracking what version of the data you are using for building the pipeline. And you need to worry about model monitoring. You need to worry about training pipelines. You need to worry about quality. You need to worry about retraining pipelines if you want to set up automated training as well. So even with MLOps, it is very important to take this in a phased approach. Like I really like this article from Azure, which gives you your maturity models for your machine learning operations, right? So you go from maturity 0 to maturity 4, level 0 to level 4, and it's one step at a time. So you automate training, you automate monitoring, you automate retraining, autonomous retraining, and so you need to tackle this one step at a time, and then as you build, keep on building layers on top of that. So this is our high-level machine learning architecture that we have internally. So we use Airflow for what it is good at. Airflow is good at orchestrating things. It is not good at running machine learning workflows, right? So we use help of a third-party tool like Azure ML. Like you could even use AWS ecosystem, so whatever the ecosystem that can fit in. But you can pair it with an orchestrator like Airflow to actually orchestrate your tasks. So apart from the data transform, the analytics engineering pipeline that you see here, the 3 new steps here are the model monitoring, the training pipelines, and also your batch prediction pipeline. So all of our jobs we have right now, so we don't have any real-time scoring requirements for them. So we do batch scoring like once a week for them. Like most of the models that we have are churn-based models or financial forecasting-based models, and we don't really need a real-time view for that. So this is a high-level example of how these pipelines look on our end, right? So for example, like if we talk about the training and inference, so for the training, you have the feature engineering pipeline baked in, then you have running the actual training job and Azure ML, and taking the assets out of the training job, looking at your different artifacts to verify if these assets work well for you, and if they do work well, then you will register that new model within the Azure ML model registry, and that completes the training run for you. When it comes to inference, then it will pick the most latest model from your registry and runs inference on top of that and sends the predictions back to Postgres. Like in our case, that's the DB of choice that we are going with. And so to talk about the model monitoring as well, so we have a setup to measure the model performance for all the deployed models, basically live in production. So what we do is we have certain custom routines which look for data drift, which also look for accuracy metrics and other different metrics that are very important, that you rely on. It could be your F1 score or whatever the different ML metrics that you need for varied use cases. And then you can bunch it up as a particular pipeline job that runs regularly. And if it finds anything lacking, then it actually automatically re-triggers a training pipeline for you. So it tries to retrain the data with much more recent data, and then sees like if it checks if the artifacts or if it is able to get much better accuracy coming out of that. And a quick note about governance, with all the stuff that we did on phase 1 at EDB, what we wanted to do is to keep governance at the center of everything, like trying to have a view of where data sits, where it sits within the ecosystem, how are we transforming it, who has access to it, and how do you manage lineage for those data, right? So that's what we attempted with phase 1. And with phase 2, we are actually creating something like a sandwich layer. So it's not central data anymore. It's decentralized data with AI, right? So you bring your own AI tools. You have embedded AI tools coming up in the market. So within the enterprise, you would have multiple of these tools deployed. So you'd have to capture data coming from those tools as well. And that's what we are enabling as we are working on phase 2 right now. So have an governance architecture that sits or covers both of these elements. Like it looks at both the centralized data and also decentralized data as well. So that's something that we are working on. And coming to the design patterns, so specifically for our workloads, there were some of the design patterns that we relied on. Basically, as multiple teams were using the same environment for the orchestration. So we had naming conventions like DAG naming conventions to determine which team actually owns the DAG. And for the if you know about Airflow, then we actually implemented custom XCOM backends. So we don't depend on Airflow's native database for our XCOM. So our XCOMs get stored on a third-party object storage. And we also rely on custom secrets backend. So we are not storing any secrets on our Airflow provider as well. And we had a use case where we had to create our own custom operator as well. We did not, so we had an environment which was federated. It was highly secure. Like we couldn't get direct connectivity to it. So we had to create an operator for that and get access. And coming to DBT, the best practice that we found painfully was having your own separated environment curated for DBT. We initially did not have that, and we ran into a lot of challenges with package dependencies. So I would highly suggest that. So if you're deploying a DBT, especially on Airflow, have it running in its own custom environment. So lessons learned. Some of the lessons learned that we throughout these phases, right? So observability was something which was very huge. Like you need to be knowing what is happening where. So design your phases in such a way that you're able to see which different pipelines are running at what time, and have some sort of an observable framework around that. So, and also be heavy on logging. So make sure you're logging everything. Make sure you pair it up with third-party sources, like it could be CloudWatch, or it could be on the Azure side. I don't know, whatever it is, but you could actually, you need to make sure you're logging it. And this would be one of the requirements from your InfoSec teams as well, like in case you are working with them closely. So logging is very important. And the second point is reusing components, right? So this was something that we lacked initially. So we were building our own, each team was building their own set of components, and that's something where we learned. So we took a step back and we built a utils package around it. So all the reusable package, like most of the teams would be using those rather than recreating everything from scratch. So CI/CD and change management, very important. So we specifically use GitHub Actions. Rely on that for CI/CD, especially for moving, think of production deployments for Airflow and also for dbt. So we heavily use that, and also make a point on documenting everything that you do so that it becomes easier for your onboarding any new engineers onto the team as well. So key takeaways, build in phases. So it's not a marathon. Sorry, it's not a single big bang job. So it's a marathon. So take it slow, build one step at a time, and treat your pipelines like production software. So that's very important. Like you have code versioning for them, have monitoring, have logging set up for all of these, so that it's very helpful and it does not come back to bite you. Start simple. Keep iterating. So start with a simple use case and then keep adding use cases on top of that. So that would allow you to actually make a huge progress within your enterprise as well. And we really found that Airflow is amazingly flexible in the sense that it can handle everything. So it can handle data ingestion jobs, it can handle machine learning operations, it can handle AI operations as well. That's where we are leaning. So we'll be orchestrating our LLM workflows using Airflow as well. So it is very highly flexible for doing that. And yeah, the code duplication, like build reusable components, which will be used by multiple teams as you move through the progress. So yeah, thank you so much. Would you happy to take any questions from the audience? Yeah. Yes. Yeah. Yeah. Right. Yes. Yeah. Especially. Yeah. That's a great question actually. So especially in the world of machine learning, data drift is very important, and one of the key things that helps us or define data drift is on how you do your feature engineering, right? So at the time of your feature engineering, you know the limits of all the features that you're considering. So you would know the up and down, basically higher ceilings for your data set, and that's what we regularly monitor. So if a new data input that's coming in from the business is outside of these parameters that the model was trained on, that's when we highlight and then we flag it. So that now we need to treat those or engineer those features separately, differently, in the sense to also capture the newer data that we are seeing.
Wait. Check it.
Yeah.
Sorry.
Manually interface. Sorry, I understand what is data drift. I understand in high level how you do it. My question was, do you use it only to flag and then act manually, or you make automated based on some KPIs that you see data drift to trigger some retraining automatically?
Yeah, so we have it both ways actually. So we have an automation to trigger retraining job as well, but some of the times like it's simply not possible as well. So in one of the use cases that we have, like we were manually dealing with those steps. So you would come across situations where you have to deal some things manual, in the sense that you would only use it for flagging and then take the model off down from the production and then deal with it separately. Like it's not as easy to retrain because sometimes your actual logic would change on how you are building things. So that brings development into the loop, right? So that's when we handle those manually. Any other questions? Awesome. Thank you. Thanks, guys.
So guys, you already saw them on the screen. Here, Peter Rusev and Lubomir Nedialkov. And enjoy and have fun.
Okay. Hello, everyone, and thank you for joining us today. In our session, we will show how SRE ensure reliability and stability of productive systems in ever-evolving landscape, and how AI agents help SREs to work smarter and stay resilient. At the end, we will wrap up with a live demo that will showcase the capabilities. Our journey starts with a brief overview of our global site reliability engineering presence and structure. Site reliability engineering is a discipline that combines software engineering and system engineering practices in order to ensure the availability, performance, and scalability of production systems. Our SRE organization operates across 5 strategically distributed locations, and in total, we are 12 SRE teams covering 50 productive services. This global distribution is intentional. It allows us to adopt the follow-the-sun support model, which ensures our continuous coverage on these productive services while maintaining sustainable on-call practices for our teams. This structure not only enhances our response time, but also contributes to our broader objective to deliver reliable, high-quality services at scale. Now that we know what SRE is, we'll walk you through some technical details so the demo at the end doesn't look like magic. Let's start with the big picture, which is standing behind the SRE Copilot. It's a network of intelligent agents that can observe, analyze, and act. And together with that, fully integrated with the entire ecosystem. At the core, we have these agents which mirror the expertise and workflows of all SRE teams which we have part of our organization. They replicate human decision making and responsibilities, but deliver it with speed, precision, and scale. To understand how it works, let's take a closer look at what defines an agent. Each one is powered by 3 core components. The first one is the context. This is the intelligent profile that defines the agent's capabilities and its operational boundaries. Through the context, each agent knows what domain or services it's responsible for, what issues it typically solves, and even its own personality and operating style, shaped by the practices and characteristics of a real SRE team. This contextual awareness allows the agents to act with precision. They know when to take the lead, when to support other agents, and how to align with the larger incident response effort. The second component is the toolset. This is the operational interface that gives each agent the ability to analyze real-time telemetry and propose remediation steps when it's needed. Agents are able to propose such kind of fixes or steps which can resolve a particular issue, But these proposals should be and must be confirmed from a real engineer because each of these actions are integrated in the so-called human-in-the-loop process. This keeps a balance between autonomy and oversight and ensures fast response with the full accountability. And finally, the knowledge base. This is the rich blend of architectural models, past incident data, dependency graphs, and procedural runbooks that each agent can draw data in order to make informed decisions. And now, we will explore how the Copilot managed this vast mix of data.
In SRE, we actually always had knowledge, tons of it in fact. The documents, runbook, everything it was there. But there was a problem. These documents, they were unstructured, scattered. It was one big mess, to be honest. And one of our focuses with the SRE Copilot was to make something actionable from this mess. So we are introducing a separated component, so-called the data loader. And he has only one job, to provide all of the data into a single source of truth. Let's see how that's done to check the whole picture. Here, we have the data loader who cares about the ingestion. Then the agent queries the information, and we need a place where to store this information. We have a knowledge graph in a hybrid setup with vector embeddings. But that was not the picture all the time. In the beginning, we were using a simple vector database. And all previously mentioned documents, we were creating embeddings of them, storing them in the vector database so the agent could query the information and search them by context and similarity. But this had a problem. We wanted, as Peter already said, we have 51 services. And each one of them is deployed across 40 different landscapes in all major IaaS providers, including one of our own. You can imagine the complexity and the amount of data which we had and we need to handle. And here the knowledge graph comes in. The knowledge graph provides us with the structure about the data. In our hybrid setup, inside the actual graph nodes, we are storing the embeddings, while the edges are semantically connected, so it gives us the relationship between the documents and the nodes. Like that, our agents can't only just query the information, but also see the whole picture and all of the connections in the relationship with them. If we go back to the slide, now let's focus in the next part, and that will be the ingestion. How do we actually bring the data to the knowledge graph? Here it's simple, we have a few steps. The first one, obviously, we are collecting all of the documents from different data sources, from everywhere almost. And here also the caching mechanism happens. If a document was already collected, create a hash based on the store it in a cache, then so we don't proceed any further with the next steps. As the next steps are a little bit more of, let's say, expensive and so on. And the next part is we actually create the embeddings of the documents. Here, in a multi-threaded way, while we split the documents in batches, we process them, we create the embeddings, so it can be faster and smarter. And then finally, but not on final place, we do the metadata enrichment. What does that mean? Using a large language model, we extract the title of the document based on the content, and the 5 most similar questions which could be based still on the content of the document itself. That's from the ingestion process. Then we actually have the query. The query, I can say that it's one of the simplest things from the user perspective. You just go to the Copilot UI and using a natural language, just queries the knowledge base and receive the needed information based on the knowledge base. That's from the query. And if we go back to the...
And here, to have a better understanding what we mean by documents, let's take a look at these example runbooks. These are kind of a blueprints. But imagine the scale and the amount of data which our engineers need to work. Because as we said at the beginning, we cover 50 productive services. And these services are deployed across all major IaaS providers. So imagine how much information we need in order to be able to react on a particular issues which they occur, or when we are put in a call to resolve an outage, for example, at 3 at the night, when each and every minute actually matter. So these RAM books actually results in this picture. This is the knowledge graph, actually, example of a knowledge graph which is built on these blueprint RAM books. All the nodes here, as Ljubomir explained, are created containing embedded data based on the RAM book in their structure, and the edges are defining the semantic connections between all the nodes created. So now let's proceed with the live demo, where actually we will walk you through the entire process, how the entire knowledge graph looks, how we can query for data, and what are the capabilities of the agents which are stepping on this knowledge graph. So let me switch the screen and start. First, I would like to show the knowledge graph in the database explorer. It's not so nice as in the picture, which it's not visible there. How to switch the screen? Probably I need to. Give me a second just to switch the proper screen. Okay, it's visible. So as I said, this is the database explorer which we have in hand, and the knowledge graph which we are already built, stepping actually exactly on this example RAM books, looks like this. It looks a bit scary, but in the essence, if we zoom in, each of the nodes are representing some particular piece of data which we have defined in these RAM books. And if we zoom a bit further here, we can see that each of the edges represent particular semantic connection between these nodes. And basically, I cannot expand the whole graph because it will become even scarier. So for the next part, we have one simple application where we can take a look at the graph in a more convenient form. So let's take a look here. We have a RAM book here as a node, which is connected to almost each and every node in this schema. So this RAM book have 8 connections, for example, and one of these connections is what is the escalation path when a particular issue occurs. This basically means which teams our engineers needs to pull in case they identify such need. There are, for example, diagnosis and remediation steps related to the dependencies of the particular service, and a lot more. So having the graph already created for us, because the most expensive operation actually is to prepare the data and build the graph stepping on it. That part I unfortunately cannot demonstrate right now because it takes some time, and that's why we prepared it before the session. But we are able right now to query the graph, and using particularly this hybrid mode of querying the graph, including including operations which are not only traversing the graph based on the semantic connections which we already presented, but also comparing the embeddings which are basically enrich the context with which we can able actually to work later, and the agents stepping on that. So for example, for that purpose, I will execute this particular query. These questions, which we see here, are actually generated as part of the graph creation. Lubomira already mentioned that. As part of the metadata enrichment and the content of each and every particular node, actually we generate at least 5 most relevant questions which this particular piece of data can satisfy. So for the example, I will use this particular query. And right now, the process of extracting the data already started. While it's executing, let's take a look actually what's happening under the hood. So here, you see, actually, is it necessary to zoom a bit? Probably yes. I will zoom it in. Is it okay now? Okay, so we saw that as a first step, it was executed a so-called HANA cipher query retriever. So what this basically means is with the help of a large language model and the specifics of the open cipher specification, we are generating an open cipher query which is intended to resolve our request, whether it's a question or whatever prompt we push through the agents. Right now, actually, we don't have agent in the picture. Right now, we just have a large language model, and through this, actually, we are querying the knowledge graph. So let's see what happened as a next step. There were a chain executed. And as part of this chain, we have, as I explained, HANA cipher query retriever with the already created open cipher script. And then we see here that we executed also a vector retrieval, stepping on the already provided data from the previous step. What this basically means, we can what's happening under the hood actually through the cipher query, we receive a subgraph of the larger picture, and this subgraph serves the vector retrieval in order to provide us actually the context, the data which is really matters. So at the end, at the step where we are refining the results which we received from both retrievers, we can see that based on our question, this is the response which we receive, stepping on the context which were previously created for us. And finally, that's the, let's see what actually were the actual response here. So this is actually explaining what is this, what's talking about when we mention this particular runbook. So let's proceed further. What we, and maybe first summarize a bit. What we did right now is querying the knowledge graph, but without having any agentic approach. It's a simple query, which can be done with whatever large language model we decide to use. But right now, at the next step of the demo, we will see how the agents use this data and how stepping on these runbooks, because in this particular runbooks, we included some data. Of course, we don't want to break some productive systems and make our colleagues' life harder during the conference, going to resolve some issues. So for that purpose, what we did is we created a simple demo application. This demo application has a dependency to a database. And this database, of course, is PostgreSQL. And what we are going to, in this runbooks, actually, we explained what is these dependencies between the components of the system, and what remediation steps can be taken in order to remediate particular issues. So let's see this in action. This is the interface of our Copilot. As we explained briefly at the beginning, it's consisting of 12 agents as of now, 12 agents as of now, and each of these agents is specialized with the context of a particular team which we have in the organization. It's able to provide information, propose actions which can resolve real issues, analyze logs, and whatever process is relevant in order to support the larger incident response effort. So let's navigate directly to our demo agent here. Let me first just really quickly to refresh my session here. And here is the demo agent. So what I'm going to ask right now is, what is the current state of the demo application? And let's see what will be the response. In the meantime, as you can see here, something pretty important happened when I send the response, send the request. And this is exactly the message were anonymized. This basically means that everything which goes through this system passed through the anonymization, and in this way, actually, we ensure no sensitive data can be forwarded to the large language model which we are using under the hood. And this is something pretty crucial and important when we speak about using large language models and AI responsibly, and having in mind the context in which actually we are using AI here and agentic approach. So in the meantime, our agent responded. And luckily, our demo application is up and running. But we need to break it right now. So for that purpose, I will navigate to the cockpit from where actually we manage our services and assets in SAP. So here is the demo application, and as the agent showed us, it's up and running and there is no issue with it. And let's navigate to the configurations of the databases. You see here we have a one key configured, which key is used from the application in order to be able to authenticate and establish session with the PostgreSQL instance. What I'm going to do right now is go and directly delete this key. And we can imagine this scenario. This is a simple example, but such issues happen. Wrong configuration, misconfiguration, human error, and etc. Such issues can happen even in the reality, and I believe that such kind of issues were part of your experience also. So the keyword deleted. Right now, what I'm going to, I would simply check the status again. So here there is nothing prepared. Actually, I'm using whatever I come with as a prompt to the agent. So actually, I hope that it will work as expected, but let's see. And luckily, it is working. So we have state down of the application. And here, we can also see what the agent is doing, observing its chain of thought. Not only through the observability stack, which I showed you previously, but also the user, from the user perspective, you are able to track each and every step which the agent takes in order to satisfy our requirement. So the application is down. What we are going to do now? Usually, in such scenarios, first thing which we do is go and check the application logs. What's happening? One of the steps, of course, it's not the most prominent, but one of the steps will be, why not? I would like to go and check the logs. And usually this means go to a dashboard, find the particular instance, find the proper filter, and etc. and etc. A lot of steps. But with the Copilot and this particular agent, I'm simply able to trigger a command. And this brings me an interface from which I can trigger a log collection, but not only providing me the particular logs of the application, but also execute a thorough analysis of these logs and provide me the most prominent issues and errors observed from this huge amount of logs. And you'll see it right now. Let's trigger it. And the logs are here. Actually, this is extracting logs from our cloud instance. It's not something which is currently I'm showcasing from my machine or whatever it is. So you see here, the logs are provided to me, and if I want, I can query manually the logs. Of course, the issue here is pretty much obvious when I see here the logs, but let's see what the analysis will bring to me, what insights it will provide to me in order to be able to remediate this issue. And while waiting, imagine that we are in a call with Ljubomir, and we are working together on this issue. I can simply go here and share the thread with him, and he can see in real time what I'm actually doing and what insights the agent brings. In the meantime, the analysis finished, and the most prominent one is here. Database authentication failure spike. So we see here the details and how often this issue occurred. And of course, this is the actual issue. What will be the next step? Usually I need to go and manually recreate this key, but instead I'm going to do the following. I will simply ask the agent, fix it for me. What will happen now? Let's see. What will be the response of the agent? And it is simply fix it for me. It's not do that or do this. A simple prompt. And here it is. It's proposing to me to execute a recommended action. And why it's aware which recommended action to execute? Because it queried the knowledge graph, and it knows for this particular kind of issues, this is the action which needs to be taken. And it's waiting for my confirmation. I confirm this. As I said, such kind of actions are always in the human-in-the-loop process. For now. Probably in the future it will be absolutely autonomous, but for now, we need to have this insurance, so to say. And right now, the recommended action is being executed. The agent is polling the status right now. What's happening with the execution of this recommended action? And luckily, at the end, our application will be again in the up and running state. But let's see. And yes, our application were recovered with 3 simple prompts to the agent, which we have part of our ecosystem. Again, let me wind back a bit. Imagine such kind of scenarios on a scale which we mentioned, 50 services on all IaaS providers, including our own. So the application is up and running. Let's see for additional evidence here in the cockpit again. I will refresh the page. Let's see whether the key were recreated for me. And yes, the key is here. So with that, I would like to thank you for your time and attention. We have 1 more minute for some questions, but of course, after the session, me and Ljubomir will be available if there are some questions or discussions happen in the meantime. So thank you very much.
Thank you.
There is a question over there, but Yes, we have only 1 minute, guys, for questions. So
Yeah, hi. Just wanted to ask really quick, you mentioned that it's an LLM that extracts metadata from the documents, like, the title and the most relevant questions. But is it also an LLM which decides how to connect the graph itself? So which document to connect to which in your knowledge graph, or is this something that you do manually as well?
Actually, we don't have any manual step here.
Okay.
Everything is handled by LLM, but with precise guardrails. And it's not about prompt. Sorry, it's not about prompt engineering. It's actually really establishing particular guardrails. When actually because we are using OpenCipher specification in order to be able to traverse and also generate semantically connected nodes. And this is a pipeline, actually, pipeline of steps which are being executed, some of which in parallel, in a multi-threaded fashion, and some of which we needs to wait for the previous steps to finish. So, yes, this is the way how we do it, but we do not write the OpenCipher manually. That's the trick here.
well, okay, I see that there are other questions, but we don't have time. Sorry.
Yeah, I have an answer for you. We have almost 3 or 4 real success stories which are part of exact scenario which I mentioned here. Actually, Lubomir's team were able to identify and provide insights to the service team for an issue which occurred in a matter of probably a minute or something like that.
Less than a minute.
And it is in a productive system. Exactly utilizing this particular case which I showcase now.
Okay, so we don't have time and we don't have break, so thanks. And if you have questions, we do not have a speaker room, so we have like the corridor hall, so you can just catch them and ask them whatever you want.
Yeah, thank you.
Thank you.
Okay, guys. Okay, okay, guys. We are for the last talk before the break. Mikhail, I don't know, clicker? Anyone? We are waiting for the clicker. So Mikhail will talk with us about some fancy stuff. I can only say that he's very experienced speaker, and few years back I was on his talk about web, and his talk was maybe the best of the conference. So yeah, I don't know what to expect today, but I would expect a lot. Keep in mind that right after his talk is the break. We do not have included lunch on the conference, but there are a lot of options around. So there are 2 restaurants downstairs, and there is a Serbian thing as well, and there is on the other side of Carigrad said there is another 2 restaurants as well. So if this talk takes more time, it's not a big deal because it's hour and a half break after it. So yeah, Misho, the stage is yours.
Thank you very much. We're approaching the lunch event, so please don't fall asleep. I'm going to talk about AI. This is the most important topic, and let's approach it carefully. Who am I? My name is Mikhail Petrov. I'm a PhD in computer science. Those are my network contacts that you can use in order to find me if you're interested to talk about AI databases, etc. I am practically living in this building, trying to educate the future of our society. The Faculty of Math and Informatics at Plovdiv University. During my free time, I am working as a head of engineering at Upia Tech. We are a Snowflake partner, and we're trying to deal on a daily basis with some database problems, mainly centering around Snowflake technologies. And the most proud achievement is that I am the founder of the first located in Bulgaria and the Balkan Peninsula Bulgarian user group centered around Snowflake technology. So if you're interested in this topic, we can always gather around and share some ideas related to cloud computing and cloud technologies. Last week, we actually hosted our first event at Plovdiv, and it was pretty amazing. We gathered a lot of people that are passionate about this technology, so I believe this the crowd in this building is going to be a perfect vector for our future society. Quick quiz. Raise your hand if you never, ever heard about Snowflake cloud platform. Let's see. Oh, perfect. We are dealing with some very knowledgeable crowd. So Snowflake is the topic of this event. We're going to talk about talking. We're going to explain how to actually communicate with our database. One of the very interesting idea that I'm currently captivated is this cloud technology and also cats. When we combine cats and snowflakes, we have a snowcat, and in the shadow of the today presentation, I am going to deal with the idea how this particular platform is going to help us actually create products that can benefit our daily life. For those who actually raise their hands in order to demonstrate publicly that they are not familiar with Snowflake, I'm going to just state that Snowflake is a modern cloud-first infrastructure/platform that can give us every single aspect of data storage, data integration, data analytics, and the whole ETL process. But today, we are going to face the AI revolution. It happens, it's wild, it's everywhere. We're not interested anymore in shiny new languages. We are interested only in large language models. This is the reason that I'm going to focus only on this particular aspect of the platform, the so-called Snowflake Cortex AI, and how to actually use this in order to create products. Of course, because the time is limited, we are going to only scratch the surface, but I believe this is going to be a very interesting foundation for future communication. So we all experience this problem on a daily basis. We are trying to communicate with our database. Usually, the medium is a single one, SQL programming language. But what about the people who are not familiar with SQL, or those of you that do not wish to even remotely approach this language because it's too chaotic, it does not look like Java, it's too strange or complicated, and the learning curve is extremely steep and strange in a long run if you're dealing with something complex? Well, usually in this case we are shouting and cursing, and we are trying to approach this in a more meaningful way. So in this case, we need to actually look at a different approach to this very problem. How to communicate with the database using our natural language. In order to actually understand this, we need to search for answers a little bit outside of the scope of the traditional databases. So we are going to approach the vector databases, the so-called odd ones in the bunch. So usually, when we are trying to communicate with our data, imagine we are talking about ChatGPT or another large language model, we always have three different types of options, of ideas, of items that are working together. We have the data, we have the model, and we have the embeddings. The data can be everything: images, text, video, audio files. Useful information. The model is the so-called large language model transformer. So this is the piece that can actually get these words and attach meaning to them. And of course, the end result is actually the embedding. The embedding is a magic set of vectors, numbers, that can actually make sense not for us, but for the database. Those numbers that you can see on your screen, they can be everything in relation to the language. But this is going to be important just in a bit. So by actually using those three aspects, we can transform images, texts, audio files, and video files into a vector in which we can communicate. Because at the end of the day, we just have a bunch of arrays of numbers that for a particular large language model means something semantically. So the idea is extremely simple. We get a bunch of data, we've put it in our database, vector database, and we can ask question the same way that we are currently asking ChatGPT, for example, or Gemini. There are a lot of vector databases that we can use. On a market, usually every single platform have a preferred way to actually introduce this to their database. We're currently going to face only the Snowflake aspect in the second column because the vector database is built in the platform, and we don't need to introduce anything separate in this case. So as I mentioned, Snowflake gives us Cortex. So the Cortex is a bunch of functions. You can think about a library or a framework of different ideas, patterns, and functionality that can come together in order to extract information from text. We have LLM functions, copilot type experience, chat, so to speak. Document AI, which means a detailed analysis of a random document. We can fine-tune, analyze, and search in documents with a multi-purpose scenario. So we can search in images, we can search in text, we can search in audio. And also we have a bunch of ML functions that can be used in order to train some models in order to get a little bit more semantically meaningful information. This is the platform in a nutshell. The Cortex AI gives us this from scratch. We just need to have a Snowflake account, we just need to connect it, and from this point on, we can use it directly, utilizing not only Snowflake proprietary models, but also some of the most popular under the sun. The OpenAI models, Gemma, Mistral, etc. So this was actually introduction. The idea that we are going to use a platform to solve our problem. But let's go to the practical cases. Let's talk integration. Some business use cases that I've actually trying to wrap my head around for the last couple of, let's call it months. It's over 12 months, so an year and a half. So me and my wife, she's a real vet. I'm the strange person with the Snowflake account. We've decided to help the veterinary practitioners to actually extract meaningful data from their patients. So imagine we have a veterinary practice, a single cabinet with a single doctor or a multiple doctors who are on a daily basis accepting different visits from customers. They are always examining patients, cats and dogs, and they are up to their eye in different documents. It's a lot of work on a daily basis, a lot of information that someone needs to keep track of it. So, what is the solution? We've created something called Vet Manager. This Vet Manager is a simple application on your phone, and you can imagine it as a glorified Wikipedia for everything that is happening inside this particular practice. We're using this application in order to solve 3 different problems. How to give us specific information about medical facts. We need to collect and filter super specific information about our patients. And of course, we need to explain the current state of the patients to some normal people that have questions. For example, the owners of those pets. You can imagine that if you're a young veterinary practitioner who is currently challenged with the state of the medicine, you're always struggling to remember what was this magical ingredient that I need to give to my patient. How to actually solve their problem. It's not easy, and usually those information is collected in some legit medical books. So our first use case is simple. I wish to have a software that can answer me a specific medical questions. If you ask ChatGPT, yeah, you're going to get the answer. But what if I told you that I've spent thousands of dollars to obtain limited medical books that are not available to ChatGPT, and I wish to use them in my practice? Those limited books can be obtained using different methods like attending seminars or buying them from some limited publishers, etc. Not publicly available information, not internet material. So, how to solve this problem? One of the solutions is the so-called RAG. Retrieve, augment, generate. So, in layman's term, the large language model do not have enough memory to contain everything that we need to know. It's limited at its nature. But what about an extra container of memory that have all of those valuable information that I need to extract at any given moment? So this is the moment that we are introducing our external documents. We have a bunch of books which needs to be embedded in the vector database, in this case, the Snowflake's Cortex. And from this point on, I can ask the large language model, do you know this extremely specific topic about this extremely specific disease, for example? Practically, this means that I have a number of books, specialized medical books, in PDFs or in different type of documents. For example, lectures in video format, or lectures in audio format, or lectures in whatever format. And I need to actually split them into different chapters that I can actually feed the database. Let's get this textbook of veterinary medicine. Let's split them to chapters. Chapter 1, basic examination. Chapter 2, different diseases in cats and dogs. Chapter 3, whatever. So, we are creating a database, we're creating a schema, and in our personal Snowflake storage, we can put every single one of those PDF files that we currently have. Surgical files, cats and dogs, canine bone growth, etc. Every single literature that I'm currently obtained, it's part of my Snowflake environment. I've updated it, I've uploaded it, and I can start rugging it. The basic process is when I have a PDF file which is part of my stage, I can actually extract information directly from those files without the necessity of actually introducing the model to this particular file. I'm not going to say, get from this column or from this row a particular information. No, it's just a pool of data. So I can use a Snowflake-specific functions like parse document in order to extract the information. I can split it into different chunks, and I can create a pseudo virtual table that is going to act as a memory pool. In this case, every single chapter is embedded using E5 base V2, which is a standard algorithms in Snowflake Cortex, and the result is going to be a bunch of arrays full of numbers. Those arrays are going to be additionally chunked, metadata hydrated, manually, or as we factually understand in the last lecture, it's possible to create a fully automated process. And actually, at the end of the day, we're going to have a huge extra large language model brain that we can directly query. So if, for example, our young practitioner asked the application, or in this case, the Snowflake, what are the symptoms of ehrlichiosis, which is a disease in the cats and dogs, I'm going to receive information directly from the Snowflake LLM using this embedding that I've just created with my PDF files. So if we actually observe this in a context way, so the same way that we are actually approaching ChatGPT, imagine that every single time we ask the model, we are sending something like this. You're a veterinary assistant or consultant, and you're going to use this medical context that I've just presented to you. Whenever you have any doubt, don't know the answer, or have even the slightest uncertainty about the accuracy, you're going to provide me information about this. I don't know, I'm not sure, I'm going to feed you something that is factually wrong. When returning information about this concept or context, always include a link to the document in order to actually check the PDF if this is correct. When returning information about a patient, if I ask, for example, what's happening with Gosho, what is the current state of this particular animal, always include a link to a patient profile or patient dossier. And this is integration on so many levels, because the AI is not going to only answer questions, it's going to be integrated in our database system, and we are actually getting everything outside of the box. The LLM in the Snowflake and the database, which is also in Snowflake. Second use case that we have. The software needs to aggregate data about the patient current and past state. This is a dynamic data use case. Usually the problem when dealing with extreme amount of information about patients is a historic accuracy. Somebody actually introduced a mistake in the protocol, or we didn't type it on the same day, and in the long run, we forget something. Is this animal is actually treated for these specific diseases? What was the weight of this animal when first he or she approached the practice? We don't know. And usually, we are too busy to type something on our computer. The doctors are pretty busy. Usually when we have the image of a doctor, we are usually imagining someone who is going to treat us, not type on the computer a specific state of the current patient. So what is going to be the best approach? To just record the thoughts during the whole examination. For example, I am examining the patient and I am dictating. This patient is named whatever. It's of X weight and X height. It have the past symptoms of this and this and this. And this information is going to be recorded. And from this point on, the recording can be treated as text. So Snowflake gives us the ability to actually collect information from whatever type of format. In this case, we can use a speech processor using the AI transcribe to get this information as a voice, directly transforming into text, and from this point on, we can create protocols, or we can ask questions about this specific use case. And because it's a verbal, we're not going to miss anything. We can just communicate with the owner. The owner testimony is going to be on the tape. And every single conversation that we have with our colleagues is also going to be on tape. Nothing is going to be lost in the translation. And this information is available in Bulgarian. So every single practice that currently integrate our software can actually talk in their own native language without the necessity to actually introduce some external language just for the application. So speaking in Bulgarian, speaking with a client, we are going to get the whole conversation ready to be analyzed and ready for questions. So in order, for example, to extract this information, we can use a simple select query, AI transcribe. We are addressing the file that can that can be obtained dynamically. For example, we have a medical consultation and consultation.waf file, which is a result of a particular recording. And the result is going to be an audio duration in seconds and some text that can be used to further analyze the situation. Also, we can actually extract different segments. So every single words or sentence can be further chunked and analyzed if we wish to have extremely lean result based on our expectation for the model. Purely from UI's perspective, every single file that is providing a multimodal capability, in this case video, audio, etc., can be directly observed inside the Snowsight UI, which is part of the Snowflake UI suite. And from this point on, based on queries or based on natural language, we can communicate with this particular document. In this case, I am presenting a semantic modeling in which we are trying to actually describe from which point of the conversation to which point of the conversation we wish to feed the model in order to fine-tune it a little bit later. This is a simple meeting analysis that is a part of the application. So everything that's happened is actually visible inside the Snowflake interface. What question do you have the meeting? What is being discussed 5 minutes into the meeting? And every single one of those questions that you can see is something that we've asked the model. We can ask it in Bulgarian, we can ask it in English, we can ask it in every single language that you've just saw listed on the screen. And the third and final use case that we've tackled in our journey, trying to make the veterinary medicine a little bit more digital, is the software needs to aggregate data in relation to our internal processes. This is a combination between static data and the dynamic data. In which case? So the dynamic data is everything that is actually working in our practice. We have some patients that are experiencing different diseases. We don't know what is going to be the exit of particular procedure. It can go right, it can go wrong. We have some ideas what's happening or how we can approach this in a different manner. But every single part of this is dynamic data. We also have our rack data that we have explained in the first use case. Everything that we've collected during the years, something that is not going to change, something that is static by nature. Documentation, patient's protocol, surgical information about different patients, internal protocols, drug info, for example. Every single medicine practice is using a little bit of different way of mixing their ingredients when they're trying, for example, to apply anesthesia or, for example, to apply different medicine to a particular weight of the patients. This is information that this is information that you cannot find in Google. This is information that is provided by the clinic. So in this case, we have different sources of information. It can be a lot of different sources. Different source of dynamic information, different source of static information. For example, we have the combination between textbook and list of drugs and internal procedures. This combination, interestingly, can be additionally mixed with our first approach. We have the application that is communicating with the Snowflake Cortex. This is the LLM. We have the initial embedding, but we also have a separate embedding for every single use case. So we are not only going to attach metadata to a specific chunk, but we are going to create a completely separate sources of information, completely separate memory banks that can be asked additionally for some question. And for example, we can ask, what is the cost of a surgical procedure for so-and-so breed of dog? Versus what is the cost for surgical procedure for a dog that is named in particular way. The first case, I am asking a general question about a breed of dog. So for 10 kilos of dog, for 12 kilos of dog, for larger breeds, smaller breeds, etc. On the other hand, I am asking question regarding a particular patient that is that we are currently dealing with. So the dynamic data can actually go through different sources in order to find the best case. And this is actually the hard part when we are trying to fine-tune, because separating the extremely different information into a memory bank usually poses a challenge when we actually merge the end result. So usually we are trying to optimize. The optimization happens when we are dealing with so-called summary reports. Every single source of information is also collecting a summary of this information. It's going to be a light lookup table that is going to give us information or the answer of the question, yes, this is the right source for you, or no, this is not the right source for you. The customer is actually asking for something completely different. Because the surgical memory bank containing information about medical books can have some overlapping with internal procedures. For example, in the textbook, we can read something like, you need to make an incision starting from the second rib. But our internal procedure is telling us, no, we are starting from the third ribs because this, this, and this. So when we are asking question, always the internal procedure is going to be the main source of information. But our LLM needs to know this based on the summary report. Also, we can introduce agents. Snowflake Cortex gives us ability to spin different MCP servers or different agents that can actually, in parallel, check our sources and give us the answer of the question, yes, this is the correct source that you are using at the moment. In conclusion, it's a complicated topic. As I mentioned, we only scratched the surface. I've shared with you an idea, a practical use case that I'm dealing the last couple of months. And if you have more questions regarding how we've built it, what was our assumption, and how to actually approach something like this in your own project, you can find me after the lunch and we can talk about this. So thank you very much for your patience. And we have 10 seconds for questions.
Shall we get started? Yay. All right, I think we lost half the audience from this morning. I blame the Serbian joint there in their rakia. So I guess all of you who are here did not have the pleskovica or rakia. So I was preparing for today and I was like, okay, obviously I have the toughest slot today to try to keep everyone awake after lunch. And of course, I was looking for some help with from ChatGPT, and there were like a couple of suggestions. One of them was to perform something. I'm not good at that, so I'm not gonna sing, I'm not gonna dance. The second suggestion was, okay, so try to engage the audience with some questions and ask them to clap or stand up or something. So I'm not gonna do that neither. I will jump ahead to the third suggestion, which I think was, well, much more plausible and will do the trick. Engage the audience by sharing a crazy number. By 2031, the OLTP and analytics market will go beyond $1 trillion. Can you imagine how much is that? I mean, it was difficult for me because it's just a number. Definitely a number that I don't have in my bank account, so I have no idea even how many zeros are there. So I tried to kind of relate it to something. So if you're fans of, Banitsa and Buza, this is like, what's that number? 400 million or billion? Billion. So we are in a 1 trillion market, so this is billion. And so I calculated this, by the way, with today's stock exchange, not stock exchange, but what's the number? Exchange rate for, left to USD. Then if you consider an average price in the US, that's like 200 billion beers. And looking at the prices of garage sales in Sofia, this might be like 5 garages in Sofia in 2030. So. All right. You are awake. Cool. So let's get to the topic of my talk today. Is Databricks ready for mission-critical OTP? Who knows about Databricks? Oh, okay. Surprisingly, a lot of people. Cool. Great. So, to save everyone's time, nope, it's not. Now, if you're a manager or decision maker at this point in time, you might decide not to listen to what follows. But for all the other people who are interested, and geeks like me, why Databricks is not yet ready? Where is the industry going? That's my personal view. I mean, I'm not being sponsored by Databricks, and that's definitely not something I would say I've read or I've seen an official report of. So all personal, what's the word? Observations. So before we get to the reason or where the industry is going, I'd like to take you back probably 40, 50 years ago and just remind everyone what an OLTP is, what OLAP is, what is the modern data analytics landscape looking like, and then hopefully I'll be able to compare things and you'll be able to understand where exactly are we going. So OLTP. Online transactional processing, a term defined probably 40, 50 years ago. It's describing those systems which take care of the day-to-day operations of line of businesses. These are point-of-sales applications, these are CRM applications, these are those applications that take your orders online and whatever. These are the applications that generate the income, let's say, of a company. Oh, sort of say. Their purpose is to be fast, highly available. They have to be protected. I mean, can you imagine not being able to access your mobile banking? I mean, these types of applications are OLTP-based applications. They have to have millisecond performance. You can't wait for 20 seconds to get your bank statement. or to do, you know, a bank transfer, they have to be typically highly normalized. You know, everybody probably learned in the university first, second, third normal form. I know there is fourth, fifth, and sixth, which is only in the notebooks. I mean, I haven't seen it being used at all. And most of the times, OLTP systems are for structured data. Meaning, you have tables, you have to know the schema before you write into that table. You have to know the data types. You have to have primary keys, foreign keys, indices, and so on and so forth. OLTPs typically have, in order to secure high availability in disaster recovery, you have to either have it in a shared storage environment with high availability cluster on top, or some kind of replication, being data storage replication or database engine level replication. This is OLTP. Now, in the OLTP world, if you want to do analytics, you can't just run it on top of your operational database. I mean, I've seen a lot of people in like today, when we were back at HP, DXC now. So one of the main challenges there was figuring out performance on top of big SQL servers or big oracles or whatever, where you needed to have both application and OLTP workloads and then analytics workloads. So back then, the industry was doing, okay, so OLTP is here, we need to move the data out, denormalize it, implement some kind of clustering, indexing, and so on and so forth, so we can run our big analytics queries. Cool. That was good for, I don't know, probably 10 to 20 years, when you had your reports running on top of your structured data. But then the cloud came, data started to grow up. By the way, I think there was some statistics that probably 70 or 80% of the data that organizations collect is dark data. So meaning they collect it, but they are not really using it. So one of the big reasons was, well, we can't access it in an optimized way, or we can't analyze it in an optimized fashion. So then the data lakes started emerging. Data lakes in the cloud, you push whatever you have, whatever you like, and then figure out how you want to run on top some analytics. At that point in time, if you still had your data warehouse, you have to feed the data to your data warehouse from that data lake. So one ETL to move the data to the lake, and then another ETL to take it from the lake and push it to this data warehouse that you have. This is what most of the companies did. And if you're running data science or machine learning, then you run it in parallel, and you take data both from the lake, semi-structured and unstructured data, and some structured data from your data warehouse. Cool. But if you've been managing such kind of environment, you know this is a nightmare to manage. I mean, where is the source of truth? Is it in the lake? Is it in the data warehouse? Who owns the metrics? Is it the data science team, or is it the data warehouse team? How's the governance done? Where are the permissions? This whole thing started to kind of, well, generate problems for the industry and everyone that was moving into the cloud data management space. Hence, the lakehouse emerged. Lakehouse as a term, if I'm not mistaken, Databricks came up with that original term. And what they said is, okay, store your data wherever you like. We'll put on top some governance, and you will use the lakehouse as your single source of truth for whichever workload type you have, being that BI, being that operational reports, being that data science or machine learning or Gen AI applications for that matter. Cool. So lakehouse. This was the new kid on the block for at least a couple of years. I think it still is, by the way. Now, the lakehouse is based on an open source format called Delta. How many of you have heard about Delta? Okay, so pretty much everyone who was working with Databricks or heard about Databricks. What is Delta? Delta, again, as an open source format, it was developed by the Apache organization. And traditionally, if you look at the right side of the presentation, Role-based storage, which is Oracle, SQL Server, Postgres, all of those engines, they store data as a raw format. And if you need to extract a single row, you just have to extract that physical piece from the storage. But for analytics, this is not very efficient. Because if you need to just aggregate one column out of 50 in your table, you have to read the entire table to just aggregate this one column. So Parquet is actually columnar storage, which says like every single column will be stored separately. We will run compression on top, encoding, compression, and so on and so forth. And if one needs to aggregate something, they will have to just read that physical piece of data. So for instance, if I need to do an average of age, I just need to read that greenish piece of physical data, and I'll be done. I wouldn't have to read all these other columns. So on the left-hand side, the role-based storage is optimal for singleton lookups, inserts, and so on and so forth. On the right-hand side, we have the columnar storage, which is good for analytics. So it's really fast, but on the other hand, if you need to do a singleton lookup to a columnar storage, that's a very expensive thing. It's again reading all the columns and figuring out which column, which row from that columnar piece belongs to that particular wider row. So we ended up in being either an OLTP system, which is row-based storage, or columnar storage, in this case Parquet. The same applies, I think, for ORC, which is the Oracle format. And Avro is not like that. So Parquet is generally the synonym of columnar storage these days in the cloud analytics space. So you end up with OLTP versus OLAP. And if you need to do any operation that is not native to that particular row storage, meaning singleton lookup versus analytical query, then you're doomed for a performance. You almost always have a performance challenge and performance issues. So how do you handle things? Well, you just start moving data. If you're going to do OTP, split it into one RDBMS. If you're going to do analytics, move the data to analytics space and do dedicated tasks there. So that was like probably a year ago. And almost all organizations that I've worked with or that I talked to have been moving data from OLTP to OLAP and the other way around in order to satisfy performance and management challenges. And the industry right now is trying to solve this problem. Okay, how can we have a single platform, a single system that can deal with both type of workloads without this performance penalty? And I'm not entirely sure if Databricks is the first, but they're definitely one of the pioneers. And probably you're also wondering why on a Postgres-focused conference we have a Databricks being presented. Well, before I talk about Databricks and Lakebase, I have to talk about a company called Neon, which developed probably the first, decoupled storage from compute on Postgres. So essentially, you have storage, open source format, in any cloud-based storage, and then on top, you have a decoupled compute, so you can run and scale as much as you'd like. This also brings you the ability to have serverless, meaning you don't have to run your own hardware in your own cloud subscription or hyperscaler subscription. You can run it anywhere. Because it's open source, it's not a vendor lock-in. And the product that these folks developed, I can't remember the name. So was it Neon? Yeah, okay, so Neon was the product. Now, Databricks, I think, merged with Neon or both Neon or invested in Neon. I have no idea how these things are happening these days. acquired Neon 6 or 7 or 8 months ago, and this got rebranded into Databricks Lakebase. And I think that's the first platform that actually brings OLTP capabilities into an analytics platform, which means that in a single platform, in a single solution, you can have either of those two. That's, I mean, a very good promise, at least. And what is another very innovative thing, I think, that I haven't really seen anywhere else is the ability to branch your database. How many of you have tried to figure out DevSecOps for database schemas? Only one? Were you successful? Any challenges? 90% successful, 10% I want to stop doing things. So with Databricks Lakebase, you're able to run an open source Postgres on top of your Databricks as a managed service without provisioning any infrastructure, clicking or, well, scripting things in the platform, and getting the benefits of running an OOTP grade performance applications. Cool. Yeah, but that's all marketing. When I heard this, so these were actually slides from the Databricks and Data and AI Summit back in June in San Francisco. And I was like, okay, so I have to present this topic. I have to figure to play with this thing. And when I started playing in the platform, it turns out that I can do only, I don't know, 20% of what was promised on the conference or what was announced on the conference. So sorry, I'm not going to be able to show you the branching and the Git-related stuff, but I can show you how can you deploy a Databricks, a Postgres instance as part of your Databricks environment, and how you can run your applications or analytics workloads on top of that. So, right, there are a lot of things here, and I hope you can see properly. Cool. So, what I have here is a Databricks, traditional Databricks workspace. This is something, if you have Databricks, this is absolutely the same thing you can see today if you open a Databricks instance in your office. On the left-hand side, I'll have a catalog. Let me just quickly start it. So I have one catalog, which is essentially, you can consider this a database. So I have a database or a catalog in Databricks that hosts my Postgres data. And I have here one synthetic catalog. So I'm using one synthetic data we have to generate for one of the performance evaluations back at the office. And we are looking at, I don't know, the table that I want to show you and how I want to, the demo that I'm going to do is a table like 32,000 rows, not too much. That is stored in both Parquet format, but also Postgres, running also on Postgres. So first, how can you create or copy your data into a Postgres instance? If you go to compute, lake-based Postgres here on the right-hand side, you just create a database instance. You basically have to point out just the name, how much you want to pay, how much you want to scale, and then how much more you want to pay. And you can configure some things like copy on write. This is copy on write. Oops, sorry. Create from parent is copy on write instance, meaning it's practically your production data, but copied. And it's not the Git branch thing, but it's something it's still you can use for development purposes. And you can enable for high availability. So far, no DR. To be honest, I have no idea how to do DR for lake-based Postgres. So that's one of the reasons that this is not the mission critical ready yet. So I create this instance. I already have one that is running. You can pause it anytime. You don't need it. So it's practically pay as you go. Well, not pay as you go, but pay as what you use. And you can even automate this. You don't necessarily have to run it 24/7. It's not very different than any other cloud provider anyway, but still something that you can do, especially for development purposes. The version 16, you can't really manage the versions. It's managed automatically by Databricks for you. So you run with basically what you get is what you see here. Very little, at least as of what I know, very little flexibility on what kind of configurations you can do. But these are the benefits of running a managed service versus, run it on your own. So I have this instance. Now, actually, let me show you first some performance stats. So I have this table, one fact table in Databricks, in Lakehouse, or in Delta format. And the Delta format is the Parquet files, if you remember, so columnar storage. If I run this, so I just started the Lakehouse, so no cache, nothing. If I run it, okay, so it was supposed to run for 4 or 5 seconds, but anyway, for a singleton row return, close to 2 seconds is still a lot. So this is retrieved from the Parquet files under the hood, and this is how the performance is looking like. So if you look at this, total of 2.5 seconds were spent to return the result. And 95% of this time was spent into optimizing the query and pruning files. What is pruning files? Basically figuring out which physical file, Parquet file, to read from the storage to return that row. Now, there are different techniques where you can optimize this, but this is 100% of the cases where the time is spent on query execution. Oh, it's 90%, not 95, as I said. And then the execution itself, you can see, it's just 56 milliseconds. So at this point in time, the bottleneck seems to be the storage for a singleton lookup. Now, if I want to see the query profile, oh, this is cached. Why are you cached? I restarted the server. Anyway, so essentially this goes through around 1,000 files, Parquet files, to figure out which one to read, and then push it to memory, and from memory retrieve this one row. Now, for an OLTP application, this is a nightmare. I mean, if you get 2 seconds for a singleton row to be returned, then your application will start getting locked. You start having performance challenges, deadlocks, and whatnot. Now, let's do the same on the Postgres. So I'll just do absolutely the same. So it's, what's that, half a second. Still not less than 10 milliseconds and stuff like that. But I mean, it's a public preview right now. So hopefully it will improve. But that's already way better than what we have for a typical lakehouse operation if you have to do. So, cool. One of the other things that's very important for OLTP is being able to run transactions and have ACID compliance. Atomicity, consistency, isolation, durability. So all these things theoretically were available for Lakehouse pattern, and with the latest advancements of Delta format. However, it was still tricky because you work ultimately with files, not so much with memory, and there aren't many things you can do behind the scenes to optimize this pattern. So even though you had ACID compliance on Delta, it's still challenging, not only for the performance, but also for the consistency of your data. So if I run, I don't know, a bunch of inserts, which typically in a lakehouse might take, I don't know, several seconds, up to 10 to 15 seconds for this example. If I run this, I only get probably, again, less than a second. Where's the stats? Yeah, less than a second here at the top. See? 12 milliseconds. Or no, that's not 12 milliseconds, that's 120 milliseconds. So inserts work fast. Good. So we have the fast retrieval, we have the inserts. What about transaction handling? So let's say instead of a number, I insert a letter here. Yeah. Let me run this, and I'll have a question for you. When you see the result, do you notice something strange in this error message? Come on. Yeah, it says the column A does not exist, but A was the value that was inserting in that table, right? So that error message right now is not really the best. So it can get you confused. So be careful. But again, this is not production ready, so don't deploy anything in production. You know, you might suffer. And what if I want to do traditional analytics? I can still do it. And for typical report, like operational report things, it's still fast because it's reading row-based storage. Now, if this data starts growing, this type of query, when you have to aggregate a lot of data, is going to be slow, much slower. So at some point, there is a tipping point where you need to switch to an analytics engine. So how do you switch from a Databricks compute, or how do you switch between Lakehouse and Lakebase? So Lakebase was the OTP, Lakehouse is the OLAP kind of a workload. If in your OTP application, you need to synchronize something that exists or move something that move data that exists in Lakehouse, you would need to do an ETL. But what Databricks did is they simplified this for you by automatically allowing you to synchronize these tables from the Delta format to Lakebase. And it's as easy as finding your table, let's say this one, and click create a sync table. So what you have to do is you have to choose your database instance, which is the Postgres instance. And then you have to define your sync mode. You have snapshot, triggered, or continuous. Behind the scenes, this creates a Delta Live table or DLT pipeline, or I mean, I think it's a different name these days. But anyway, snapshot means you're gonna take snapshot of that table and rewrite every day. Triggered means every 5 minutes get the new data and move it over, and then continuous means you're running as a streaming job. So the difference, essentially this defines how much you're going to pay, obviously, and how fast you're going to get your data to Postgres. But if you need to run a workload on your OTP application that requires data that lives only in your lakehouse, this is the way to do it, not by creating ETL jobs or something else. Let Databricks deal with this for you. Okay, so what if I want to run my analytics workloads and get data out of Databricks, of the Postgres? In this scenario, so that's the reverse scenario of what I showed you. So in this case, you don't even have to move the data. Databricks has this thing called Databricks Federation. So essentially, you run it against your Spark cluster compute, but the Spark cluster compute sends the query to the back engine, which in this case is the Postgres, transparently for you, gets the results, and present them to you. So for instance, if I want to run this same query, but instead of the lakehouse, I want to switch to data stack catalog, goat. It was synced fact landing. Right now I'm using the Databricks Spark compute. So this is the SQL warehouse compute. Let's hope it works. Yep. Even though the data lives in the Postgres, I'm still able to run it in my analytics queries. This means also that I can run it with my PySpark, with my machine learning training algorithms or whatever. So this whole thing kind of starts converging. What else? Cool, so we showed this, transactions, we did inserts, we failed a transaction, and we did analytics query. All right, so I'm gonna spend some more time on this slide, and prepare for questions. I think I have 7 or 8. I will have 7 or 8 minutes for questions and an open discussion. So, industry right now is moving towards convergence of traditional transactional processing systems and analytical systems. With AI and agentic AI applications and all these I don't know, fashionable terms these days, it's extremely important to have your data accessible through a single platform. The less you do on moving data, the more you win on maintenance, keeping your data as close to the source of truth, and also getting the proper results. And I think all the big players on the market will move into that space, and they will want to grab this OTP market, which, how much was it gonna be in 2031? 5 garages. So 60 billion in US dollars in 5 or 6 years is gonna be the OTP market. So essentially the big analytical engines will try to grab that market and integrate as close as possible. I don't see the other way around happening as fast as the analytical space is moving. So if you need to figure out a strategy right now, think about this scenario. What is Lakebase good for? Well, obviously, to talk on conferences about it at this stage. In 6 months, probably it's going to be even more. It's not yet production ready, but when it is, you should think of using it for, first, application prototyping, faster development, because Databricks also offers you Databricks apps, which essentially lets you run any Node.js or Flask or whatever. I think there were a couple of other frameworks supported. You can just run it on top of a single platform. Forget about functions, Azure Web Apps, or whatever the alternate is in the other hyperscalers. Besides fast prototyping, a lot of the agentic solutions these days need fast access to data for singleton lookups. I mean, in term, what was the term? When you have to have online feature table available constantly, so that whatever prediction algorithm you have, it has to have real-time inference. You can't simply do this with keeping your data into a lakehouse. I mean, can you imagine waiting for, I don't know, 10, 15 seconds to get a recommendation? You would like that recommendation immediately. Imagine you're running on the stock market. Can you wait 15 seconds after an event to get a suggestion? No. So for machine learning scenario, agentic AI, all those features that require real-time inference, you want to consider the Postgres engine. I think that was one of the core reasons for this to be brought into Databricks. Before that, Databricks had their own Databricks online online features feature. Oh my God. But that didn't really work well. So they decided to bring in Neon to help with the manageability part and the cost part. Analytics. Obviously, you want to run analytics and have some master data living in, I don't know, in some MDM or RDM, reference data management systems, that do not necessarily will be in lakehouse format, in Delta format. In those cases, if you need faster lookups, faster joins to nomenclatures and reference tables, you want to use Postgres. One not very popular application for for the lake-based Postgres, but still very useful, is serving data, or allowing applications, external applications, to get data out of Databricks for whatever reasons that they might need them. Imagine you're keeping your entire data estate into Databricks with Unity Catalog, including federation and whatnot. And you have downstream applications who consume data for either analytics or some predictions, like real-time inference, or they need to, I don't know, get the data through an API. All this is supported by Databricks. But how are you going to meet the performance? Lakebase is the feature that would allow you to meet sub-second performance for all those singleton lookup scenarios. Imagine that you have an application that needs to do a REST API to get, I don't know, the salary of a person by his ID, right? In a Delta format, that's not going to be fast enough. You typically expect less than, I don't know, a second performance. With Lakebase, you can achieve this. So you can use this to actually serve your data out without buying third-party product to virtualize your data or to just expose it as an API. Obviously, you can use fast API or whatever else is available on the market, but that just complicates your architecture. If you don't have that much of a demand in terms of performance, like for instance, for medium queries per second, medium scale queries per second, and not so low latency, then Databricks and Lakebase can meet these expectations. Where I don't see Lakebase to be helpful, definitely not mission critical OLTP, where you require high availability and disaster recovery. It's still a managed instance. Managed services are great when they work. The moment they break, it's a nightmare to recover. If you need to run secure, highly regulated applications like HIPAA, FedRAMP, and so on and so forth, Lakebase is not yet ready. So I'll pause here. We have 7 more minutes for any questions. Oh my God, no questions? Really?
It's not that bad if no questions. I mean,
no, okay.
This means no one understands anything, or everyone understands everything, right? So
yeah, I doubt that I explained things that good, so everybody understood everything. So I guess people are just shy.
Wait, can you ask on the microphone so it will be on the stream? To be on the...
I still didn't understand. Are you working for Databricks or not? Are you affiliated person or not? Or you are like very good independent specialist making review?
Okay, cool. I am not working for Databricks. I am not affiliated with Databricks. I run, actually, yeah, so these are my contacts. So right now, my day job is I work at the World Bank in the Sofia office, and we deal with data platforms. So Databricks is just one of the things me and my team run, and that's how I get my experience with the platform. I also run the Databricks user community, because with the rest of the founders of that community, we believe that knowledge sharing is the key to succeed, especially when well, there is so many online sources that you get confused sometimes what to read from where, and if that's even true, what you read. So to answer your question, again, no, I'm not affiliated with Databricks.
However, I can ask because I'm one of the Java user group leaders, and I had like, I don't know, 6, 7 clients about Java just indirectly because I'm involved. So sometimes when you share or when you participate in a user group, this means that you might get consultancy opportunities or some other opportunities. So there is a value even if you are not directly involved with Databricks. So that's why most people should join some user group, depending on the technologies that they like or they use or they want to use. Any other questions? Nope.
Okay,
Okay,
I guess I
thank you.
could have had the 30-minute slot, not the 45. But anyway, so thanks everyone. My name is Ivan, and I hope you enjoyed the session.
Thank you. without more delay, I want to welcome Lubomir Tulev on the stage for the next talk.
Thank you very much.
Yeah. Thank you for being here.
Къде е само кликърчето?
Нямам идея.
Това е мое.
Спейса, не знам. Може би някой лектор го е завлече.
Добре, аз имам само една секунда, ще взема моя кликър за секунда.
Някой да знае на кликъра къде е джаджата, не дистанционното, а другата част, да не е някъде отпред. Фал старт. Чакай, намерихме.
Намерихме ли?
Да.
Добре.
Тук трябва да дадеш обаче...
Чакай обаче.
Вау.
Да.
Затвори го това просто. Да, виж сега трябва да бъде.
Да.
Окей, почваме. Окей, Любомир, second try.
All right, so hello everybody. 43. An interesting number. Does anybody know what exactly 43 means in the cybersecurity world? Maybe not. The year is 1984, 82, indeed, when RSA as a corporation has been built for the first time. And this is considered as the first product in the world of cybersecurity. In the next couple of years, a new antivirus solutions has popped up on the market. And since 1982 till 2025, we have 43 years, which basically means that our industry, cybersecurity, we can say is more or less 43 years old. Why this number matters? We all know that the gender population basically switches every 15 years. So 43 years of existence of the cybersecurity and 15 years of changing the generations brings us to the year where actually we're now in the third generation of cybersecurity. And this is important simply because every population, every generation tries to look back to see what has happened in the past and to change it, to make it differently. Well, in general statement, today's talk is about the cybersecurity generations. What is the trend now? What are the modern cyber attacks? And what we can do better compared to the previous generations. And I want to ask you in the next couple of minutes to join me on this conversation. Should you have any questions, I would like to have as much as possible at the end of my presentation. Hello, everybody. It's a great pleasure to be today here on the stage in front of you. My name is Lubomir Tulev, and I'm a founder and executive officer of Cyber Experts. And in the next couple of minutes, we're going to see what are the current cybersecurity trends, statistics, modern cyber attacks, and how we can actually protect against them and make our organizations resilient to cyber attacks. So, speaking about the generations, what actually is fascinating me and many of my colleagues in the field is that no matter if we are changing in the generations, still we see all in the same kind of problems, kind of issues, kind of attacks. We're still talking about legacy systems, not patching systems, default passwords or password reuse, SQL injections, cross-site scripting. So we are seeing again and again and again the same issues, the same problems with the previous generations actually they had. And you might think, all right, it's really embarrassing why we are changing in the generation, why we're changing our security approaches, and still we have the same issues and the same problems. So you might think nothing is changing, but indeed, it's not right. A lot of things has been changed in the last couple of years. When we're talking about cybersecurity, everything is about the risk appetite. Everything is determined around the risk. And when we talk about technology vendors, suppliers, and adversaries, and the way how they contribute and influence each other is determining the cyber risk. So let's take a view what has happened in the last couple of years, in the last generations, in terms of the risk and those three factors. Technology vendors, as I said, our industry is considered to be 43 years old, starting from 1982. So what has happened with the technology vendors? Most of the technology vendors has changed a lot. Take a look. We had in the past antivirus solutions, but antivirus solutions were not enough for these days, simply because the antivirus solutions, they detect on a signature-based detection. It means that if you have created a new zero-day exploit, which is not known to the antivirus suppliers, antivirus providers of the solutions, simply you cannot detect it. Then it means that you have to be focusing on the behavior on analysis of this zero-day, which basically brings us to the point where antivirus has been switched to EDR, endpoint detection and response. And EDR solutions, somebody are calling them antivirus on steroids, simply because you are now checking the signature-based of the malware, but also you are inspecting the behavior of this malware, potential malware. So a lot of things with the technology vendors has switched and has changed. The other big thing with the technology vendors are the migration, the switch from on-prem to on the cloud, data storing and data and computing. Meaning that you are actually enlarging and opening your attack surface. In the past, attackers, if you have your organization fortified strongly enough, then for the attackers it was heavily to get inside, to infiltrate into your organization. But now, due to the COVID pandemic situation, a lot of organizations started migrating to the cloud rapidly, which basically opened the attack surface. So now the attackers, they don't have just a single infrastructure to attack. They can attack a wide range of publicly accessible assets of your organization. And lastly, speaking about the technology, the last thing what has changed in the last 4 years already, although in the cybersecurity world, and especially you guys, we know about machine learning and artificial intelligence many, many years ago, even before the rise of ChatGPT. But for the mass authority, for the mass users, ChatGPT basically was the first start with artificial intelligence. And with the rise of AI and machine learning, we have seen that the integrity of the data became really important, crucial. The data which basically is used by the machine learning and artificial intelligence algorithms to process and to generate data. And talking about the integrity, this basically brings me to this very famous triad pyramid in the cybersecurity. It is so old, maybe like 43 years old, I guess. So this is the triad between the three elements of the cybersecurity: the confidentiality, integrity, and availability. Very briefly, what does it mean? Confidentiality means to keep your data in safe, to keep your data in confidence, so that nobody else can access the data unless you're authorized to access it. The second element, integrity, means to keep your data unmodified, unchanged, unless you have the right to change the data. And lastly, availability. To make your data available to those who need it right now, all the time. So those three elements are important to be protected all the time to keep your data safe. Of course, for some organizations, one or two of the elements of the cybersecurity are more important than the other. Take a look at Netflix, for example. For Netflix, taking the movie, downloading it somehow, it's not such a big problem. Okay, it is. It's violation of the intellectual property rights and etc. It is, but does this stop the business of Netflix? Not really. But availability is the element which basically will stop the business of Netflix, because your your platform, your website will not be accessible to those who actually need to watch the movies right now. On the other hand, for the banks, obviously confidentiality of the data, so to keep the bank accounts and the amounts of money and etc. for their users is a top priority, together with the integrity. Well, availability is important too, because if the business cannot make their online payments, it's also a big problem, but it's not so big as the confidentiality and the integrity. So see how important these three elements are, and they are differently important for the different organizations of their business. So speaking about the AI and machine learning, integrity is very important, because your AI algorithm is basically generating your responses based on the integrity of the data where this has been used for analysis. The second element of the determination of the risk is the service suppliers. So if we have the technology vendors and how they have changed, the service suppliers also have changed in the last couple of years from the previous generation. And talking about the service suppliers, just to imagine, these are the mobile operators, these are the internet service providers, these are cloud computing provider companies, and etc. And this is very important in the perspective of our businesses being so interconnected and so dependent on somebody else. Simply because, again, you cannot be just a single fortress. You have to communicate, you have to work with some suppliers, external entities. Some organizations are outsourcing their accounting, their travel agents, and etc. Some are even outsourcing IT and cybersecurity support. So you see how the suppliers are very important, and you're going to see later in my presentation how supply chain attacks are one of the top trendy right now. And again, yes, it was a topic when we talked about the COVID pandemic situation, but remote working is, well, in some organizations it's still a topic, the other has totally forbidden, the others are totally hybrid or open, doesn't matter. But the question is, once again, as you're opening your organization to be interconnected with suppliers, the same way your employees who are working remotely are always an entry point for attackers. Because the attackers now, they cannot, once again, have only a single infrastructure where to attack. They might attack every single employee remotely working. Which, as I said, basically brings us to the issue of the supply chain risks. How we can mitigate this kind of a risk? There's a framework, a concept called ZTNA, Zero Trust Network Access. Zero Trust Network Access basically is a methodology, it's a framework, it's a concept where you are considering every request, every entity, everybody, device or user connecting to your infrastructure is unknown, unfamiliar to your organization, and having inspection every time on the requests, on the entity, on the user, etc. And last but not least, adversaries, so the hackers, the attackers. They are also changing. They're not a constant. The way how the technologies and the suppliers and everything is changing, they're also changing. And when we talk about attackers, there was a misconception in the, by the way, I forgot to mention, I'm an ex-law enforcement. I have been working for over 7 years with the GetABOP, the Bulgarian version of FBI for those who are not from Bulgaria. So, yeah, and working there, you know, there was a kind of a stigma when companies are coming to report that they have been compromised or under attack. And you know, all the other companies, they were, this has been hacked. Nowadays, it's not a problem to be hacked. I mean, okay, it sounds really strange, but the biggest challenge is to be such a mature organization so that even if you are compromised, to be able to recover as fast as possible. This is the level of maturity which we are now seeing nowadays. Not the stigma that, okay, you have been compromised, you have been hacked, but how fast you can recover. And the same way with the hackers. There was, as I was saying, there was a misconception in the beginning when, you know, when you say hackers, you were thinking of, you know, isolated individuals hacking. Not anymore. The hackers group are well-structured, well-organized crime groups. And their leaders are driving Lamborghinis around. And when I'm saying, by the way, this is really the guy behind the Evil Corp hackers group, very famous Russian group of hackers. So as I was saying, they're nowadays really organized groups, the same kind of our companies, of our organizations. They have the boss, they have project managers, they have HR. We have identified many, and okay, maybe, I don't know how, I'm gonna share it. We are infiltrated in some of the hackers groups of, you know, hackers in Telegram, Darknet forums, etc. So from time to time, we are analyzing their behavior and their patterns. They're even requesting a PTO, personal time off. So they're requesting, hey, I'm gonna be off the next days. So as I said, they have a very, very strong organization of boss, project manager, HR, the guys who are attacking, the others who are making the negotiations with the victims, and so on and so forth. They're not just standalone, single, individual hackers anymore. And not forget that even some hackers organizations are very close to the states where they're actually located. So we are talking about a special category of hackers groups called state-sponsored hackers. What does it mean, state-sponsored? It means that the country, the state, is behind them. They are protecting them. Why? Because for those countries, it's simply a GDP income for their countries. Traditionally, countries such as Russia, Serbia, by the way, is coming very, very popular in the sponsoring their hackers. But usually Russia, Ukraine, Iran, Iraq, North Korea, China are those suspected, you know, to be state-sponsored hackers organizations. And speaking about, again, the state-sponsored and my background as a law enforcement, believe me, I'm talking from the personal perspective. We have been identifying a lot of hackers, and when we were sending requests to Russia, simply we did not get any answer for them, because they just don't want to mess with the hackers. For them, it's a win-win. It's a GDP. They're hacking bad companies in the West and taking this money in Russia, obviously. And on the other way around, they also are hacking, making this cyber warfare against the enemies of the state. So let's bring now your attention to some numbers. I'm a fan of numbers. 10.29 trillion. It sounds like a big number, huh? Isn't it? This is, colleagues, estimated to be the cost of the cybercrime for 2025. It means all the direct and indirect costs and expenses based on the cybercrime in 2025. If you take a look at the progression of the numbers in the last couple of years and in the future next, you're going to see that almost every year we have around 1 trillion increase of the cost of the cybercrime. Just to bring to your attention, to imagine it, to map this number, the GDP of Bulgaria for 2025 is estimated to $117 billion. So 10.29 trillion is exactly 88 times, which means that the world economy will lose 88 times the GDP of Bulgaria this year. The average data breach cost for this year is estimated around $5 million per data breach. It includes the cost for recovering of the data, of recovering of hardware, paying some sanctions, and etc. 87% of organizations suffered a cloud data exposure in the last 1 year. And the ransomware downtime average is 24 days, which means that and we're going to talk about ransomware in a bit, but every ransomware attack basically locks your company at least on average for 24 days. And when we talk about such a big numbers, it reflects on the geopolitical agenda. And it brings the cybercrime topic in the political agenda between the world leaders. We're not longer talking about if we'll be attacked, but how fast we can recover, as I said. And speaking about influencing the world and political agenda, the cybercrime, Europe definitely is one of the leaders, I would say even the leader worldwide for making a lot of, trying to, at least to make a lot of regulations and to narrowing down the cyber protection. Here's a comparison between how we are increasing the cost of the cybercrime and how many pieces of legislations has been adopted in the European Union in the last 13 years. Starting from 2013 to this year, we have 13 different cyber security related regulations adopted on the European level, which basically means that on average 1 regulation per year. So Europe is throwing a lot of efforts to protect, to organize the chaos in the cybercrime. All right, we are losing a lot of money, obviously, the world economy. Now the other question is, what we do in this regard and how we can respond to this? Well, through investments, right? So if we have an attack, if somebody is attacking us, that means that we have to protect. The world economy is estimated to invest in cybercrime as an industry this year, $300 billion. So now take a look. We are losing 10.3 trillion, but investing just 300 billion. Huh? Obviously, it's not enough. Obviously, it's not enough. But if the companies are investing a lot of money in cybercrime protection, they have higher expectations. Now, when I go to different organizations, different companies, and the CEO, the boss is saying, all right, Lubu, I give the money, I'm going to invest in cybersecurity, but I have a higher expectations. And the higher expectations means that you have to work and you have to invest in developing your experts. The world currently is lacking of 4.7 million unfilled cybersecurity positions worldwide. 4.7 million unfilled cybersecurity positions worldwide. It's an interesting topic, by the way, that half of this 2.5 million unfilled positions are in Asia. So for those who are investing, let's say, oriented people, investing in cybersecurity in Asia now turns to be an interesting topic because we have 2.5 million unfilled requests for positions in this region. So speaking about the regulations, speaking about the certifications, as I said, the organizations, the companies have higher and higher expectations. And that's why we have certifications. In cybersecurity, such as also in the other industries, I guess, we also have certifications. Actually, we have a lot of certifications. Well, actually, I have at least half of them, but that's another topic. The question is, you have to invest a lot of money and time for your people to certify them, to train them, which costs you money, but also time. It's not like I don't know, a software developer. I'm not offending anybody, but with the software development, usually you can, I don't know, spend 2-3 years, I guess, to learn a language, to start programming. Of course, for the seniors, it takes a little bit more time, but you can have a experienced cybersecurity really expert within just 2 or 3 years of experience. He or she should have a bigger number of certifications and years of experience in order really to protect your organizations. And this is hard really for companies to find those people working only for them, especially when cybersecurity is not your core topic, your core business. Therefore, companies are usually outsourcing this service. So, no matter if you like it or not, the cybersecurity is moving fast, and it's a matter of you liking or not to be on the bus or not. And I suggest you to be on the bus for sure. A few words about the threat trends in 2025. Everybody's talking about AI, not just in cybersecurity, everywhere, but we cannot get rid of this buzzword. So obviously, as any user nowadays is using AI in his or her daily work, hackers also do the same. They use AI to generate attacks. We're going to talk about a special attack called 3D social engineering. You're going to understand what it is. But rise of AI-driven attacks in this year. Supply chain compromises. Why supply chain is so easy? I'll give you a practical example. You have your organization embedded with no matter what kind of security solutions you can think of. SIEM, SOAR, EDR, blah, 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 all the 3-4 letters of acronyms. Just think about it. You have everything. You've made a big fortress. But you're outsourcing your accounting to 2 ladies with 2 computers sitting in a small office having no idea about cybersecurity at all. For them, how they can actually do their business is just making the accounting. I'm not saying it's an easy task. The question is they don't just care about the cybersecurity. And this is the best for hackers. First, because they can easily attack them and through their RDP or other open ports can infiltrate into the organization. But secondly, this accounting company is not serving just a single organization, right? In most cases, they're serving 10, 20, 30 companies. Meaning that if I compromise, if I'm a hacker, in the past I was, but if I'm a hacker, I'm going to attack an accounting company because they lack of security, so it's easily hackable. And secondly, from this already hacked organization, I can sprawl and I can basically attack 30, 40 more companies and organizations. So supply chain, that is why it's so easy for the hackers now to attack. Data poisoning, again, in relation to the AI, machine learning, and integrity of the data. Cloud misconfigurations and AI-based phishing. We're going to reach at this point. I'm used to say that the worst time to test your defense is during a real attack. So it's better do it pre or that, right? So which are, in my opinion, the top 10, as the title of my presentation is titled, most modern, common, I would say, kind of a cybercrime attacks we are seeing nowadays. I'm going to start with ransomware. But the question is 3.0. Ransomware has, for the first time, started in 2011, 2012, where actually we have seen at GitHub the first case of ransomware in Bulgaria. In a nutshell, ransomware is a type of attack where the hacker, the attacker, is able to get inside of an organization to compromise a company. The hackers group are taking a look what is important, what is confidential there, exfiltrating data, sensitive data, then encrypting this data on the local servers, machines, infrastructure of the target organization, and asking for a ransom, sending an email or changing the background of the infected system with a message, hey, you have been compromised, we have your data, you have to pay the ransom in order to provide you with the decryption key. Paying the ransom is an option, but it's a very vulnerable option. We never recommend it. Because if you send the money to a hackers, do you have a guarantee that these hackers indeed will send you back the decryption key? Or you're gonna chase them in Russia? Okay, good luck. So yes, some organizations are going in that direction, paying really the ransom. And saying about the ransom, just to give you a glimpse of understanding, the ransoms usually are around 0.5 Bitcoins. And the Bitcoin today's are rocking, right? So 0.5 is quite a big number of a ransom. A very big group in Facebook has been compromised this Sunday, and they reached out to me. And they asked them for $100,000 for a ransom to give them back the group. So you can imagine what kind of numbers the scale of the ransoms are nowadays. But why 3.0? In the beginning of the ransomware era, the hackers were just simply entering the organization, encrypting the data, and asking for ransom without even exfiltrating the data. If you have a good backup solution, a regular one, then for the companies it was, okay, not a big deal. My data is encrypted here, I'm just loading the yesterday's backup, I'm pretty fine. Then with ransomware 2.0, the hackers started to be more proactive. They said, okay, now you're gonna see it. We're gonna exfiltrate your data, and then it's gonna be encrypted, and asking for ransom. No matter if the organization pays out the ransom or not, the hackers were still selling the exfiltrated data in darknet. So basically they were doubling extortion, double winning. But with the ransom 3.0, the ransomware attacks became even more devastating. Because the hackers, what they're doing right now, they're infiltrating your organization, exfiltrating data, and starting a script to totally destroy your data. Not to encrypt it, but just to delete it, just to destroy it. Why? It's faster. Instead of encryption, just a script to delete everything is faster. And secondly, they don't even give you a chance to recover something, to try to create a decryption key, simply because you don't have the data, right? So 3.0. Deletion. Ransomware as a service. Many hackers have created websites which are ransomware as a service. You simply log in there, you're paying 10% of your deal, of your target organizations, and you're getting everything as a service, cloud-based service. The malware itself, the decryption and encryption key, and etc. You don't even need to be a hacker to develop the malware. It's simply there. You just need to use it. So ransomware as a service. This is the 3.0, what is important with ransomware. How we can outsmart, how we can protect. Zero trust segmentation, as I mentioned about this, and immutable backups. Again, some numbers. 277. What is this number? 277 days. Any clues? Any ideas? Come again? Okay. Maybe. I haven't counted. 277, ladies and gentlemen, is the average day, or the average days, organizations are understanding that they have been hacked. What does it mean? Companies have been compromised today, and after 277 days, on average, they're going to understand that they have been compromised before 277 days. Almost a year. Almost a year, organizations need to understand, to realize that they have been compromised. Why does this happen? Because we don't have eyes. The organizations, the companies, they don't have eyes. They're not logging, they're not aggregating information, they don't have solutions such as SIEM. So if you don't have eyes in your infrastructure to see what is going on, it is becoming darkness. So, the unexpected darkness was uncomfortable, right? In order to have eyes and to not to experience this uncomfortability, we simply need to collect logs, to collect data, to aggregate, to see, and the results are very visible after even the first couple of days. We're talking about solutions such as SIEM, SOAR, EDR, different cybersecurity solutions which can collect logs and say, should we have a cyber incident right now to be able to see it, to be able to react it? Because as I have said, 277 days is the average range. Companies are understanding that they have been under compromise. Cloud misconfigurations, 79% of cloud breaches are due to misconfigured storage backup buckets. How we can protect against this? Continuous cloud posture management. It's a special kind of a cybersecurity service, which is basically looking your attack surface, what is publicly exposed, what is publicly accessible of your organization, because we may have shadow IT resources. A marketing team in your organization has decided to launch a marketing campaign in the past, but they have not even, blocked the website after the campaign has been over, and it's becoming a shadow IT resource because we have unpatched systems, some new vulnerabilities taking place there. So continuous cloud posture management and policy enforcement. API exploitation. I'm going to fast a little bit because I have a timer here and I want to be on time, but API exploitations. Again, in the perspective of the attack surface management, exploiting APIs, which is one of the recent reasons behind the breaches of LinkedIn and Facebook. So we're talking as a protection, API gateways, anomaly detection, risk privilege access and tokens. Insider threat. Many organizations are not paying attention. Usually, they have this mindset, and this concept. Only from the outside of my organization can attack me. No, actually, we have our employees, and some of them are disgruntled, who might also attack us from the inside, right? So the insider threats. 45% of the breaches start from inside. I'm not saying it's intentionally. Some employees might have clicked or whatever without even putting an attention to this. But 45% of the breaches starts from insider somehow. I want to bring to your attention sorry, I lost my voice. Thank you. In the last 2 years, we see a rise of a 3D social engineering attacks. What does it mean? Based on AI, hackers are targeting their victims from 3D directional approach, meaning sending a phishing email, continued with a voice solicitation, phone call, or text message, or deepfake generated audio or picture. 4 минути. Тук пише 7. Добре. So, yeah, I'm gonna tell you a very brief story. It took place 3 years ago. This was basically the rise of the 3D attacks. The manager of a Chinese branch of a bank based in Singapore. No, it was outside of China, in Singapore, I think. Yes. Received an email Sunday around midnight. In the email, it was written, hey, the mail was coming from his boss, the boss of the bank in China. Hey, I don't know if you're online, but you have to be, we have to make a bank transfer to acquire organization. And if we don't have the bank transfer right now, we're going to lose the deal. Please send to this bank account $17 million so that we can acquire this company. Of course, the bank manager of this branch in Singapore, of this bank, didn't believe in this email coming on Sunday at midnight, although it was pretending to be coming from his boss. Just a second later, a phone call with a spoofed phone number from the boss of his, from his boss, from the owner of the bank, called him with a cloned voice. Due to AI, it's so easy now to clone anybody's voice. We have seen so many deepfakes in the last couple of years, even here in Bulgaria. And the voice was saying, hey, I don't know if you have seen your email, but please do. It's very, very important. Sorry, I don't have so much time. We're going to talk tomorrow, but please make the wire transfer right now because we are losing the deal. I count on you, right? Okay, see you tomorrow. He even didn't give him the chance to ask questions or to talk. So what do you think this branch manager did? Of course, transmitted the money. He had the email and he had a phone call from the phone number, spoofed phone number, of course, but from his boss and with the voice of his boss. This is a perfect example of a 3D. All the different aspects of hackers are trying different aspects to, make their victims affected. Supply chain, I'm gonna skip this, already talked about this. Credential stuffing, identity attacks, very important. The hackers are on rise of a hunting of credentials. Believe me, hackers are even becoming more lazy and lazier. Many types of cyber crimes attacks we are identifying the last couple of years are due to leaked credentials. Missing multi-factor authentication, not changing your passwords regularly, reusing passwords. 86% of breaches involved stolen credentials. Because it's easier to log in instead of hacking. Fileless malware. When we talk about malwares, every day we have 4,330 something new exploits created every day, every single day. 4,000 exploits every single day. But fileless malware is something very, very trendy because hackers are trying not to leave any clues, any trails on the infected machine. A fileless malware is a piece of a payload, basically, which is injected directly into the memory of the system to create a special task requests from the hacker without even leaving any trails on the infected system. Many exploits in the IoT and OT. And business email compromise. Very briefly, business email compromise, 4 companies on average per week are becoming victims of business email compromise in Bulgaria, according to the last statistics of GetABOP announced a couple of months ago. 4 companies per week in Bulgaria, and the cases basically vary between 100K Bulgaria level to one of the biggest ones, which I remember, 17 million Bulgarian level, like 5-6 years ago. In a nutshell, business email compromise is when an attacker infects 1 or the other mail server, and just observing and monitoring for interesting email. Interesting, I mean email with an invoice, to be fast enough to change the IBAN in this PDF attached and to resend the email so that the other company is paying the IBAN, different IBAN than the ones which is the genuine one. Business email compromise. How we can outsmart the KIM, SPF, user awareness, transaction verifications. Generally speaking, old cybersecurity protection is totally different than the new real world threats. What we can do, we need to switch and to shift the mindset from defense to resilience. And saying resilience, I like the NIST cybersecurity framework, CSF 2.0 version, which basically says something very simple. No matter what kind of organization you are, public or private, small, medium, or enterprise, doesn't matter. If you make 6 categories of activities to identify your threats, what is threatening you, to protect against these threats, to make active monitoring and detection. Why? 277 days later, the companies are understanding that they have been even hacked. To respond as fast as possible to cyber attacks, to be able to recover as fast, as fast as possible, and to govern, to manage all of this process, then you are cyber resilient, then you are cyber good, right? So try to make all of these 6 categories of activities through penetration testing, managed extended detection and response, implementation of different cybersecurity resilience practices, backupping, awareness, and many. Yes, I have to.
And no time for questions.
No, yes.
Sorry. You have to find him to ask him.
You have my contacts. You can ask the questions if you want. You can find me in LinkedIn, email, phone. Yeah.
And I can share how you can get you can make the hacking even without hacking. Just send random invoices to the proper emails, and they usually will get paid. So
sure.
That's how Facebook and everyone works. Just find the right email and just send the invoice. That's it.
Yeah.
Okay, thank you.
Thank you for me.
Sorry. in a very tight schedule, so we should start. I will just start to speak. Hopefully people will join in time when Letitia is ready. I saw that she marked herself as Postgre woman. I'm Java developer. I consider myself a Java man, but usually the Java man is actually a skeleton of some being found on that Java island, which is the missing link between man and a woman. Man and a monkey. So I'm not sure what Postgre woman is, but yeah, Letitia will probably share, and I'm very happy that we have a speaker with a Linux, not this crappy Macs. So anyway, without further ado, whomever came. Letitia, the stage is yours. Thanks for being here.
Okay. Well,
is it working?
No, it doesn't.
Try now. Try.
Yeah.
Okay.
Oh, okay.
It's working.
Hello. I'm very happy to be there to talk to you about the PostgreSQL project governance. But first, if you've never been to one of my talks, you might be puzzled, because my slides are all about images without any word, which is great because people actually listen to me, which is what I want. I'm a mom. When I speak, I want people to listen to me. But it might be a problem because my accent might be beautiful, but might be also not that easy to understand. And you might have hearing problem. You might have attention disorder, or whatever reason might make it difficult for you to follow without any words. Also, I found out that sharing beautiful slide decks without any word was useless. So I provide an annotated version of my slide, and you will find it here. If you skip that slide, the QR code is also on the right-hand corner of my slide. I will publish them on LinkedIn and Blue Sky. Who I am. My name is Laetitia Avro, which is obviously French. And don't look at how it's spelled. This is a Latin spelling, so don't look at it. It's pronounced Laetitia. I'm a PostgreSQL DBA since 2007. My first work on Postgres was to try to create a syntax algorithm for Postgres for French tone name. If you studied a little French, you might know that it's a challenge due to so many mute letters and so many different ways to write down the same sound. After that, I became a PostgreSQL recognized contributor. I'm also the founder of Postgres Women, where we try to put some light on women in the community. So there's a very simple evil plan in 2 steps. Step 1, make them come to event. Step 2, push them on stage. And it works. Until this year, I was also a university teacher in Lyon, where I was living, where I was teaching Postgres. Actually, first year, I was teaching Oracle and Postgres. And then I called the university headmaster and said, this is not good for Oracle, because students can compare and they see that Oracle is not that good. So they want to do only Postgres. And he said, OK, let's do only Postgres in the curriculum. That's how I traversed the Lyon University. You might find my blog, mydbnotebook.org, and also this small website that I wrote, psqltips.org. PSQL is the only official client of Postgres. It's command line, so it can be a little difficult to learn it, more difficult than a GUI tool, for sure. So I created this little website that will give you a tip at random. You can refresh anytime you want. It will give you another tip. I have 150 at the moment. The main goal is to go to 250 or 300 in the end. So let's talk about organized anarchy, trash bin system. It's also called the garbage can model. This is how Postgres work. And you will see that it's interesting. So first, the PostgreSQL project. There is no governance. There is no product owner. There is no project management. And it works. I mean, if you've run Postgres, you know that it works. And it's been working for a long time now. So how do they achieve that? On top of that, it's also one of the most loved databases from developers, because the Stack Overflow survey, over 90K responses from the survey, Postgres is #1 on the most popular tech, most admired and desired, and most worked with and wants to work with, which is by itself an achievement, because it's been like 4 to 5 years in a row that Postgres is #1. So it shows that Postgres kind of have something. What is organized anarchy? So I use that term instead of the trash bin system or garbage can model, because that's how we translate it in French, and I love the oxymoron, organized anarchy. So there are 3 important things to understand. If you want to create a project using the organized anarchy philosophy, you need to have no common goal. Nobody has common goals in life. In this project, it will be the same. The process must rely only on the most simplest tech. You don't want something fancy and complicated. You want things to be very simple. And you want to allow anyone to go on and off with their participation depending on their time and the time they want to invest in the project. About anarchy, so this is a picture from La Commune de Paris, Paris Commune, which was a French anarchy revolution in the late 90s. We don't know if anarchy could work as a government thing, because each time there was such initiative, it was brutally repressed, like it was here. Most people in this picture are dead now, that's for sure, but were killed during the attempt to try to change the government. So we never knew if it could work. Postgres, by using the anarchy philosophy, is a proof that using organized anarchy can make things work. There are 4 ways someone, including in an organized anarchy problem, can contribute. First, they can look for problems looking for solutions. But then they can also go the other way around and look for solutions and then look for the problem to that solution. We can also have decision makers looking for work, because decision has to be made, and it can be done by anyone in this philosophy. And then we can have participants who are looking for decisions. So those are the 4 times, the 4 streams of data, the 4 streams people can participate. So the most important thing is you don't need to have a problem to propose a solution. That's the most important thing in organized anarchy. And this is exactly how American universities process things. And you might think that it's not very efficient. Well, actually, like in most universities' project, this is pro bono. So we don't care about efficiency, actually. We just want to do things the way we want. And if it's not efficient, who cares? I'm spending my own time. I can do whatever I want with it. So efficiency is not the problem, which is very different from when you're coding in a company. But let's look a little about why it works. Let's picture a company of 1,000 employees, and let's imagine this company is making 200 billions revenue. If we take an average, we can approximate that each employee generates 200,000 euros revenue. That's a simple division. How would you evaluate the normal productivity of a normal employee? Do you have any idea? Would be 50%? Raise your hand if you think it's 50%. 60%? No? 70? 80? Normally, in all the literature, we suspect that the motivation rate of a normal employee is 70%. If it's under that, normally they do quit and find another job. So, let's say it's 70%. Then, let's say that by having highly motivated employees, we go from 70% to 80%. So that's the productivity of a motivated employee. I don't go to 100 because, of course, even motivated employees have bad days. That's normal. So let's just calculate how more revenue they will add to the company by being highly motivated. So this is a simple calculation, and we go to each employee coming from 200,000 euros to 230,000 euros. But if now we add this, we multiply this 30,000 euros more by the 1,000 employee, that's a 30 billion euros extra revenue. So this is a very simple demonstration to explain what everyone should know. More motivated employees produce more than the less motivated employees. Well, I do it because we have some managers in IT who could look at that sometimes. If you have highly motivated employees and they work out whatever they want, using the time however they want, then you can go into processes like we have in Postgres where we focus on quality. Because in a company, you have pressure to ship the new features, pressure to add things into a minor version, even though it's a new feature, and so on. If you're in an open source project working pro bono, there can't be any pressure. In that way, it means that the PostgreSQL project decided on very simple rules to maintain quality. And those are 4. There will never, ever be a new feature in a minor release of Postgres. Minor releases are meant for patches, fixing bugs, and vulnerabilities. No new feature. The new version of Postgres will be out each year in fall. We don't give a deadline or a precise one because it will be out when it will be ready. Sometimes it's September, sometimes it's November. It's okay. But what we do is for sure there will be a feature freeze in April. It means that after April, we can remove features from the release candidate, but we can't add more. And then we have no fixed scope. Again, it's okay to remove a feature if it's not ready. The most important thing is that when we ship Postgres, it's stable, or at least the most stable it can be. I'm not saying Postgres is without any bug, because that won't be true, but we're trying very hard to make sure that it's stable. So, as I said, we work pro bono. And there's something very freeing when you're working pro bono. It's you give whatever you want. No one can pressure you to give more than what you want because they don't owe you. You don't owe them anything, and they don't own you. So you work on what makes you happy. If it stops making you happy, you can stop. That's okay. What matters is that you have fun. So some real example of how it works. I spent 3 months working on adding hyperbolic functions to Postgres. I don't know if you know about hyperbolic functions, hyperbolic sinus, tangent, and cosinus. I didn't know about these functions before. I learned about them and wanted to add them to Postgres for SQL compatibility. And I was very sure no one would ever use them. But after it was released, a man thanked me on email, thanking me because he was looking for that feature for a long time. You never know. Even though you think it's totally useless, maybe it will be useful to someone. And at least if you, and again, the main goal should be to have fun writing code. It's not to create something useful. It's just to create because you want to create. Some people in the Postgres community dedicate their life to improve performance on very corner cases, or can track 100 millisecond lag for days or weeks. It's okay. If it's their way of having fun, that's so great. When you create a documentation fix, actually it's at the same level of code fixing. So it's celebrating the same way. Actually, when you do contribute, you get a coin. So it's a small gesture from the community, but it's very nice. So there is no too small or not big enough feature that you can create, as long as you have fun creating it. No burnout culture, you can take a break whenever you want, because we all have a life, and we all know that sometimes life happens, and it's okay. There are a huge number of patches that were begun and never finished, and maybe someone else in the community will pick them up and keep going with them, or maybe no one will, and that's totally okay. We do value quality over speed. That's why it was so slow to build features into Postgres at the beginning. That's why in the early 2000s, MySQL was more popular than Postgres. The thing is, in my opinion, it's easier to add features to something stable than trying to add stability to something with a lot of features that is not so stable. Quality metrics. So, in the Postgres release, the number of bugs is very low. Again, I'm not saying there is no bug. That wouldn't be true. But its vulnerabilities are rare and bugs are low. We want to release a minor version of Postgres every quarter, and we do so. But sometimes the number of fixes in these minor releases is very, very low. And that's okay. And regressions are normally caught early. We have all these CI/CD pipelines that is trying to compile and run a lot of regression tests over a farm of various OSs, storage systems, and so on. But even if it's slow, I think that doing things the right way, which is my way of saying things, plays off in the end. About tools, as I said, if you want to go with organized anarchy, you need the simplest tech ever. So, Postgres works with mailing lists, which seems a little outdated in 2025, but there are some advantages. We have full ownership of our archives. We are hosting our mailing list servers, so we have full ownership of everything. There is no platform lock-in, because we own things. It's accessible worldwide, which is very important. And it favors asynchronous communication, which is very important. As I said, you want participants to be able to go on and off whenever they want. Also, there are some countries where connecting to the internet can be a challenge some days. So it's okay to go on and off. It's part of the process. And also, mailing lists work with any mail client you want. Then people are asking, why aren't you on GitHub? Well, actually, we do have a mirror on GitHub, but we're not hosting the main PostgreSQL Git on GitHub. Why is that? Because GitHub is owned by a company, which you might know because it's Microsoft, and they can change their terms and conditions without without telling you before. They can change overnight. And they actually did that several weeks ago about the AI policy. They can revoke your access. As you might have learned that there were some problems with the international trial at the Hague, who was hosting their emails on Microsoft platforms. And these emails were revoked overnight. So that might be a problem for you. And GitHub might not be available everywhere because it's a Microsoft technology, so there might be some countries where you can't use them. So this is what I mean when I say that platform dependency is a risk. There's also another capability that we use. It's transparency by default. Every discussions are public on the mailing list. People are discussing. And when I say discussing, it's real discussion, not everyone showing their point of view and not trying to listen to the other. I've seen people changing side, well, not changing side, but hearing to the other arguments and think, okay, you are right on that point, and maybe we should try it another way, and they were discussing to find a consensus. Archives go back decades. As I say, we are the owner of our own platform, so we have archives for over two decades. And it's easy to search and reference emails. It's just text. And also, as everything is public, there is no backdoor for, no private channel for backdoor deals, which is important. But Postgres lives in a world where not everyone plays fair. There has been historical threats at Postgres. So companies tried to take over Postgres and the PostgreSQL community. They couldn't because the community structured itself to make sure it doesn't happen. How does it come? We have a core team. The core team is not responsible for the technical changes in Postgres, but they are responsible for kind of taking decisions regarding the project, not technical decisions, most of the time politics decisions. And this core team was made of 5 people. And there was this unwritten rule that there couldn't be a majority of the core team people working for the same company. It became a problem in 2020 when EDB bought Second Quadrant, which was the second, so EDB was the first Postgres company at the time, Second Quadrant was the second. So we found out that we had 3 people out of 5 in the core team working for EDB. We added 2 extra people, so that now we have 7 people. Of course, 2 extra people not working for EDB, because it wouldn't have been any point in doing that. And now we have no majority, no majority of people working for the same company in the core team. We had also a trademark issue. You will find in the annotated slide a link to the case where someone tried to take over the PostgreSQL trademark, because even though we are utopists and we try to work pro bono, we have some legal matters and we have lawyers defending our trademarks. And PostgreSQL survived everything. Then there are threats like, like the XZ utils platform. Have you heard of it? So this was, it's a supply chain attack, so someone was very interested in contributing to a platform using OpenSSH, and it's a year-long social engineering attack. So we think that behind it, it's not an individual, but more a country. And the maintainer, it was, as always in open source, it was a tool that was used worldwide with 1 maintainer. And the maintainer got burned out because it's very difficult to maintain open source used at that scale. And someone came and said, oh, I can help. And he began committing patches. Until 1 year after, he committed something that added a backdoor into OpenSSH. And we found it because one of the PostgreSQL fellow, he's really into performance, and he found out that from time to time, he had a 200 millisecond lag in his OpenSSH connection. And he began looking at the code and looking, and he found the backdoor. And as it was only on a beta version, it was not released on a planet scale, and he was able to prevent this to spread all over the world. So the PostgreSQL project has some protections against that. The first thing is that the trust is slow to come, and it will come over the years. It's easier to get trust when you meet people. So if you go to events, you discuss with people, it will be easier to create that kind of trust. Changes are reviewed publicly. Everything is public. And we have very experienced reviewers. I think that the PostgreSQL project might have the best C coder all over the world. So it means we don't have one single point of failure. Of course, I'm not saying it will never happen. If a country wants to give enough budget, enough money to try to compromise something like Postgres, they might succeed. But it will take a whole lot of money and time. So maybe that's not the best target. If you see an open source project where there is a change of governance that benefits one company, or if community members have pushed out, like it happened for the LXD community. LXD was the follow-up of LXC, owned by Canonical. And actually, all the community members left out and created their own project outside. If you see license changes, like recently we've seen with Min.io, it means that it's not a real open source project. Well, they do disclose some source, but if a company can take over, it's not real freedom. So look for simple red flags. If there's a single company behind, if it's a closed decision-making process, you have, even though you work pro bono, you have pressure to rush failures. If there is a contributor license agreement, meaning you give to the project everything, and that the company behind can sell your work. If there are some governance changes, these are red flags. There is sorry, I will rush to the end. Yeah. So what I mean is, it's easy to work on Postgres. You can go on the wiki on postgresql.org, and it works great. It's fun, and if it's not fun, stop doing it. And it's sustainable, and you can come and join us. We have a booth there where you have a small sheet to help you begin your contribution to Postgres.
Thank you, Laetitia. So everyone, unfortunately, there is no breakup right now. Right after Laetitia, please welcome Valeria on stage. We will need a few minutes to just set up Valeria really quickly.
It's on, right? Can you also help me to set up this one? Where is the cord? Let me check. No, I think I need help because it has the presenter view. Yeah. Okay, let's check one more time. Oh, shit. Okay. Still there. So should I close it here? Can you do it yourself? Maybe not share my screen when you use this. Can you unshare the screen? Perfect, but now with the presenter view. Yeah. Delay. I hope you managed to read my presenter notes when we were prepping this because I don't have them here. My name is Valeria Bogatireva. I'm working in product marketing at the company called Percona. Before you run away from this talk thinking that this will be another product pitch and I will encourage you to buy something at the end, don't worry. This is rather a conversation about how to stay secure and compliant without giving up the open source freedom of PostgreSQL. So whether you are a data analyst, DevOps engineer, or you work in the leadership of the company, you may have noticed that in the past years, the compliance regulations have become tougher. The attacks have definitely become more intricate, as we have already heard on the talk earlier today. But unfortunately, the company budgets to tackle these attacks and to comply with new regulations are not growing. And so this is what we are talking here today about, how to comply without adding more complexity to the whole process. In general, I think going through the compliance with any regulation may be a bit like a dental appointment. It is for sure necessary. It may be painful, but if you avoid it altogether, there will be big consequences at the end. The clicker doesn't work. All right, so on this image here, you see a DBA in the middle running a compliance maze. In 2025, there are endless number of compliance regulations and local policies to comply with. There is PCI DSS, HIPAA, ISO. Has anyone heard about LGPD? Yeah, what is it? It may be. I'm sure you may be right. To be completely honest with you, it was a hallucination of my AI, but I'm sure it took it from somewhere, so your guess is valid. So this is not, of course, the full list of regulations companies need to comply with, and each of them introduced their new changes in 2025. The changes are numerous, but the essence of them is actually that they want companies to encrypt. Most importantly, they want companies to prove that they can actually encrypt the information. On the next slide, I collected a few of the changes that came to action in 2025. So for HIPAA, this for the pharmaceutical companies, there are more stringent encryption for electronic health records, so for all of the patient data that they are storing on their SQL databases. PCI DSS, this is for the companies who store the cardholder data information. There is new requirement for stronger database encryption, access controls, and real-time monitoring. SOX Oxley Act, this is the one that protects the financial reporting for the investors, asked for tighter audit trails for financial data. GDPR, which is relevant for Bulgaria, requires more consent management and also imposes higher penalties for the companies that don't log and store the user consent in the databases. Finally, CIS puts more emphasis on the database configuration controls. Now, as I mentioned, those are the changes that came into effect in 2025. And 2025 is almost over. In a few months, we are going to face a list of the new set of changes that companies will need to comply with. And this means that being compliant is no longer a checkbox that you need to tick every once in a while. It's more of an ongoing and continuous effort and process. So what every compliance framework is actually asks you to do can be narrowed down to these 5 things. Firstly, they are asking for encryption at rest, that your data on the disk must be unreadable and must be unreadable to unauthorized users. The second one goes hand in hand. It's encryption in transit, protecting data over the network with TLS processes. Then there is a key rotation, and of course, if you have the key rotation, there should be a documented key usage. You need to be able to prove what's encrypted and how it is encrypted. And finally, there is access controls. Only privileged users can manage the encryption keys. Now, I would say that these 5 alone cover most of the compliance checklist. And quick story, I interviewed once a customer who shared that he managed to write a short novel into the attempt to explain to his auditor how the encryption works in his organization. And this is not any of us want to do on our daily basis, writing novels about the encryption. And this is why the simplicity of encrypting data on Postgres becomes priceless. First of all, let's see how data is stored on Postgres. So there is some application at the top, and it sends a query or transaction to the database. Then the query goes through PG parser, PG planner, or PG executor, and then it's been executed and written into RAM. So at this stage, the whole change is being written into the shared buffer space at RAM. At the same time, before it has been even acknowledged to the client, the change is also written to the write-ahead log, or WAL for short. Write-ahead log is the sort of a first level of data integrity in Postgres. It guarantees if there is a database outage happening at this time, the logs have been saved even before they have been applied to the actual tables. So when the database restores, the data can be also restored from that state. At that point already, when data is written to WAL, it is already written to the disk. Then for the longer storage, there is a background worker that would scan the so-called dirty pages, the pages that are considered change and not being written to RAM. So it will periodically, depending on the configurations, write those new changes into the heap files that are, let's say, the longer-term storage in Postgres. Essentially, this is the primary storage mechanism to store table data. What else we have here? Okay, so in case there are some columns that take more than a single table, so something really big, those will be separately stored in separate files in tables called toast tables. Of course, all of this happens automatically, almost simultaneously, and in the matter of nanoseconds. But what I want all of us to be on the same page about, it is that before the data entered the database, it is considered to be data in transit. Then everything that you see here in blue, so everything that is written to RAM, is the data in use. Finally, all of the data that is basically written to the disk, so write-ahead logs, actual table logs, heap files, and these big toast tables, this is considered the data at rest. So all of the data that lands on the persistent storage media is considered to be data at rest. And this is essential to understand from the perspective of TDE. Because TDE, which is transparent data encryption, is also from time to time being referred to as the data at rest encryption. So I'd say that the most important thing about TDE is that this is an encryption method that is entirely managed by the database itself. And at the same time, it is transparent to all of the clients that use this particular database. So there are no changes to the application side here at the top are needed. And it's also the database that is responsible for the encryption and decryption process. So encryption from everything that goes to the storage and decryption that comes to from the storage back to the RAM. The interesting thing that the Postgres itself is also responsible for managing the encryption keys. Well, actually the management is being produced by the kind of separate key management solutions. That's why I placed them a bit to the side of the database here. But monitoring and managing of the KMS system is still on the Postgres database itself. Okay. So I want to be clear that this is not the conversation about why TDE is the only and the best encryption method. Rather, transparent data encryption complements all of the other methods, including the storage level encryption. And it also has a few benefits comparing to the storage level encryption. For example, it offers flexibility and granularity in the encryption of the database objects. You are the one to choose which table you want to encrypt, how you want to encrypt it, and with what key you want to do this. Also, if the database files are copied or somehow otherwise exposed in their raw form, exposure actually does not happen because what is getting exposed is the encrypted database. And this is particularly useful for physical backups that are being stored in the open Amazon S3 buckets because they're very common exposure vectors. Finally, it adds the additional layer to the whole security of your organization. Even if the storage level encryption exists, having TDE plus the storage level encryption gives you this more strengthened compliance posture that your auditor is asking you about. So TDE is the encryption at the database level. If someone gains access to your data, it still remains unreadable. Think of it as, well, a notebook that has been locked not just at the cover, but every single page of the notebook is locked, so no one can understand what is written inside. And the best part of it all, it works automatically. Inside of the database, there are no additional refactoring or change of code required on the application level to make it work. Additionally, TDE offers table-level granularity for precise control, so it is no longer necessary to encrypt the whole cluster if you only want to encrypt just a single table in your database. Just out of interest, how many of you had to push a very simple encryption method to production and then found out that it broke everything? Luckily, not a single person. And this is what we also wanted to achieve when we were building Perconis TDE, simplicity. Simplicity in the implementation. So we saw this gap that the Postgres community, Postgres does not have, do I have 5 minutes? Okay. Community Postgres does not have their own version of transparent data encryption. There were many attempts to introduce one, I think, over the past 10 years, but none of the patches have been pushed to the production. So what we did is we built a fully open source extension. Right now, it works only with the Perconis version of Postgres server. And the reason for this is that for this extension to start working with the vanilla version of Postgres, the upstream needs to accept a patch from us. And we're diligently working on making this happen, because this was the ultimate goal of this project, to create a TDE extension that would become a de facto transparent data mechanism for community Postgres. Oh, but even now, if you are a startup with a very small budget, or if you are a big government bank, you can already go and try our TDE extension. It is completely open source. There are no gated features, no paywalls, and also the Perconis server for Postgres is one-to-one compatible with the vanilla version of Postgres. The best thing about TDE, in my opinion, even if someone manages to steal your data, they won't be able to actually read it or sell it or expose it to the whole internet, because it is still remains unreadable. It is encrypted, so think of it as a very secure vault that, due to a lot of bad luck, got somehow stolen. But the attacker cannot do anything with that vault. They cannot open it simply because they don't have this master key. So the data is stolen, but it can't get exposed. And this is exactly what the regulations asks when they tell you to strengthen your compliance posture, to do something extra to protect your company in case your data gets exposed. So the key is the master. However, if you lose that key, you lose the data. Even if you are the database admin, you still cannot access the data without this one master key. So don't lose the key. In general, the biggest compliance risk that I have heard from our clients was not the lack of encryption. It was the key management. So that's why Perconis PGTD approach includes the centralized key management integrations with the leading KMS solutions. You can integrate Perconis TD with Tails, Fortinet, HashiCorp. You can integrate it with OpenBAO if you prefer to stick to the open source solutions. And these integrations provide automatic key rotation, separation of duties, auditability of key usage. And these are not just the good practices to maintain. This is explicitly what is required by PCI DSS, HIPAA, and GDPR. Okay, now to my favorite question. How does your TDE impact my performance? Well, TDE was built with the efficiency in mind, and when our engineers were working on it, we wanted to keep your SLAs the same, as well as your latency and your sanity. And we also wanted to protect the businesses and their data without compromising the speed of their operations and the user experience. So I'm leaving here a link to the benchmarks that were performed earlier in June this year by a Postgres contributor who is not affiliated with Percona. So the blue line here is the performance of the vanilla Postgres. The red line is the performance of Percona server for Postgres with TD enabled. And you see that the discrepancy in the performance is minimal. Now to the green line, this is the Percona TD with the write-ahead log encryption enabled. And the reason why this test is separate is that back in June, TD wall encryption was still in the beta process. And you can see that the difference is actually like down 20% in the performance, which is a lot. The good news is that 3 weeks ago, we shipped wall encryption in TD to the general availability, and now the difference in the performance is very much the same as between the blue and the red line. So finally, I have to say that open source does not mean unsupported. Percona provides open source tools, however, we monetize off of commercial support and services. So whether you need to prepare for the audit or tweak some performance issues, we are here to help you. But I'm reinforcing here that the support and services are optional. You're free to use Percona software however you want, in how many clusters you want, because we are truly open source. There are no gated features. There are no limits to the usage. So let's wrap it up. TD encrypts data at trust, and it helps you to meet global compliance requirements. There is centralized key management that ensures auditability and security. Integration of TD is simple, and the performance overhead is minimal. The whole extension is 100% open source with optional support. All of that means that you can finally meet the enterprise level of compliance without compromising your open source freedom or paying extra resources to do this. If there is one takeaway today, I'd say that security does not have to be expensive or proprietary for any company. It just has to be done right with the open source tools. So there are certainly many things that I did not get to cover today. So that's why I'm leaving the link here where we collected the most frequently asked questions we have received about TDE so far. It also contains the link to the documentation and to the repos. So please go try TDE. It is free, it's open source, and it can really make a difference when it comes to the compliance posture of your organization. Thank you very much for listening to me today. Благодаря ви.
Okay,
I
yeah,
rushed,
we have
but we
5
have
minutes.
questions.
5 minutes for questions. So, if someone have questions, yeah, okay.
Hi, that's a really interesting solution and an important one for compliance. I want to ask, does it support different schemas being encrypted with different keys? If we have the case where we want to separate different customers' data to be encrypted with different keys?
Well, yeah, it totally depends on the original architecture that you have, but there is no limitation on how many keys you can have. It's not like one master key for everything. I did it for illustration. The KMS solutions are quite advanced. You can have as many keys as you need for actually not just one table, but for a column inside the table.
Someone else had question? Yeah.
Hi. Hey, and thanks for the talk. You mentioned that key management is in the hands of the user, essentially. They can use Vault or whatever other tool out there to manage keys for them. Have you benchmarked the performance or how long it would take to re-encrypt whenever you need to rotate a key? And are there any implications of rotating the key periodically, let's say, I don't know, once per month, once per quarter, whatever is applicable?
That's a very good question. So what we're doing to address this, we are working in partnership with Tails and Fortinix. And because we decided to integrate with them, we're actually obliged to follow their best practices. So this is to answer your question regarding the rotation. I would say that it totally depends on the KMS provider. We are complying with whatever they tell us to do. That's why the integration takes so longer to establish.
Any other questions? Nope. Okay. Thank you.
Thank you.
I love the country, and I love food. And what's my favorite? Everything. Oh, except broccoli. I don't like vegetables.
No one in
As
Bulgaria
I told
likes
you, yeah,
broccoli.
that's why I don't like it. If it was Bulgarian, I would love it. Or Brussels sprouts, because it's Brussels. So, and I heard there is PG Days Bulgaria in June.
There will be. That's the plan.
Yeah, there should be. Because we will be there. I love here. So,
So it might be in Sofia, but it might be also the mountainside of
as long
Bulgaria.
as I can travel, I don't care.
There will be a lot of rakia for sure.
Yeah,
as well.
let's do it.
So
Let's
no
do it.
food, but just drinks.
Yeah, let's do it.
Okay, do you need introduction or you can?
I don't know.
I can just share that I'm very happy that this talk and you appeared, because otherwise I would have been doing a talk about Supabase. But when I saw, it's about Postgre extension, so maybe we don't need Supabase talk, and yeah. So okay, Devrim, very happy that you are here. So you can start when you are ready, and yeah.
Thank you very much. So thank you. Thank you. So I would like to start with with a complaint, because I'm going to complain to the organizers. I was told that my talk would be 45 minutes, and it's 30 minutes. So last year, I gave a lightning talk in a few Postgres conferences, and I used 90 slides in 5 minutes. So basically, I can speak fast. But in this specific slide, I have 130 slides or something. But I promise I'll squeeze everything in half an hour by skipping some portions of the talk. So, Devrim Gündüz, I've been working for Postgres for a long time. I think 1998 was the first year that I started using Postgres. In this talk, don't expect a happy story, okay? Because if you think everything's perfect, life wouldn't be good, right? Because we are here to develop the things, we are here to make things much better. And this talk is about making things much better. So I'm one of the Postgres major contributors. I do the Postgres RPMs. If you are using Postgres RPMs on Red Hat, Fedora, SUSE, and Rocky, and Alma Linux, whatever, I build the RPMs. I used to break website, and then I don't break it anymore. I have a tattoo as well, Postgres tattoo. So I asked them not to change the logo. If they change logo every year, that's going to be a huge problem, right? So fortunately, that's nothing. I travel a lot. You can find me in London, in Istanbul, or in Chicago, basically, or in the airport lounges. Sometimes I take more showers in the airport lounges than my home. So anyway, and I sometimes DJ, you know. Music is my thing, so let's do it. Anyway, so this talk is going to talk about the history of the extensions, and then introduction. And I will skip again a few parts, because like in the original talk, we have mentions to the references to which goes back to 15 years when we first had the extensions. But the slides will be available. So the slides are already available in PGConf DE website. So this year in Berlin, I gave this talk with almost similar content. So this is just updated version. So you can still download it here. So who are using Postgres? Hands down. Who are not using Postgres? Shame on you. Who are, yeah. So you should use Postgres anyway. So, and the extensions is a good start of using Postgres. Everyone uses Postgres. Because everyone is a PG Statements fan. If you are here for you've been here for the whole day. I heard at least 2 speakers mentioning about PG Statements, right? Because everyone uses PG Statements. Smile, right? So even Oracle people love it. So, right? Yeah. So consider this case in Oracle Cloud. There's Postgres database, right? We are working on it, right? Working on it. So in the past, I will skip those slides, but I will just skip until we get there. So in the past, there was no extension concept, and there was something in the core, which is called the contrib modules, which is still called the contrib modules. If you are looking at from the packaging point of view, we still call them the contrib modules. They are actually distributed with the tarball, but not a part of the main database. The idea was like having something close to the core, but not including core. It's like PG statements. Like for every customer that I have or every user that I see, everyone is using PG statements. And one of the questions that we get every time in the booth or somewhere, why is it not included in the core? Because the skipping is over there is much better. So, and then we had some extensions. We had the extension feature introduced like about 15 years ago, like 14 years ago, sorry, in 9.1 version, which is like too old. I met with someone in here, maybe he's not here, I believe. They are using 9.6. I told them not to do this. Like, it's too old, right? Anyway, upgrade. And then we were able to package features into Postgres, and we were able to maintain them extremely easy, right? Because in the past, for example, when we tried to install PG statements, we had to uninstall, we had to run an uninstalled script before installing a new version, which doesn't make any sense. And then we had no the idea of versioning as well. So we had lots of problems back then. But I mean, this is, as I told you, this is not a happy story, and we are here to improve the stuff, right? Otherwise, we would stop using Postgres 20 years ago, 25 years ago. And fortunately, there is some dependency checking. So basically, I will talk about those dependencies. So it also helps you, well, if you want to use post-PG routing, for example, it says you need to use PostGIS. Or if you want to use PostGIS Tiger, you need to use DB-Link, stuff like this. So you don't have to worry about the missing dependencies. But the only thing is, when you want to install an extension which requires a dependency, that dependency must be available on the operating system. So what does it mean? Basically, either the system administrator needs to install it, or if you are using cloud provider, see, I cannot say it anyway, anything. So if you are using a cloud provider, and then some of them include many of those extensions as well. But of course, from the user, as I'm a packager, okay, I make my life. I mean, I spend 100% of my time for Postgres and getting paid for it, and my time is actually for packaging this stuff. So I know lots of extensions. I build extensions every day. Like today, I built 2 more extensions to the Postgres repo while I was working over there. And then there are lots of extensions, and basically we have a control file for each extension. There's a control file which is quite basic, just a few lines, 3, 5, 6, depends on the extension, which includes the properties and properties of the extension. And then the one important thing is they have to be available for each major Postgres version. This is one of the things that I will mention during my talk as a non-happy story. Because, I mean, I don't want to point, I will point my fingers during my talk, but there are some slackers of extension orders who don't publish their extension, let's say Postgres 18. So you want to use Postgres 18, you depend on an extension, but the extension isn't updated for a long time, right? We will get there. So don't expect a happy story, but again, it must be available for every Postgres major version available on the operating system. So let me talk, if you are talking about dependency tracking, in control file, it says in H3 PostGIS, it says you need to have H3, PostGIS, and PostGIS raster before being able to install PostgreSQL. Before being able to install H3 PostGIS. So basically, it gives you dependencies. So if everything is installed, when you paste the cascade command, which I'm going to show you in the next few slides, it will install everything for you. And once everything is installed, it's ready for usage. Is it true? No, it's not true. Because as I told you, this is not a happy story. Right? Wish everything was so simple, because some extensions also require a restart. Because you have, like, if you are using Citus, for example, that's the first one that came into my mind. It used to be added to shared parallel libraries parameter in Postgres, which requires a restart. So, so don't, I mean, however, like PG, if you are using PG Partman, which you should, of course, you don't need to restart your database, but if you want to use it background worker feature of PG Partman, then you have to. So, I mean, there is a lot of things, but they are well documented. And if an extension requires a restart or something else, it will warn you before starting using it. So in the recent Postgres version, I mean, all the available, all supported Postgres versions, there are two views which you can get idea about Postgres extensions. One of the, so in Postgres 18, things are quite different. In Postgres 18, some people, some great people, I should say, came up with an idea of being able to install or say use, eventually use, extensions which are available on the operating system but doesn't have to be installed by the system administrator. So what does it mean? So the idea is like having like OCI images or a non-standard location. So actually DBA also can install an extension and make it available for usage inside the database, which is awesome, right? And this also, if you are using Kubernetes, actually this is why the old feature has been actually written. One of the major reasons that it was written, because in Kubernetes now you don't have to rebuild your cluster because you have an extension, right? You can just attach it and use it, and unattach it and don't use it. So basically, it's quite convenient for those users. Starting Postgres 18, we are now also able to track if there are multiple versions of the same extension are available or not, which is quite handy, because let's say if you are using version X of an extension and you want to also install the next version so that it's ready for usage, then Postgres is going to show you the availability of the extension. And then, again, of course, it will bring more problems. That's what I mean, as I told you, don't expect a happy story, right? So, but on the other hand, I don't want to say that it's hard to use. It's quite convenient. I just want to make sure that I'm not here to market anything. I'm here to tell the truth, right? Like Valeria said in her previous talk, right? She said, "I'm not selling anything." She said, "I'm here for you telling the truth." The same thing. I'm still here for the same thing. So let's talk about the state of Postgres extensions. They are everywhere. So you can find them on GitHub, you can find them on GitLab, you can find them on OSGeo, GTA, PGXN, SourceForge, Postgres Git repo, PIPI, and their own websites, and Bitbucket, and laptops. Oops. So you may think this is a joke, right? Who develops a software and doesn't put in any of these, right? I'll get there. So laptops, because I told you I'm a packager. I deal with people. And I deal with people every day, and it's not fun. Believe me. I find the tarball somewhere. It's not in the Git repo. And then there is the latest release, which this is true story, by the way. Still true story as of yesterday, because I checked it. So there is a release which is like about 7 years ago, 7.5 years ago. And there is no recent commit to the Git repo. So there is a Git repo. So there is no recent commit, but then they release a new version. Okay, so because just to make sure, I need the source code, see the source code to see the extension. So I asked Oder, and this was the answer. The sources are in the zip package included. Really? Yeah, I know the sources are over there, but I'm looking for the tarball. And I just kept pestering him because I'm looking for the answer. And he says, your tone seems like you think you are my boss, which you are not. I'm not your boss. I'm you. I'm the user. I want to use it safely, right? Because if you are talking about an extension, I have to make sure that they are safe and secure enough, right? Great. So is this all problem? Of course not. I mean, as a packager, I told you, in Fedora 39 there is something, 40 there is something, Red Hat 8 is something different, in SUSE is completely something else. So basically, I'm working on some if and else conditions like almost every day. Let's move on. Is this all? Of course no, because this is not a happy story, right? And then everyone has a great idea, right? Like we all have great ideas. That's what we are looking for, right? Hey, let's make it as an extension to Postgres. Let's do it. Perfect. That's a great idea. Users say yay, and they deploy it to the production. It works great. Perfect. Yeah, it works great. The extension is great. And then, okay, there's a new Postgres version. It doesn't compile. I also tell them, as a packager, it doesn't compile. We pester them, they want to upgrade, and developer just doesn't respond at all. So if you want to start using an extension, make sure that there is some nice people behind those extensions, not one single person. Because, yeah, it's open source, everyone cannot pick it up, but sometimes developers even don't respond to pull requests. So it's a major problem is non-responsive maintainers. Extension gets stalled. Some people send pull requests. Some people try to fork. It's not good for the users. It's not good for the community. Not good for packagers, of course. And then eventually, this is my life, I told you. So if you think I have a fancy life, yes, I do. At that point, this is what can I do sometimes, right? Like. There is no response from the developer, no response from the forwarders. All I can do, grab an espresso martini and enjoy the life. I'm sorry, that's the wrong slide. So we do some actual work. Anyway, so there are lots of packages around there. If you are using Ubuntu and Debian, we have lots of extensions. If you are using Red Hat-based, RPM-based distributions, good for you. In Windows and macOS and other operating systems, we have some of them, but not all of them. And let the breakage begin. Again, there's a new Postgres release. There's a new GCC version, right? And it doesn't compile with GCC 14, and then 15, and 16, and 25, and 55. I mean, this is what I see in my dreams, because 40 years later, I feel like I won't be able to compile the same extension again, right? So that worked. New LLVM version, the dependency version. And so it's not that easy. So anyway, so in wiki.postgresql.org, we have a website. We have things for the extension orders. If you are lucky, if your extension is listed there, it means we don't have a new version working against that release. By the way, don't get me wrong. Many extensions work. I mean, I should say 80% of the extensions just work, or they get updated frequently. And then, if it doesn't happen, it's a problem. So this is my life. If you thought that I was making a joke about non-responsive maintainers, I'm not. Okay? I spent like a whole chunk of my life pinging other people from the other part of the world that I have no idea where they are. So these, this is the list of the extensions that doesn't build against Postgres 18, except timescale DB. Why except timescale DB? Because they release a new version today. And I couldn't update my slides because we were working in the booth. Sorry about this. So anyway, so if you are using these extensions, they are unable to work and unable to build against the recent Postgres versions. Only Rep Manager will be out in November, so it's not that bad. So there are some slickers. And start some extension orders, which is, again, real story. They said, we will update the extension when they release 17.0. No, there is a beta, right? Go and do this. There is RC. Go and do this. So they don't do. So what did I do? I complained I stopped complaining, and on social media said, please complain to the extension orders, not to us, because I'm busy with my espresso martini, right? I have a life. Anyway, so installing an extension is quite easy, but again, there are some stuff like when you say create the extension Citus, for example, it says Citus can only be loaded via shared preload libraries. So actually, it's going to tell you what to do before installing the extension. Quite easy, right? So basically, you add this parameter to Postgres, and you will restart your database. It's a downtime, but that's fine because you are installing a major feature into Postgres. I accept it. And then when everything is done, it should be then you are ready to go use the extension. Again, I'm almost going out of time, but because I have to, I want to talk about the extension in general. So let's say if you want to install H3 PostGIS, it says this is not installed. So what you're going to do, use the cascade feature. So once you install the extension with cascade, it will install the dependencies which is defined in the control file by the extension order. So quite easy. Basically, it tells you what to install, where to install, what to do, use cascade, and you're done. Right? So don't think it's a quite hard thing. Go read it. Right? Because I know a good person who's doing the PostgreSQL RPMs and who's currently speaking at a conference in Sofia, has built a website on yam.postgresql.org, and it actually gives you an overview of, for each individual extension that we have the RPMs, it has a detailed documentation of how to install it with the command line and how to load it to the database. And some extensions like PG statements has parameters that you can use in postgresql.conf, right? Like pgpartman, like Citus, like PG statements. There are lots of extensions that you can add some configuration parameters, or PG set key cache, stuff like this. So we have an extension documentation. You can take a look, and it's quite easy for you. Updating an extension, that's the most tricky part, because when you install the updated version to the operating system, it means the binary is updated, or the SO file is updated, but the database is using the old version. It's quite tricky. See my point? Let's say you are using pgpartman 5.0, and you update it to 5.1 for a good reason, but then the current clients are still using the old version, but the SO file on the operating system is a new version. So it means you should restart your database for an extension to work properly, right? And actually, starting Postgres 18 started to complain about this. Like if you go to pgpartman and if you see the latest release notes for 5.3.1, I think, you will see the detailed explanation of the problem feature in Postgres 18. Yeah, so because there are duplicate SO files. Uninstalling is easy. Drop extension is going to do the thing. And if it depends on other stuff, just use the cascade, okay? But don't forget, when you drop an extension, it also drops the objects that depends on the extension. So you may end up with losing some data. Just be careful, okay? So let's talk about this is what I'm here for. Thanks to organizers. They gave me a break for 10 minutes after my talk, which means I will cheese a little bit. Right, may I? Thank you very much, appreciate it. So first of all, there are some programming languages, which is called PL. This is the only default extension in Postgres. If you are writing sort procedures with SQL, with PGSQL, that's always available in the Postgres database. Or if you want to write a sort procedure with Python, it's over there. It's PL Python. Perl, Tcl, still available. Java, Lua, Bash, right? You can write a sort procedure with Bash, or R. If you are, I know if anyone using R language in here. Yeah, perfect. R language is great for statistics, and we have a sort of well-maintained extension for PLR, and stuff like this. PostGIS, everyone loves PostGIS because PostGIS is the game changer, one of the game changers in Postgres. This is developed completely apart from Postgres core, and they have their own release cycles, but they follow Postgres. So basically, they release before the major release. They are not slackers. They know what to do. And then it's a special database extended for Postgres. It's an extension, but it's too huge. I mean, the feature-wise is awesome. Postgres.net is the URL, and the latest version is 3.6. PG routing. PG routing is extension to PostGIS, basically. It extends an extension. So if it adds the routing algorithms to Postgres. I'm sorry, PostGIS. So if you are trying to solve the traveling salesman problem or something like this, PostGIS is, PG routing is for you. It comes with a lot of number of routing algorithms. PG statements. Yeah, everyone loves PG statements. This is a must install for everyone. If you don't think that's the case, I'll talk to Pablo. Have you seen Pablo in the booth? The big guy? Yeah, just think twice, okay? Think twice. PG Vector. There was someone today who was looking for PG Vector stuff. Unfortunately, there is no PG Vector talk in this conference, but it starts a vector simulated search for Postgres. It's great, awesome, and it's also one of the major additions to Postgres in the last few years, to be honest. So PG Partman is a must, again, use extension like PG statements, but if you are using partitioning. So to be honest, the partitioning in Postgres is not usable. I mean, usable in terms of not like from user point of view, maintaining the partitions is a problem. But PG Partman makes it extremely easy. Creating the partitions, like aging the data, it makes everything extremely easy, okay? So if you are using the partitioning in Postgres, which you should do, please always use PG Partman to maintain it. Citus, it's 100% open source. It's horizontal scaling of Postgres. It does sharding and replication. It's awesome, and it gives you to be able to maintain your warehouse stuff problems with Postgres. And Timescale DB, it's a PostgreSQL-based time series database. It's partial open source. Source is open, but it's not open source. So you can see the code perfectly, no problem. But the part of the most functional part of Timescale DB is licensed to prevent cloud providers to fork it, to be honest. But it's not fully open source, and it gives you automatic partitioning across time and space. It's awesome. The release that they had today also has unlocked tables for hyper tables, right? Yeah. So it's much better than better with today's release, to be honest. PG audit. Everyone's data is quite important. I haven't seen any data which is not critical for a company, right? That's why we are keeping the data. PG audit is auditing the extension for Postgres, and it's developed with, I think, some US government institutions to check the security of the security of the software. So basically, it helps you to audit your database, connections, access to tables, whatever is logged to the Postgres log file, and you can analyze it and see if there are any problems or not. Federated databases. FTW is one of the most important features. Don't get me wrong, I love Postgres, but this is one of the reasons I love Postgres more and more, because it also helps you to connect with Oracle, SQL Server, Sybase, MariaDB, Hadoop file system, Mongo, even SQLite, Firebird, JDBC data source, ODBC data source, OGR file, CSV files, and even PG bouncer. So basically, these are the foreign data wrappers, which helps you to connect to other data sources. Well, there is more. Don't get me wrong. There is at least 100 more FTWs. These are the things that I got in here. So I'm almost there. I know I have 1 more minute. Perfect. There are lots of extensions. I mean, if you want to use like hypothetical indexes in Postgres, right? There is no feature in Postgres which gives you to add hypothetical indexes. So you want to see a result of an index before actually creating it? Yeah, it's a good idea, right? So HypoPG is one of those extensions. Or PG cron. If you want to run your jobs within Postgres database, use PG cron. Or if you want to use a background worker with Postgres, it's this. Monitored authentications, incremental view maintenance, PG sequence. PG sequence is the new way, it's a new PG repack, I should say maybe. But the good news is PG sequence is going to be integrated in Postgres code as of Postgres 19. Yeah, so basically we will have much better vacuum stuff and repack stuff built in Postgres. It's one of the most interesting and most exciting features in Postgres 19, which will be released hopefully next year. Top end, there are lots of top end is also another interesting thing. Don't get me wrong, there is more. If you want to use a database in read-only mode, this is what you can do. If you want to prioritize some of the processes, this is what you can use. You can give hints to your Postgres queries. You can roll back a specific statement. Basically, you cannot roll back a specific statement in Postgres if you're in a transaction, because of the transaction rules. But you can use this extension to be able to roll back one specific statement inside the transaction. Or PG memcache, like PG audit log to file, PG sphere, PG sodium gives extremely critical crypto interface for crypto functions for Postgres. It's one of the interesting features of extensions. If you want to connect to a web server and get some data, you can use PGSQL HTTP. Semantic version. There are lots of stuff which is being added more and more. So I would like to say thank you, first of all, listening to me, and first of all, coming to this conference. Thanks for organizers for having us in here. And we are in the booth. Pablo and I are in the booth. So if you have any questions, unfortunately, we will have to get those questions in the booth. Come and join us. Grab stickers, because I don't want to bring those stickers back to my home. Grab some brochures and enjoy Postgres. Thank you, Postgres. May I take a picture? Ready? Thank you.
Мира Георгиева от САП. Тя ще ни разкаже за Kubeflow и как всъщност да печелим от него.
Welcome everyone. It's pleasure for me to be here today and talk about the Kubeflow. Today I will share a brief introduction about the platform. We will go through the stages of the classical ML workflow and see how the platform supports each step. And finally, we'll wrap up by building a pipeline together. But before we diving into the technical details, let's see why the platform like Kubeflow are becoming increasingly essential. Over the year, machine learning has gone through various evolution from classical algorithm to deep learning, and today we have a scalable system. At the same time, modern ML projects face enormous dataset, complex pipeline, and need of the rapid experimentation. Challenges that Kubeflow is specifically designed to address by automating orchestration, scaling, and resource management. Kubeflow is an open source machine learning platform built to simplify how we deploy and manage ML workflows. Traditional frameworks like PyTorch focus primarily on building and training the model, but that's one piece of the puzzles. What Kubeflow brings are the missing links: management, automation, and seamlessly integration into the production environment. Kubeflow is not a single tool. It's a collect of the Kubernetes native components. And unlike of the monolithic platform on the market, Kubeflow gives you control over the entire ML lifecycle, from data and training to deployment, with flexibility to use only the components that you need. In the next few minutes, we will explore these components and see how each fits into the AI product lifecycle. If this sounds interesting, the official documentation is an excellent place to begin. And of course, if you want to contribute to the platform, welcome. Let's look at standard ML flow. We start with the data preparation, pass by model development, model training, evaluation, and in the end, we need to serve the model into the production. If these steps are new to you, don't worry, because we'll go through each one. Kubeflow components help automate it and coordinate it every stage in this process. The first step of the ML workflow is data preparation. This is an essential step before we moving onto the modeling and training. In this stage, we work with the raw data and we focus on ingesting, cleaning, and transforming large data set efficiently. To support this, Kubeflow leverage the Spark operator as an external component, and it can be installed separately and integrated seamlessly with Kubeflow pipelines, enabling scalable and distributed data processing. When the data is ready, it's time to move to model development. During this stage, we designed and building our models architecture. This is where Kubeflow notebooks come into play. Notebooks provide an ideal environment for experimentation, allowing data scientists to quick test ideas, prototypes models, and faster visualizing the results. But Kubeflow notebooks aren't just a Jupyter installed in Kubernetes. They are a fully integrated and configurable environment where each notebooks run its own pod. Kubeflow launches an isolated environment for each user, and you can choose image among Jupyter, VS Studio Code, and RStudio. And of course, if you want, you can create your own, and you can use YAML definition to control where it's run and what nodes it uses. For example, GPU, NVIDIA, AMD, or Intel. This is ensures efficiently use of the cluster resource and prevents overloading the nodes. When we have the prepared data set and we defined our model's architecture, reach to the next step. Before this stage, the model is just a blueprint. It doesn't know anything yet. And now, here, it's time to train the model, which means teaching it using our data so it can learn patterns and make accurate predictions. There is where the Kubeflow training operators come in. With the operators, teams can systematically deploy complex machine learning workflows without worrying about the infrastructure. The operators schedule a job across available nodes, balances GPU and CPU usage, and adapts to dynamic workloads, ensuring that every training session runs a peak efficiently. Kubeflow training operators streamlines the whole process, enabling faster iteration, higher model accuracy, and optimal hardware usage. Let's go back to diagram. So we've processed the data and built the model, and now it's time to evaluate it. An important step that often involves adjusting hyperparameters, which are settings or configuration chosen before training that control how the model learns from data. Without the Kubeflow, the process looks like this. We choose the initial values from experience. We started training the model, wait for the result, record the performance, and repeat with other values. This approach is slow and often misses better combination because it's difficult to test many variables manually. This is exactly the problem that Katip as part of the Kubeflow solves. What does Katip do? It automates hyperparameter tuning, allowing you to systematically explore many combinations and find the optimal setting much faster. It runs on the Kubernetes and can connect to different machine learning systems and frameworks. In addition, it's not limited only to AI. It can be used to optimize any task where we have input parameters and can measure outcomes. For example, to finding the faster ETL process or the most efficient configuration for DevOps pipeline. And step by step, we arrive to the final stage where we deploy the model into the production environment. This means taking the ready model and making it available so other applications or user can use data and receive the predictions. Deployment involves not just serving the model, but also ensuring scalability, reliability, versioning, and monitoring, so it can handle varying workloads and continue performing accurately over the time. For this reason, we have a KF serving was created as part of the Kubeflow project and was later renamed to KServe to reflect its broader scope beyond the Kubeflow ecosystem. KServe is a tool for automated deployment of the machine learning in Kubernetes. It allows you to easily expose model for inference by defining a configuration in YAML file. In that YAML, you describe the model specification, environment, and resources. When you create an inference services, KServe automatically creates all necessary Kubernetes resource to start serving the model. When a client sends a request, it goes through predictor. It's a component actually loads and serves the model. It supports different runtime environments and provides a standardized way to serve model regardless of the framework. If you want, you can pass by explainer, which adds a functionality to interpreting the model predictions, or transformer, a component that allows pre-processing or post-processing of the data. Kubeflow comes with a model registry, S3 compatible storage, where you can manage artifacts and metadata. It can be used from the very beginning of the project and interact with throughout all stages of the ML lifecycle. Let's walk these steps again, because everyone can be part of the pipeline. And actually, pipeline is heart of the platform. You can use the Q4 pipelines to create and run multi-step ML workflows as containerized tasks. Executed pipeline with specified arguments, return with new data, schedule runs, and organized experiment. Track model, dataset, and metrics in artifact registry, and visualize pipelines, log, and result with the Q4 dashboard for reproducible and scalable ML operations. Here you can see the full process of execution of Q4 pipeline. AI practitioners submit a pipeline to the web server. The web server has user interface which provides a job creation to start the pipeline, run details with ability to see the status of each run. It also displays ML metadata, including inputs, outputs, and metrics, and it visualizes artifacts like models and graph. Once the functions reach the compiler, it gets transformed, usually into the YAML, which describes the DAC. The definition is passed to the execution engine, which prepare the pipeline execution by creating a Kubernetes custom resource, describe each step, and then hands it off the orchestrator. The orchestrator is the component that loads the intermediate pipeline from via the IR loader, track the progress of each step using the execution tracker, assign the task to the Kubernetes node, and writes the result into metadata store. All pipeline steps are executed in Kubernetes pod, and there may be multiple nodes used for parallel execution. Here, I will stop with theory, as this is enough to give us a clear picture of the process in the ecosystem, and we will take a look how to apply this in a practice in our project. For the use case, I've come up with an idea to solve a typical problem from our day-to-day work, consistently adjusting requests and limits of the resources. Let's imagine a standard Kubernetes deployment scenario for application with 3 components: backend, frontend, and database. Instead of deploying each service on a separate physical node, with Kubernetes, we deploy them as pods, which can run on any nodes in the cluster. Suppose our cluster has 3 worker nodes, each with 4 CPU cores, as shown in the picture. We create a deployment where we request a specific amount of the CPU. Let's assume the database and backend consume more, and we request, for example, 2.5 cores for it and 2 for front end. From experience, we assume that this is the expected behavior of the app. The Kubernetes scheduler selects a node that has enough resource to fulfill the pod's request, and it reserves the amount of the resources for the services. But what happens if the first pod actually needs more CPU than requests? The app maybe freeze, or the container will restart, not the behavior we want. And if the backend consumes more than requests, the problem becomes obviously. We have CPU resources that are both unused and cannot be scheduled elsewhere. To address this, we built an end-to-end workflow that can be used as a way to manage resources in the Kubernetes. If you continue to follow the classical ML workflow, first step, we collect the data. For this, we need to collect CPU usage, for example, from Prometheus for our pods, and then aggregate metrics and add the temporal features for example, weekday, hours, months, also create a log feature and a rolling feature. When the data is ready, we split the process into the two parallel flows. In one of them, continue to follow the workflow, train the model and evaluate it to use the model to suppose operational decisions and capacity planning by visualizing potential outcome. On the second, classify resource usage and generated actionable optimization recommendation. The main installation when we need are Python, Kubernetes, and Kubeflow. It's supposed to install Kubeflow. It's using the official manifest, which provides a different installation with pipeline, Katib, Kserve, and lightweight distribution, which make it easy to deploy in different environments. I've already set everything up, and I have a Kubeflow pipeline installed. To simulate the situation, I've created a code that simulated the Prometheus metric endpoints, generating CPU metrics for 3 pods, so the Kubeflow pipeline can be tested as if it were running against real world in Kubernetes. At the end of the presentation, you will find a link to the Git repository with the code and explore more about the demo. Let's see how it looks like data in Prometheus, and query that calculated the rate of the accumulated CPU. Use the same query into pipeline. I stop with 3 main points about in the code. First, in each step, we use the DSL component decorator. This makes every step modular, reproducible, and easy to connect into the full ML workflow. And runs its normal Python function into reusable Kubeflow component. The function must be type annotated and hermetic. So all model imports have to be inside the function definitions. And we come to the most interesting part of the code, because here we see the full picture of how Kubeflow pipelines work. This is where we define the execution order of the steps. A Kubeflow pipeline is built from components. Each component is a building block. It takes input data, executed some logic, and generated output data. Each functions call like load data from Prometheus, process data, train model, and etc. represent a Kubeflow pipeline's component. When we provide real data to a component, it becomes a task in the pipeline. Now, the pipeline code itself are just a Python. It's only describe the steps and their dependencies. But Kubeflow cannot run Python directly. It expects a decorative file. That's why we use the compiler, which translates our pipeline code into the YAML that Kubeflow can actually submit and execute. Once the file is ready, we run Kubeflow create command, where we pass the desired name of the pipeline and generated file. This creates the pipeline in Kubeflow with a specific ID. We can see listed the pipeline, and we click on it and open the DAC. You can see every step on code as a single step on pipeline. And now it's time to create a run. A window opens in which you see the name of the pipeline, version of the run, and you can add description and associate experiment or stay empty this part, you choose. During the execution, you can select a specific step and click on it. In additional window opens. In it, we can inspect the inputs, outputs, as well as the result, logs, and errors, if there are any during the execution. Additional, you can also monitor the pipeline execution and its individual pod in real time. Now, let's return to our example and look at the model results. Due to limited time, I will skip the intermediate diagram and show you directly the combined chart. The historical data present in the blue and the forecast data present in the orange. What do we see? For most of the period, the backend services run steadily in the optimal zone around 2 CPU with short dips. The clearly indicates that the declared CPU requests are more than enough. We can also clearly observe the typical pattern of lower consumption during the weekends and outside working hours. This simple example shows how the model can be used for the optimize schedule resource or automatically trigger alerts when abnormal consumption occur. Sorry. And I know the example is interesting. For that, I prepare a blog post when you see more about it. But let's turn back to the platform. What is the kubeflow? Overall, what is the kubeflow? A platform made up of multiple open source projects, each adjusting different parts of the AI ML lifecycle. And today, we walk through the main phase of the machine learning flow and see how kubeflow projects interact with each step. And with that, I will stop and open the floor for questions, comments. Okay. Thanks for everyone.
Start. The last speaker for the day is Julian Donchev. He's working with Oracle in United States, and let's congratulate him because his flight from Las Vegas just arrived this afternoon. So you can imagine how hard is it to travel so long time and straight present to our audience. So thank you, Julian, and have a good one.
Hello, everyone. So my history is as follows before I start presenting. I am the product manager for JSON and PL/SQL at Oracle Corporation. I'm a database guy. I used to work before Oracle for Accenture. I was running for 12 years the global database team of Accenture, all databases, not just Oracle, any database. And before that, for 9 years, I was running the database team of Nokia 20 years ago. My history is primarily with Oracle databases, but I'm going to do some demos also with Mongo Compass. The presentation today is on JSON relational duality. And I don't know how deep I should go because I do not know how much you know about Oracle database. Can you please raise your hand if you have worked with Oracle database? Oh, everybody, okay, that's good news. And Mongo? So that's easy, all right, very good. So last week or a couple of weeks ago, we announced the latest version of Oracle database, 26 AI. So 26 AI is like 23.10, but you don't have to specifically upgrade to get to 26 AI. So what I'm going to demo today will be based on 26 AI. I have an Oracle database in the cloud. Here I'm using SQL Developer. So this is a database. When you run select banner full from version, you see that it's 23.10. But actually it's 26 AI. Also, I have a connection to the same database, but using Mongo Compass. And Mongo Compass, for those of you who don't know, is you can think of the SQL Developer version for Mongo, guys. And here I'm connected to the same database. It's called AJK26. And the way how it works is that we have a Mongo API, which connects to the Oracle database. You can run Mongo commands against an Oracle database. That's what it does, basically. You can think of some software on top of the Oracle database where every Mongo command is being translated into an Oracle command, and we run an Oracle command. So it's exactly the same data, the same version. But before I even start doing any demos, I'll go into the PowerPoint presentation, so I introduce some concepts. And the topic today is about JSON duality views. And I saw a lot of you work with JSON, Mongo, and Oracle, but who has worked with duality views, with JSON duality views? Anyone? So no one, nobody. All right, good. So this is something that we developed in 23 AI. And the whole idea is that you can view Oracle relational data in JSON format. You can present the data in JSON files, JSON documents. And the agenda for today, in the next 40 minutes, is first some historical background on JSON in the Oracle database. Then I'll explain what is JSON relational duality. And some people claim that this is the biggest invention in not only in the Oracle database, but in the IT industry, which is, of course, as the product manager of JSON, I'm a bit biased, but it's probably in Oracle 23 AI, or say 26 AI database, it is by far probably the most interesting and important feature. I'm going to show you what flex columns are, flex columns in tables, because they relate to JSON and to Oracle database. And then I'm going to show you the newest tool that we have, which is called the JSON to Duality Migrator. It automatically migrates Mongo or any other JSON database to Oracle. I'll even, if I have the time, I'll show you how I'll do it. I'll do it with a very simple collection, but it automatically runs a command. It's a PL/SQL block that I'm going to run, and it will convert Mongo into Oracle. You don't have to do anything. So it creates, based on the Mongo documents and their fields, it creates relational structure. It builds also indexes, sequences on top of that. It creates the JSON views on top of the Oracle database, and then it imports the data in one go. That's the live demo. And for Q&A, you don't have to wait for the Q&A. you can anytime raise your hand and you can interrupt me. It's fine if you want to ask me something specific, because at the end it's a bit different. And those lamps a bit directly into my face, but if somebody's raising the hand, please point him or her to me. JSON in the Oracle database, more than 10 years. It came with 12c release 1. And with 12, this is the converged database. So basically, that's the Oracle database where everything, what you can think of, is being supported. You know, the Oracle database compared to the other databases, which are, I think at the moment, around 450 in the world, 450 databases that you can download from the internet, you can configure, install, use. Oracle is probably one of the very few which contains, if the only one which contains most of the features that other databases have. And one of them, of course, is JSON. And we started with JSON in 12c released 1, where I won't go through all those slides, for all those bullet points, but the ones that you see in red are probably the most important milestones that we developed. So the first one in red is the MongoDB API. I explained that this is software which translates Mongo commands into Oracle, so we speak Mongo. Then we created the native JSON data type. In Oracle, you have a JSON data type. It didn't exist before. Of course, you were able to store JSON documents as CLOPS, character large objects, or BLOPS, binary large objects, or even as varchar2, but with 20C and 21C, we introduced the JSON native data type. It has a limit of 32 megabytes for one JSON document. Compared to Mongo, they have 16. And then duality views. The duality view is probably the most important topic of today, where we, like in a normal view, you worked with an Oracle database, you know how to create a view on a table or on several tables. It's just a meta structure. It doesn't consume storage. It's not a physical segment. It's a view. It's same with JSON duality views. They just read the relational data and they represent the same data in JSON format. And then in the latest release, we introduced the Duality Migrator. This is the tool that I mentioned that migrates automatically Mongo database or any other database that stores JSON files to Oracle. So JSON relational duality. Now, in order to be pretty fair, I would like to compare in one slide which is good for relational and what is bad for relational. The good stuff about relational, that you don't have to duplicate data like you probably would do it in Mongo. There is the consistency, which is guaranteed, while in Mongo, I've seen some customers who migrate from Mongo to Oracle because they have issues with data consistency. Then it's the use case flexibility. And of course, you have SQL. I've seen also several customers who migrate from Mongo to Oracle because at one point they need to start to run reporting and analytics on the data, and they cannot, it's very difficult to do it in Mongo. However, to be fair, in relational databases, and here I mean PostgreSQL, Oracle, DB2, oops, I should have closed this. You require upfront schema definition, so you need to know very well your use cases. It takes time. While if you start developing an application in Mongo, you can start very quickly without the whole hassle with Oracle that you need to create all the tables and you need to know what columns you have in the tables and what data types of those columns and so on and so on. And of course, with the relational, you often, if you start normalizing too much, you can break the business objects into several tables, into a lot of tables. And of course, SQL is usually, not always, but usually not integrated into the programming languages. Same slide, but about JSON. What is good about JSON, what is not good about JSON. So, of course, good stuff is the JSON object. They contain all the information for one use case. And those objects can be retrieved with a simple get operation. Get the JSON file, put the JSON file. And it's schema flexible. You don't have to worry about the schema. Eventually, I've seen, you have to worry at some point, but not in the beginning. Data first, schema later. However, single hierarchy in JSON in Mongo is only possible for the very simple cases. And I see a lot of data duplication. It's really required for real applications. And the consistency, which I mentioned a while ago, it's very hard to keep. So you have with Mongo, initially you can develop very quickly a database, an application. However, the more complex it gets, the more difficult it gets for developers. and DBAs too. And the opposite with Oracle. Initially, it takes time, it's slow, but eventually it can cover very complex cases. Now, the question is, should we choose relational or documents? Can we get the benefits both of relational plus documents? And yes, the answer is yes. This is JSON relational duality. This is the topic of this presentation. It's available with Oracle Database 26 AI. Now, how it looks like. So on the left side of this slide, you can see how data is stored as rows. It's stored in tables. Against those tables, you can run SQL. And those rows, they can include also JSON columns. You can have a combination of number, date, varchar, and you can have JSON. Data can be accessed as JSON documents. And that's very simple for documents which do not exist. They're based on the relational data which is in the tables. How do you create those views? The new command is create the JSON duality view. And here I have a simple case for a conference. Imagine you would like to create an app for the conference like most conferences have. And you can build the schedule for different participants. Here on the right side, you see the schedule for Geo. And you have only relational tables in the database. But creating such a JSON duality view called attendee schedule, you directly refer to the table attendee, and you use some of the columns to become the fields of the JSON document. So here on the right side, you see how the view would look like. So directly, you can use the same logic like in Mongo. You can get the JSON document and you can put it. So you don't have to worry. You don't have to know Oracle. You don't need to understand the relational databases. You don't need to understand how to work with reporting and analytics. You simply can use the views. This is extremely good for teams which have combination of both Oracle experts and Mongo experts, or document experts and relational experts. They can work together. The ones who do not understand Oracle, they can directly use tools and methodologies they used to, like Mongosh, Mongo Compass, and still don't even comprehend or understand that behind this tool there is an Oracle database. And the people who are relational and understand relational databases, they can still continue using their tools like SQL Developer, SQL Plus, and so on. Now, here is how simply you need to specify the tables which contain the data in order to create those JSON documents. They're called JSON duality views. This is the official name, JSON relational duality view. And here, creating the JSON duality view attendee schedule, we use 4 tables. You use the attendee table, the attendee session table, the session table, and the speaker table. Those are very normal relational tables in a conference app. You have also JSON collection views. And JSON collection views, there are 2 kinds of those. There are the duality views that I just mentioned. They are updatable. You can directly run and delete or update against the view, and it will also update the relational data behind the view. But you have also non-duality JSON collection views, which are read-only. Why there is such a division between those two, readable and read-only? Updatable and read-only, it's because some apps just do not need to update the data. There are customers that create now apps only based on JSON collection views, which are read-only. And the way how you create a JSON collection view is very simple. You run a command, create or replace JSON collection view, and you select the data that you need from the tables using the JSON operator. Now, those JSON duality views and JSON collection views, they have only one column. The column is always called data, and the type is JSON. So only one column. When you describe such views, you see what you see here at the bottom of the slide. You see one column, always the name is data. Now, flex columns. Flex columns are related to JSON duality views, and in order for me to explain it, I rather show you with an example than show it on a PowerPoint slide. Now, let me first drop what I have. And note here that in 26A, we have a syntax if exists. So you can drop now a table if it exists. You'll never get an error message. Before, in the past, if you drop a table that exists or doesn't exist, you get a message the table does not exist. Here, always you get a message table drop. That's probably good for developers when you run your scripts, that they don't throw you error messages. Now, I'm going to create a simple table called person, this table. And the table has 4 columns. One is the ID, which is the primary key number. We have the first name, the second name, and we have the JSON, which is called extras. I'm calling it extras. You can call it anything you want. This is just the JSON document. I want to show you what is a flex column. Table created. Okay, now I'm going to create the duality view on top of this relational table. And I'll show you how the syntax works. So here it is, create JSON duality view. I'll call it person merge view. I will select from the person table. I'll select the ID. And I'll call the ID, I'll call it underscore ID. This will be the field in the JSON document. I have the first name, and I'll call it first name. I have last, which I call last name, and the extras. I say add flex because this is a column where actually we'll be dumping everything. And it says JSON duality created. So flex column basically is a column in the table, in the Oracle relational table, where we dump fields that are unknown or unpopular. You always can have in a JSON document a new field, but behind it, there is a table. The table has a certain amount of columns. And you do not know if the field that comes from the JSON view will have behind it the column or not. You can, of course, create always a column. You can always alter table, add column, but that you need to know very well when to do it, and this doesn't work in real production life. So here we create the duality view. And I need to insert in the table probably few values so that I can show you what it means. So here I'm going to insert the first row. I'm going to insert 3 rows. First with ID 11, I'm going to add one for Bida Hammerschmidt, and I'm using also a field called nickname, Dr. Jason. Bida is the VP who runs JSON in Oracle for development. So note that I don't get an error message, 1 row inserted, although I didn't have in the table a nickname column. It goes into the flex, that's the whole idea. It absorbs it. It takes everything that is unrecognizable. Then I'm going to do a second one for Herman, no nickname. So here the nickname is empty, as you can see. And then I think the last one is me, Julian, and my friends call me Jules. So here it is with the nickname. And probably I need to commit. All right, so now we have the three columns in the table. Now, let's see what really we have. If I select from the table with a where condition where the ID is 11 or 33, here obviously it's me. So here you see that, let me increase a bit. I'm without the mouse. So here you can see that it's me and the nickname is here also. It's a flex field. Also, if I want to select everything from the duality view, not from the table, you can see that I have Bida, I have Herman, I have me, and you have the nicknames. You can see the same also from Mongo Compass. Let me refresh. Person merge duality view, here it is. And here we have Bida, we have the last name, the nickname, same for Herman and same for me. Here you have this button where you see where the cursor is. If I click on it, you get a view from Mongo Compass, more like a relational-like. You have columns, rows, but probably that's the right way to view the data. Now let's continue. If I would like to add another country, another field, which is the country Finland, where I live, I can update directly the view. So look at this update duality view. I set a new field called Finland, and it's called country. It's for me, for ID 33. Here it is, 1 row updated. Let's commit this one as well. Now, if we look here at Mongo Compass, you'll see, if I refresh, I'll see that there is now also for myself, there is the country field. So directly through the duality views, you can update the relational data. You don't have to be an Oracle expert. You can continue working with your Mongo skills. You can use your even Mongo tools. And so on and so on. Now let's see if I would like to get a better output. I would like to concatenate the first name and the last name, get all the information, get the nickname and the country. And here I'm selecting also from the duality view for myself. So here it is the name, the nickname, and the country. So everything you get from here. So this is a flex field. That was exactly what I wanted to show you. You have a field in the table behind the duality view, which absorbs all unrecognizable data. It gets there. It's a JSON. Yes, please. Oh, it's inside the table. It's inside. It's inside. And the size is 32 megabytes. That's the maximum size. But you're asking why? Why the 32 megabytes? Well, think of this like in Mongo, it's 16. So if so many customers manage in Mongo to cope with 16 megabytes, you should be able in Oracle to get with 32 megabytes. Although I've seen some customers who sometimes get documents which cannot fit into the 32 megabytes, and there is a workaround, then you can create the column as a binary large object which has no limit. Blob. If you mm-hmm. Yes. Like the B file in the past, you mean? Yeah. Well, that was the architectural decision, and the idea is to store everything within the Oracle database. Because in the past, when you had the external files, then think of if you have to restore and recover the database. Then if everything is in the database, you have everything in sync, right? You can still do it if you would like. B files still exist, and you can have the JSON files on the operating system. But the question is, how often would you need a JSON? How often do you have a JSON document which is more than 32 megabytes? I have here one file which is with movies, like from IMDb. It has maybe 4,000 or 5,000 movies, and the whole file is only 4 megabytes. So to get to 32 megabytes, you really have to have a lot of data in the JSON document. It's for one JSON document, only 32 megabytes. Not if you use the JSON data type. You're not wasting it. You're not wasting it because it consumes exactly as it needs. That's how it's architectured. You do not use more than it is considered. You can waste it if, for example, you have a varchar 2 and varchar 2 4,000, or now you can have even more than 4,000. And for example, you have a very small file which has 2 or 3 fields, and it uses, say, 200-300 kilobytes only, but not with JSON. So JSON consumes on storage as much as it needs. It doesn't waste space.
And what is the starting size?
I'm sorry?
The starting size of the field.
It doesn't have a starting size.
So it's
zero. It's 0. So if you, for example, create a table with a JSON column, if one column is JSON, and if you go to DBA segments or DBA, or for example, you analyze the table and you see what is average row number, the average size, then it will, of course, show 0. There is nothing.
So if we update the fields, everything needs to move around, or how does it work?
Which fields?
The JSON field, if we need to change it from 0 kilobytes to 32 megabytes.
You don't do it yourself. The moment you insert the data into the JSON column in the Oracle database, then it automatically will expand.
Like the varchar.
If it's varchar, no, we're talking here about JSON native data type.
Okay, thanks.
Yes, there is one more question. No, okay. All right, let me see how I'm on time. All right, let me continue. We went for flex columns. I did the demo. Now, JSON to duality migrator. So I want to show you how this works. And probably this is an interesting one because it will migrate directly JSON collections to Oracle database. I can show you some concepts, but I'll do the live migration soon. It will take me 5 to 10 minutes. Now, like every tool has parameters. So you need to put some, of course, you don't need to run the tool with parameters, but there are some concepts that require some background knowledge. One of the parameters is called minimum frequency. So frequency in a JSON document, in a collection of JSON documents, means how often a field is present in the documents. Imagine a collection with 100 documents. Every document is about a single person. So we have 100 people in his audience. There is one document for each one. Think of the field nickname. Maybe only 2 or 3 out of 100 have a nickname in the JSON file. We consider those fields as outliers, meaning they're very rare. They're not common. And by default, we consider a field an outlier if it's less than 5% of the values. Because once you migrate, think why are we doing that? If you migrate a Mongo database, JSON files to Oracle database, do you have to create for every field a column? Maybe not, because maybe there are those unpopular fields, like nickname, which are not present in every document. They're present only in 1 or 2 out of 100, or in 5 out of 100. Those you can use as flex fields, as flex columns, and you can dump them in the flex column. And flex column would help you because in the future, if you have new fields in the JSON documents, they'll be directly dumped there. Now, the frequency can be considered in 2 different ways. Frequency in terms of the field, for example, nickname, or frequency in terms of the type. Usually, number is a number, 5, 6, 25, 100, and we put it as a number. But some developers, some people, put it in quotes as a string. Now, if you have 100 times a number, but in 2 or 3 documents you have the number 7 or the number 5 in quotes as a string, is this a string or is it a number? How would the database consider it? Would it consider it a string or a number? And that's why we have this type frequency parameter as well. What the JSON to duality migrator does, it will analyze the JSON documents. It will create relational tables based on the documents and their fields. It will create the indexes on those tables. It will create some sequences even, the foreign key constraints, and at the end, it will create the JSON duality views on top of them, so that the JSON documents exist like views, like they did exist before in the Mongo database. And at the end, we're going to import the data. What else I wanted to show you? So the migrator has 2 components, the converter, which converts the structure, and the importer, which imports the data. That's what I'm going to show you. What we do 4 things. We first validate, we check if this can be done. We try to normalize the tables, and we generate the database objects. The way how we generate the database objects, we create one big string with commands like create table, create index, create sequence, and at the very end, we run this with execute immediate in one go. And at the end, we import the data. So those are the 4 things that happen. How does this work? There is a new PL/SQL package called DBMS JSON Duality. It has very few procedures. One of them is infer and generate schema, which is the one that usually one would use, so it does everything in one go. And some other parameters which are important, updatability, those 2 are Boolean parameters. Updatability means if those duality views, JSON duality views, can be updated. Of course, in most cases, you want the data to be updatable for them, so the default is true. So of course, once you have the application ready and running, you would like to also be able to update the data in the Oracle tables directly through the views, through the duality views. And use flex fields. Default is true, of course. In most cases, you want to use flex fields because you don't want to lose data. If the JSON documents bring new fields, you would like those new fields to be recorded. You don't want to lose them. And of course, there are parameters like error log, source schema, table spaces that are typical for Oracle. Now, that was from the PowerPoint side. And let me show you how this works in practice. I was just telling my colleagues here that I was traveling all day and I didn't drink coffee so I can sleep on the plane. It worked, but now I feel like I am on a plane. Now, the collection that I'm going to use is called coffee. It's a coincidence, just. Let me drop some tables if they exist so I can get rid of them. I'm going to create 12 different coffee documents, like espresso, cappuccino, and so on. But before that, we need to create the JSON collection table. And as you can see in Oracle 26 AI, there is a new command now, create JSON collection table. And I add the syntax if not exists. So I call it coffee. And JSON collection table, it's a table with only one column. And this column is called data. Let's see it. Data, and of course, JSON data type. So let's generate the data. So I don't have to go to a Mongo database, export the data, move it. We don't have the time for that. I'm going to populate the JSON data. So the first one would be a bit more complex. I'm going to have a document with ID 1. It will be called espresso, and the fields are usually standard. I'll have price. Here, price is 5. Size is short, quantity 22, and I have coffee items. I have details. I have Italian espresso and I have Finnish espresso. And for every Italian espresso, I have a unit price, I have a code, so let's add this one to the collection. One row inserted. And the other ones, I'll do it in bulk. I'll create them all. I have one row for cappuccino, latte, mocha, americano, cortado, macchiato, Turkish coffee, iced coffee, dirty chai, decaf, Finlandia coffee. And every coffee has a price. You see the size and the quantity that we have. Let's insert those into the collection. So 11 more. 11 more. All right. Hopefully everything worked well. Insert. So let me show you something about those documents. Look at, for example, the Turkish coffee one. I have here one field called old price. Old price doesn't exist in the other one, so that's a exotic field. We call it an outlier. So this will be dumped into the flex fields. Also, I have here old price also for coffee Finlandia, as you can see. I have decaf coffee, row number 11. For the decaf coffee, I have a brand called Relax. This exists only here. The other ones, they don't have brands. So I'm deliberately creating some fields which are non-common. And now, let's try to, based on this collection, let's try to create an Oracle database. I want to show you how it works. That's the whole thing that you see, this POSQL block. I'm not going to run it. I'm going to eventually to run it, but I want to show you what it does. So you see here from declare until the end. I defined the schema SQL, which is this very big character string, which we're going to run with execute immediate at the end. We're going to use the new package and the new procedure called infer and generate schema. I have to list all the collections from Mongo that I'm going to convert into an Oracle database. Of course, for the sake of this example, I have only one, which is called coffee. I'm using flex fields because I have outliers. I want to play it safe. I would like to make the views updatable, so updatability is true. And I'm setting the frequency to 20. Default is 5, but I'm setting it to 20, just for the sake of this example. And the source schema is admin. Admin is the schema where I'm logged in. The user here is admin. You can print the script. You can, of course, change the script as you wish, but I'm going to run it at once. And at the very end, I'm running the import procedure. I'm importing from the coffee collection everything that we have already into the duality view called coffee duality. When you run this automatic procedure, for every collection, Oracle will create a duality view with the same name and underscore duality. So you know that those are the JSON views. Now I'm going to run it, and if everything works fine, I should get a POSQL procedure successfully completed. Yes, here it is. All right, very nice. But what happened? We don't know what happened. So Oracle created some stuff for us. So in order to see what Oracle created for us, let us select everything from user objects for the objects that were created in the last 1 hour, and I'm going to order them by the object type. So Oracle created several objects. We're just curious what Oracle created for us. Let's see. You can see we have the coffee duality view. This is a view. Oracle created the root table. This is the relational table that Oracle created based on the JSON document. Oracle created also a sequence. Oracle created several indexes. And probably the most interesting thing is to see what is that relational table that Oracle created for us, coffee root. Always they're called root because they're based on the JSON collections. So Oracle created a table which contains which fields? ID, date, item, size, price, quality, and the flex column. Let's see what this looks like. Let's select star from coffee root. This is the relational table. So here it is. You can see, starting from the right to the left, the flex data. The flex data is the coffee items for the coffee espresso in Finlandia. You can see the oat price for Turkish coffee, and you can see also for the decaf coffee brand Relax. So Oracle dumped those unrecognizable or outlier fields into the flex column. For the rest, Oracle created a column called ID, date, item, size, price, quantity. This is the relational table. Oracle created automatically based on the JSON document. Think if you have a MongoDB database, you want to migrate it to Oracle, how hard work manually would be to figure out what tables to create. Now, probably that's the last session of today, and you might be tired, but one question, why did Oracle create a column called item? It's called item. Price is called price, quantity is called quantity, but why is size called or dollar size, and why is date called or dollar date? Is this Misho? Okay, you know. Yes, that's the correct answer, yes, because they're reserved to works in Oracle. All right, so that's how it looks like. And if we go to, if imagine we are Mongo guys, we don't understand about Oracle, and we want to work with this Oracle database. Let me refresh. Now we have the coffee duality view here. You can see here we have the same document as a JSON document, but it's a view. And you can see here that we have for ID 1, we have the espresso. For 2, we have the cappuccino, and so on. If I click on this one, which will show us the same data in rows and columns, we can see that we have exactly the same stuff here. And if you are a Mongo guy and you don't know how to update the data, for example, if you want to update, for example, this price, you can directly edit from here. You can make it from 5, you can make it 6, and you can run an update. And you can continue working as a Mongo expert without caring how Oracle database works and how to run a SQL statement, how to write an update statement against an Oracle table. This can happen directly from the Mongo tools. So that's the bottom line of my presentation, that you can use now the Oracle database in dual form. You can use it as a document database, as a Mongo database, and you can use it as an Oracle database. Now let's do something else. Let's go back to SQL Developer, and for example, let me create, for example, another view, a JSON collection view, a read-only view called cheap coffee, where I would like to select all the coffees where price is less than 5. It's basically a simple command, create JSON collection view cheap coffee as select star from coffee duality from the duality view where price is less than 5. Here it is, created. Let's go back to SQL, to Mongo Compass. If I refresh, here is the cheap coffee collection. How many do I have? I have only 2 because I updated already one. I have the decaf and the Americano. You can create a view based on a duality view. Yes, you can. You just have to select the fields from the flex column. You can find out which yeah, exactly, yes. You can select, you can drill down and pick up fields from the flex column. That's a very good question, and that's important sometimes because this is a very simple example, but you might have a flex column with dozens of values. All right. What can I do? I would like also, for example, if you can insert directly data through the root table. If you're an Oracle expert, you don't know how to work with Mongo Compass, you can insert a document number 13 called Ristretto. Here it is, and I can add another field called color. We didn't have color until now, color dark. 1 row created. I can update through the duality view, and I can set the color to light for Coffee Finlandia. Or not Coffee Finlandia, it's number 3, I don't remember which one it was. So you can change the values. Let's commit. And let's see what happened. Let's go to coffee duality again. And we added a new row, number 13. You see, although we inserted the information directly into the root table, of course, that's a view. It automatically reflects the new Ristretto coffee. What else I can do? I can insert directly into the duality view, number 14. I can insert, for example, cafe cream. That's what German guys like to drink. And say, put some quantity, price 0. Well, 0, I don't know why 0, but 0. It works with 0. So here it is. And I can update also using the color for a coffee number 14, the one we just inserted. I can set color to unclear. Let's do that as well. And commit again. And let's go once more to Mongo Compass. Refresh. And see if number 14 exists here. Here is number 14, cafe cream, price 0, and color unclear. So you can basically do everything either from the duality views or from the Oracle tables. If you have a team of developers who are both with complementary skills, you don't have to anymore choose between a Mongo database or an Oracle database or between PostgreSQL database or DocumentDB. There is no issue with that. We have in yes, we have new Oracle functions and operators in Oracle 26AI. You can use those to extract the data. It's possible. There are functions and operators that do it.
Final question. You have everything created, but then you have new collections, which means the outliers that you had are no longer outliers.
Yes, then you might have to run again the same tool. Then, of course, it's up to the policy how the business application develops. So are you creating now the new applications directly from the...
Or you just have a new brand for coffee, like in your example. Maybe
Yeah.
the old ones were changed,
Yes.
now you have another 15.
Yes.
And this another 15 makes something that was flex column and not flex column.
Well,
So you have to reimport
understood. You have to re-import everything, or for example, you might decide at one point after half a year or 1 year that you probably don't want some flex columns fields to be any more flex column fields. You want them to be, yes, exactly. Yeah.
So you have some procedure now to run an update, or
You can rerun it once more. We have actually a customer in Canada who is doing it on daily, I don't know daily or by the weekly basis, but they're reinserting the data all the time from scratch. All right, and this is something interesting. There is also Golden Gate for Mongo migrations. We just announced it that it's a free tool for half a year, and that you can directly migrate. So basically, that was my presentation. I think that's the end. Summary, in the Oracle database, JSON documents and relational data can be within the same database. That's clear. Number two, that you can store, manage the relational data and the JSON documents in the Oracle database. You can do the same thing for them. Unified management, security, consistency, everything in one go. And the JSON to duality migrated the tool, that's number three, that it's a tool that automatically migrates documents stored such as MongoDB to Oracle, DocumentDB to Oracle. All right. You can try it for free, and I'm open to questions now.
Thank you for the wonderful lecture. I would just to ask if these commands from Mongo to Oracle database put many different rare parameters in this flex column, and I want a specific parameter to be in a separate column. How we make this? Let's say the old price. I want the old price or the trademark to be in a separate column by my wish.
Yes. There is the way that you can play with this parameter, which is called the frequency. You can set the frequency to 0, and then you can put every single outlier in a separate column.
But if I want a specific parameter like code price, no matter of the frequency.
But do you know in advance, keep the microphone please. So do you know in advance which this field would be, or?
Yes, I know in advance the name of the field.
Then in that case, I would not run the script in one go like I did. I would just look at the file, the script that it creates, because Oracle runs it automatically, and I would manually modify it. Some people may modify it manually.
And manually set the name of the column.
Yes, exactly, yes.
Thank you very
It's
much.
a manual work, but some people do it.
Thank you.
Yes, thank you.
Okay. A lot of questions, I guess.
That's good.
Sorry, how slow it is for mass update? If I want to insert a new property in every JSON and I have like 100 terabytes of table.
100 terabytes a
yeah,
table. The biggest I've seen is 90
different-
terabytes, but it's a big table, yes.
What difference should I expect compared to a normal column and mass update?
Well, same. But of course, in most of the cases nowadays, those autonomous databases they run on top of Exadata, so this is pretty fast. But if you would like to update a table with 100 terabytes, and I've seen a customer with 90 terabytes of data, that takes time. That can be very slow.
But it will not be slower than regular column.
No, but usually such big tables, they're partitioned. They're even sub-partitioned. And usually you'd only run the update in one partition.
Can we update the JSON, let's say, to be, you showed a new column like brand or something. If it's a complicated column like array or embedded address, let's say, with few fields inside embedded JSON, is it possible because the structure that you showed with additional tables that Oracle does internally, it should be changed because we need a new table, let's say, that we need to refer to?
Well, what Oracle does is based on an internal, let's say, AI algorithm, which cannot be changed. But once you know the script that is going to be run against the database to create those fields, you can do it on your own. But it wouldn't happen automatically.
So the migrator is just providing you with the script just
yes,
for easy start, and
yes,
you can
correct,
do whatever
yes.
you want after that.
Exactly,
if you don't
exactly,
like it.
exactly, yes.
But okay, with generated table already, migrated, whatever, I want to insert record, I don't know, 25, that has the address of the cafeteria, let's say.
Yes.
And the address is, street,
Yeah,
number.
the stuff, yes.
Yeah, so is it possible? What will happen?
If you have the flex column, yes. Otherwise, you get
flex,
an error message.
Yeah, in the flex, of course, in the flex.
Yes, yes, otherwise you get an error message.
And do we have opposite migration from Oracle to some kind of MongoDB, let's
Well,
say?
that's a question you should ask from somebody who works for MongoDB.
Ah, okay.
I work for Oracle.
You can't escape the Oracle, I guess.
Is there a maximum limit to nesting for
No,
dual?
no, there is no. Actually, that's a very good question, and probably this is the 5th time somebody is asking me this question, and there is no physical limit, but you hit the limit with performance at some point.
Do you know at what level is this?
I've tried to with 1,000 nested, and I didn't have an issue, but it's worth trying. I created a script that does 1,000 nests. But maybe if you do 10,000, 100,000, 1 million, I don't know, maybe you hit some performance issue first before you hit this limit. And I did ask development. I'm product manager. I asked development about this limit. They said that they have not put it in the code anywhere. So usually the answer we give is that there is no physical limit.
Okay, thank you.
Thank you.
Okay.
Okay, so thank you for the great presentation. One question, is the flex column JSON type?
Yes, it is, yes. It must be.
It must be, okay. Yes. Then, and then when we select only it out of a given table, would it appear again as only data name?
It will appear as a data. The column will appear as data only if it's a JSON view or if it's a JSON collection table. Otherwise, if you'd like to create a new table, you can choose whatever names for columns you want.
Okay, and one question about the colleague that answered asked is if we just insert another JSON data or another record that is over the threshold for a given field name, would it automatically become a column of the table instead of a
No,
flex?
it wouldn't become automatically.
It
wouldn't, no.
Okay, okay, thank you.
Okay, final question, because anyone? No final questions?
There is one more
there
here.
is final question.
My final question is, if I search a sequence of symbols, which in the JSON file is present in different fields, but I wanted to select it and to put it in one column in Oracle database. Is it possible, and how we do it?
Yeah, it is possible. We have an internal operator which is called JSON exists. JSON underscore exists. That's how you do it. JSON underscore exists.
Underscore exists. Okay,
Yes,
thank you very much.
that's the way how you do it.
Thank you once again.
All right, thank you very much for the attention. Yes.
And guys, do not leave the room. We will just proceed with the closing in a minute. So yeah, the coffee is over. The water, I believe, is also over. So unless you really want to visit the restroom or something.